to every member of the public who showed up, because so much of what we did this year was for you. And this is my chance to tell you that those cute little treats you had last night from Saucy, wouldn't have had them if we hadn't had sponsors. The cool swag bags, sponsors. This room, sponsors. The tech crew, sponsors. So if there are folks who are in the room from our sponsors who can stand up, that'd be so cool. So Lake County Watershed Protection District, Flood Control and Water Conservation District, West Side Sacramento Integrated Regional Water Management Plan. Ex-Ordo is not here. They're in Ireland. Folks, Ex-Ordo is amazing. It's such a cool conference platform, and they gave us a discount that I cannot disclose. But let's just say that when I go over to Ireland, I'm taking the entire office out to dinner. Lake County Lake Air Adventures, Utrofix. Anyone from Utrofix here? Yeah, thank you. Check out their booth. It's quite awesome. Museums of Lake County, California, and they had an amazing booth last night where you could make little borax things. California Natural Resources Agency, looking at you, Geneva. Yep. Lake County Vector Control District. Anybody from there? Yes, thank you. AES. Anyway, they did a fabulous job coordinating things yesterday. And then, of course, we have Habamatolel Tribe and the Robinson Rancheria, Pomo Indian Rancheria Colony Band. Anyone here from Robinson Rancheria? Well, we're in their casino. And then the Alliance of Indigenous Math Circles. I don't know if you got a chance to meet with their representative yesterday. She tabled at the poster session and came up here specifically from Santa Rosa to be with us. And if anyone knows anything about Pomo basketry, high-level math. So, does anyone need instructions to where the restrooms are? Right out the door. In case of emergency, should we have an evacuation order or a medical emergency, please come directly to myself and Angela. We will be closing down the symposium and making sure that everyone evacuates in an orderly fashion. And something that I'm going to ask our presenters is eat the mic. Eat the mic. Because if you eat the mic, then everybody can hear you. If you do this, or if you do this, can't hear me, huh? And for our participants, if you can't hear, please do this. Because what that means is you can't hear. And if you can't hear, the people online can't hear. And the folks from PEG TV and Sam from the county who are working so very hard to make sure that everything works and they're recalibrating our mics every time, you'll just make their job easier too. Okay, the amazing Angela, are you ready? Okay, here we go.
I wanted to just give a moment for one of our largest sponsors from County of Lake. So Supervisor Michael Green, you have 1 minute.
I have less than 1 minute. I'm just grabbing this. I want to thank all the sponsors here, but I do also want to point out for those in the audience, Lake County is a cannabis regulating county, and we have both local regulations and local taxes. $10,000 toward this conference came from discretionary cannabis tax revenues. So I understand many people have concerns about cannabis in the illicit space. Plenty of people still have concerns about the legal space, but cannabis brought me here, and cannabis brought a big chunk of this conference here. And so I hope as you talk about all things that are impacting Clearlake, including things like illicit cannabis cultivation, that you also take a moment and say, this is what Lake County is doing with its legal marketplace and putting to good use its cannabis tax revenues. Thank you.
I just want to remind folks that we do have concurrent sessions. So in the afternoon, the meeting will be split up into 2 locations. some morning, afternoon sessions here. And then if you look on your schedule, which I'll show in 1 second, the other location is at Habimatal Meeting Hall, Upper Lake. And there are some parking areas. There's a back lot here behind the building. You can park on Main Street, but it might be full. And then there's a paved dirt lot here. So just make sure to give yourself enough time. We'll give you a little 5-minute, 10-minute grace period before you start the sessions, but just a reminder on the logistics for that. And then if anybody who came to the poster session last night, woo, was it awesome or what? It was so good. Let's give a big round of applause for all the poster presenters. These photos are a little blurry, but we have on our @Clearlake CA Science Facebook page a bunch of photos from last night. And we also encourage any other people that took photos to please share them with that Facebook group. We had about 13 posters, and it was awesome. So thank you so much for everybody for participating, coming to visit, and learning about all the additional projects. And then this evening, we do have the Big Lake Big Science film that'll be at Sopa Reese. And this is the general map, how to get there. I did want to let you all know that there is construction, of course, today on Martin Street and Forbes. So make sure to get there early. If you have to, park in an adjacent parking lot and then walk to the theater. They didn't put any signs on exactly what they're doing and where, so give yourself a little grace period to get there. Who is registered and going to the film tonight? All right, I am so excited. So thank you so much, and yeah, just be aware of that as you drive over there. And again, these are all the agencies that participated in this event, and we are so grateful and thankful for coming together and be able to share all the information that we're learning about Clearlake. If you need any more information, you can go to our website, and it is being live streamed right now. I just checked it on my phone, so yes, it looks good. Thank you to our tech guys, Sam and Thomas, this morning. And the links are going to be there on our website right here. So you guys know the afternoon sessions that are held at Habimatal Meeting Hall have a webinar, and so that link is here. And that is going to be recorded. That'll be on our YouTube page, but just so you know, it's not the county YouTube live for the afternoon sessions at Habimatal, it's a Zoom webinar. And then a reminder, too, that we have proceedings that will be for sale, so capture the science memories forever in a book of your own. You can purchase it for print. We're going to print a certain number, and you can purchase that now for $20, but it'll always be available digitally for download or viewing on our website. After the symposium ends, we're going to put everything together, all the presentations, abstracts, and information, and all of that will be in a nice little package digitally for us to access and use forever going forward. So these schedules, this is the general schedule, easier to read a little bit, right? We do have copies of these on the tables for you guys, but this is day 2. So right now, in a few minutes, we'll have the fish and aquatic fauna wildlife session, and then we'll have the invasive species and Clearlake session. These will both be right here. And then we'll split after lunch, and in this room will be the geology, geysers, and groundwater, really cool session. And then after that will be 2 back-to-back sessions for Clearlake Hitch status and conservation. At Habimatal, we'll do a education workshop, and we'll actually get together and talk to each other and talk about education. We're really excited about that. And then we have lake restoration projects in Habimatal after that session, and then we'll finish up with the in-lake mitigation. So I work for County of Lake Water Resources, and I always get phone calls. What are you guys doing about the harmful algal blooms in the lake? What are you doing about the blooms? This session has a lot of the technologies and what we're proposing to do, some projects that are going forward, some projects that have been approved, waiting for funding. So that is a really great session if you're interested to learn about what's being done in the lake and what's going to be done for in-lake restoration projects. And then the Sopa Reese Theater. So the doors will open at 6, and the film will start at 7, and there will be some concessions being sold with proceeds going to Sopa Reese. So that's the way that we're helping out local theater and arts. And then all of the details are in the itty-bitty tiny font schedule that is also still available out there. And I just wanted to take a moment because we're going to have back-to-back sessions, and we're going to have breaks, and then we're going to split up, and I might not see some of you the rest of the day. And I just want to take a moment and just really thank you for being here, and thank you for bringing science into your lives for So as scientists, as researchers, we work for the public, we work for the common good. So keep pushing us. You guys are the public. You need to make sure that we're accountable and we're following through. So if we do a science project and we say, this is what we think needs to be done, push us to keep pushing the envelope and figuring out what needs to be done and then getting those things done. Because we want to keep the system in Clearlake for the future generations. So I just wanted to say I'm very grateful. Thank you guys for being here, and thank you for sharing in all the science with us. Okay, so now we will get started with our morning session. Really cool. I have lots. If you wanted to come here for all the wildlife photos and the fish photos, this is going to be the session for you. So let's go ahead and switch the PowerPoint. And I will introduce our moderator. It's Donna Makowicz. She's with the Redbud Audubon Society. And if you've ever worked with Donna, she is just a spark plug of excitement. And I'm going to be honest, and Donna knows this, but I'm not a bird person. And when she heard that, but Donna has really opened my eyes. And I have a son, and he loves birds. So now I'm going to love birds. But I'm just really excited for this session, and we have several bird talks. And yeah, there we go. So I'll hand it over to Donna as the moderator. Do you want to use this one? Okay, great. And then this is
Good morning, everyone. Can you hear me? Okay. I'd like to welcome everyone, and I just want to tell you a little bit about Redbud Audubon Society. We're a 501c3, and way back in 1974, a group of conservation-minded citizens, some of who are in the audience here, got together and started our chapter. And Audubon's mission is to conserve and restore natural ecosystems, focusing on birds, other wildlife, and their habitats for the benefit of humanity. We have monthly Zoom meetings. We do field trips. We have lots of citizen science projects. One that we've been doing for almost 50 years is the Christmas bird count. So we have lots of data through the years. And everyone is welcome for our Zooms. And right now I'd like to introduce a couple of projects that we've been working on. I'll go right into introducing a really awesome man. Dr. Scott Butterfield is the Clark Professor of Conservation Technology at Pacific Union College in Angwin. He holds a PhD from Michigan State University, where he developed and tested conservation technologies for rangeland management and evaluated the usage by ranchers and range management professionals. Dr. Butterfield is also the lead scientist for the California chapter of the Nature Conservancy. And with that, I'd like to welcome Scott.
Sounds good. Well, thank you guys for having me here today. Yesterday was really exciting. Obviously, we're going to talk about a project that has just recently been approved by the Blue Ribbon Committee. It's not yet a project that is happening, so I'm going to talk a lot about just the concept and the vision of the project itself, as opposed to actual results. But it's a really, really exciting project done in collaboration with a variety of local partners here, including Lower Lake High School, Upper Lake High School, Robinson Rancheria, and Big Valley Pomo Indians, as well as Redbud Audubon Society. So the work is monitoring grebes as a bioindicator of Clearlake ecosystem health using drone technologies and student-driven education and outreach. I know that is a mouthful. So the goals of our project and sort of the timing is a little fluid depending on when the actual funds come, but the idea here is to use grebes as a bioindicator of overall health at Clearlake, and to develop a monitoring program in collaboration with the local high schools and with local tribal educational groups that lives beyond the time period of the actual project itself. All grebe work at Clearlake to date has been done sort of in an old school way, which is fine, you know, getting out on the lake, riding a So why drones, artificial intelligence, and local citizen science? Well, like I said, I'm a professor of conservation technology. I'm a conservation biologist. I'm always thinking about how we can take these cool new technologies that are being developed all the time for a range of different things and think about how we can put those in the hands of local community members, high school students, college students, anyone, and make things easier, cheaper, and more sustainable over time. So like I said, most of the grebe work that has happened over time has happened by putting a canoe in the lake, having to row that canoe out to each individual grebe colony or each nest and count those nests over time. So what we're hoping to do with these drones, and this is just one example, these are not grebes themselves, but the idea holds in that you can use artificial intelligence-based algorithms to not only fly that drone in a consistent way across all 37 of the colony sites that exist here at Clearlake for grebes, but then you can use that AI, that machine learning, to basically train an algorithm to pull information out of those videos, out of those photos that will actually count those nests and count those individual grebes for you. Obviously, a really, really big driver of this project is that we don't just want this to be a project like on the technical end of things as a conservation technologist, it's not that hard to get a drone out there and count the individual drones. But as I am guessing, if you have had high school students or work in high schools, training high school students to fly those drones and count those grebes over time might be a little bit more challenging. So that is the really cool part about this project is working with these local high school students and training our future conservation technologists. And if you were in the poster session last night, our poster really emphasized this, right? I had a lot of people that came up to me, first of all, and said, what the heck is Pacific Union College? Where is Pacific Union College? What is conservation technologist? And I had a number of parents ask me, like, what kind of job would my student be able to get? So one of the really cool parts about this project, I think, is shining a bigger light not only on Clearlake and on grebes, but thinking about what conservation technology is, how we can apply conservation technology over time, and how this is a really growing field with jobs for kids after high school and college. So a little bit on what this will look like. I've already talked a little bit about this, but there are 37 colony sites, and this is from Floyd Hayes did a review of all grebe monitoring at Clearlake that was published in 2022, and I'm happy to share that if folks are interested. Across that 5-year time period, 4 times a month in the breeding season from May to September, we're going to go out with a variety of different partners. This is going to be a relatively flexible thing as we start to work with our high school partners, our tribal environmental center partners, and also our college students, in that this could take the form of things like developing curriculum and putting that into the local high schools. It could be after school programs, it could be nature days, internships, etc. But at the very least, 4 times a month in the breeding season, we'll put those drones out, we'll count individual grebes in the grebe nests. We'll bring those videos back, and then again, across that 5-year time period, we're going to be developing and testing artificial intelligence or machine learning-based processes that hopefully, at the end of the project, will allow us to not only leave those drones in those local high schools that we've already trained up to actually fly the drones and count the drones, but those algorithms are there, which will allow those students in a really easy way to learn about things like coding, write really simple code, pull out that this this particular project, we have a forest at Pacific Union College, 1,000-acre plus forest, where there's been a lot of forest management done over the past couple years in response to and hopefully preventing a major fire from coming through the college. But in response to that forest management, we've set up about 40, 50 wildlife cameras across the whole forest, and we're using those wildlife cameras to, for example, track the impact of that forest management on things like mountain lions and deer and bobcats and black bear. So in that particular program, just like we're proposing here with the Lake County high schools, we show those students how to put the wildlife cameras up, how to get that information off, how to develop really simple coding methods to process. And when I'm talking like a huge amount of data, these wildlife cameras, 40 cameras set up for a couple years across the forest, you're talking hundreds of thousands, if not millions of images. Now, I made all those students individually have to go through and sort of tag some things just to make them feel the weight of what science is. I don't want to just give them the easy way out. And one of those students was my daughter. And at one point in the process, she's like, there's no way we're going to be able to figure this out. And I was like, well, just keep going. She's like, but it took me all of Saturday to go through this. And right at the end, when they were worrying about being able to complete their project, I showed them that I wrote this very simple code which pulled all this information out. So in this particular project, it was a mountain lion counting thing. And in what had taken them multiple weeks of going through, in about 5 minutes, it went through all 500,000 images and pulled those lions out. So it was a fun moment for me as a parent to watch them crumble. So anyways, I think it's an important part of, as Angela was talking about the importance of science, it's important that I think students understand how hard science can be sometimes. And as a conservation technologist, then to think about how we can apply some of these technologies in a responsible way to potentially make that science a little simpler and more transparent. So, anticipated results, unlike most of the talks today where folks are going to talk about the exciting results that have happened, ours are anticipated and what we're looking at. But at the very basic level of what we will deliver on at the end of the project, we'll have a 5-year bioindicator analysis. So looking at what grebe numbers, grebe nests look like, and how those grebe numbers track with a variety of other ecosystem metrics. We will have built in a sustainable way into our local communities, into our local high schools, a monitoring program that lives on after this grant. That's a really, really important part of this work for me, is I don't want this to just happen across 5 years. We give the data out, and that's it. I'm very serious about developing a program where the physical drones live at these high schools, the monitoring program lives at the high schools, and that it lives on as part of these curriculum. Our goal is to, across the 5-year time period, to train 200 student, teacher, tribal, and conservation collaborators. So 200 local Clearlake students and teachers and interested public to be able to go forth and carry on this monitoring program in the future. And again, a really important part of this work for Pacific Union College and me is
We will take a couple questions.
Hi, thank you for all the good work.
Yeah, thank you.
You know, you talked about why grebes, but I would like to hear about why grebes versus blue herons, osprey, green night herons, all those other species. Why specifically did you focus on the grebe?
Well, one, we focused on the grebes because there is a really long-term data set on grebes, which we can leverage, so we can look across grebes across, there's been monitoring data collected sporadically on grebes for 70 years, so our work then can plug it into that and understand what those long-term trends are. From a conservation technology standpoint, the drones have been shown with grebes to be, the grebe nests and the grebes themselves are large enough that we can actually count them on the lake. So that would be another thing. So some of those other bird species, the drone-based technologies are unproven. So what we're trying to do here is maybe not demonstrate this kind of crazy new technology, but we really want to go with something that's a little bit more proven so that we can work with the local high schools on it. Good question, though.
We'll take one more question. No. Are you sure? This is your time.
This is your chance.
Okay, I'm curious why the red dots in that map that was mostly black dots. And one of the things I notice is it's on Middle Creek at Rodman Slough, and I see fishermen taking their boats into that area when it seems to me they should probably be staying out of it. And I'm wondering if the county has thought about actually making that a boat-free area for the birds.
Yeah.
That's a very good question, and Water Resources did supply us with buoys, and we have little signs saying grebe nesting, no wake zone, and we can only just hope that a fisherman or a jet skier will stay out of the areas during nesting. And again, it's just hard to police. It doesn't work very good. I've seen nests just get destroyed by one jet ski coming through the nesting area. So it's just lake life, I guess. Okay. And one more question, I believe?
Yeah, I want to take some more questions. This is the time to ask the science, so
Okay.
yeah.
Thank you so much for your presentation. I just have a quick question about the graph that you showed. You talked about the 1950s and the chemical applications and the impact on grebes, but I'm curious about any data that came before that time. Like, what was the grebe population, and is there a sort of a target that you're hoping to see, or have we exceeded that target? Or I'm just curious if you have any of that information.
Yeah, I mean, as far as actual grebe data on Clearlake, this is kind of what we have to go from. It's nowhere near capacity, I think is the biggest take home, even though we have seen levels, up to 6,000 nests at time periods, in the mid 2015s. We're nowhere near capacity as far as that goes.
Did we have one more question back here? Okay. Oh, okay. I knew I saw someone.
Hi, I have a couple questions about the drone program. So I'm aware that the aeronautical rules as put forward by the FAA for unmanned drone and pilot licenses, they're really strict. Are the high school students being trained in those rules, and are they going to be provided with opportunities to take the Part 107 exam so that they can put these skills towards more research in the future?
Yes, so it's a great question. So we will be, obviously having a permit as part of this. I will be sort of the certified drone pilot at the start, and then I didn't get into it, but probably not all of the individual students will go through that process of getting a drone permit and becoming those drone pilots, but there will be specific students through internships, capstone projects. We're trying to create this as flexible as possible, so that if we do get some students that are really excited about it, that there are those potential avenues for participation.
And there was another question over here. Oh.
I'm a photographer and I live on the lake, and I've also did not have the several hundred grebes that we normally have breeding in our area. They've always been there for the last 15 years, and the last 2 years there's been very few in our area. But the concern is, why are they coming on shore? They've never done that before.
Yeah, I mean, it could be just what you were saying. I mean, the habitat for them out in the lake right now might not be suitable, so they're trying to find other, potential ways to, find habitat and live. I mean, it's we've heard a lot of stories this year that grebe numbers are lower, and that where people have seen, grebes in the past are not there this year. So this would be a great year to have this project started, but it hasn't yet. So yeah.
Okay, thank you. Can I just add to you guys that thanks to a funding source from U.S. Fish and Wildlife Service, there's going to be new grebe signs going out around all the public areas. So I'm sure you guys, if you've been to any public spots, you've seen the big signs that say, for boaters, beware, grebes are nesting in this area. And they've kind of faded, and Red-Billed Audubon Society and U.S. Fish and Wildlife Service paired up and got new signs, and they are going out as we speak.
And
Roberta, do you have a question?
Roberta?
Okay, I'll get one more for Roberta. Only you, Roberta.
So when you talk about bioindicators, are you going to base that on their breeding success? And my other question was, are you going to be also looking at things like the forage that's available in the lake? Because when we had a lot of threadfin shad in the lake, there was a huge population of the grebes. And so I'm wondering if you're going to try to tie that into with your studies.
Yes, so I'll address that first one. I mean, we're basically going to be counting the individual nests and the individual grebes themselves. So those numbers will be the numbers we'll use, as the bio indicator of overall health. And again, like our particular project is just focused on that, but we're hopeful that by making the data available, if others are taking other data, we're open for evaluating how those grebe numbers look against a variety of other sorts of things across the lake. Great. Thank you, guys.
And I'll add on to Roberta's question. In 2010, we started monitoring grebes. Red-Billed Audubon Society did, and Floyd Hayes took the lead on that. And one of the things that he did was he only counted the nests. So something we could expand on is success rate, and do they do successive nesting afterwards, like other herons and cormorants do. But we just counted just the nests, not the success of them. And on your question about photography and seeing the grebes, it's really hard for a grebe to be on land because of their body. Their legs are so far back, it's really hard for them to walk, although they can. So that's really interesting to know that they were actively on land. In the Clearlake Oaks wetlands, our nests were abandoned, and I don't know why. I assume probably lack of food, but we had 14 nests directly in that I was monitoring, and they were there one day, and then the next day they're gone. So lots to learn about. And should I go to the next? Okay. Our next presentation is the long-term variation breeding, populations of cormorants and herons at Clearlake, and it was written by Floyd Hayes with Brian McIntosh and Doug Wiederman. Brad Barnwell and myself contributed as a part of the science, and Floyd couldn't be here today, so I will try to do my best. He's an awesome speaker, and he was the one that did our grebe monitoring. Clearlake and adjacent wetlands are severely impaired with a long history of human activity, including contamination of mercury from the nearby mine, invasive species of aquatic plants and fishes, applications of pesticides and herbicides to control the pests, loss of wetlands due to modification and reclamation of agriculture, and cultural eutrophication from excessive nutrient loading. In 1949, 54, and 57, massive amounts of the organochlorine pesticide DDT were dumped in the lake in an attempt to control aquatic larvae of Clearlake gnat. Shortly after the second and third applications, large numbers of dead western and Clark's grebes were found along the shoreline. Subsequent studies revealed elevated concentrations of DDT in the tissues of several fishes, frogs, and the peciferous grebes, providing the first documented instance of biomagnification in which toxic chemicals accumulated in increasingly high numbers from lower to higher trophic level organisms. Although the devastating effects of DDT on Clearlake's grebes are well documented, resulting in mass mortality of adults and cessation of breeding followed by a gradual, multi-decadal recovery of their breeding populations, little is known regarding the impact of DDT on other birds, including cormorants and herons. No information is available on DDT populations of colonial breeding herons. Double-crested cormorants are colonial water birds that seek aquatic bodies big enough to support their mostly fish diet. They're known to fly up to 40 miles to a feeding area. They tend to form breeding colonies in clusters in trees or near water. Given the potential threats of habitat loss, water diversion, introduced species, bioaccumulation, and biomagnification of toxic chemicals, climate change, and other threats to water birds, monitoring their populations and habitats is crucial for evaluating their conservation status, detecting long-term population trends, assessing habitat quality, and documenting the effects of environmental changes. The management practices on water birds is also discussed in the paper. Floyd summarizes the long-term variations in breeding populations of cormorants and herons at Clearlake based on data previously published in surveys from 93 to 99 and surveys 2006 to 24. He discusses the potential causes of variation and provides suggestions for future grebe monitoring. Great blue herons mostly breed colonies located within 2 to 4 miles of their feeding areas. Clearlake is formed of 3 major arms, and these major wetlands along there occur in large tributaries at the northwest end of the lake, Middle Creek and Rodman Slough area, and at the outlet at the southeast end of the lake, Anderson Marsh and Cass Creek, and in many shallow areas along the margins of the lake, especially at the mouths of the tributaries. Riparian forests dominated by willow, valley oak, Fremont cottonwood, and California sycamore occur along the shores and tributaries and portions of the lake, providing nesting habitat for cormorants and herons. Urban development occurs along the shore in several areas along the lake, but not in Rodman Slough, Anderson Marsh, and most of Cass Creek. Recreational boating and fishing are extremely popular, with dozens of hundreds of watercraft on the lake during fair weather. In our Christmas bird counts in 1997, we reported 62 great blue herons, and in 2023, we only had 32 birds, so it's a decrease of almost 50%. The great egret eats mainly small fish, but also eats amphibians, reptiles, birds, small mammals, and invertebrates. It hunts in belly deep or shallower water, alone or in groups. And we know Lake County's precipitation occurs mostly during October to May, and rarely June to September, with the water level typically highest in February to April, declining in summer and lowest in October to December. Water level at Lakeport, the west shore of the upper arm, during our study period of 2006 to 24 varied dramatically, ranging from 10.58 Rumsey in 2017 to negative 2.74 Rumsey in 22, well within the historical extremes. Black-crowned night herons can be found in Lake County all year, with highest numbers during summer breeding. They require aquatic habitat for foraging and terrestrial vegetation for cover. Our Christmas bird count in 1997, we had 32 black-crowned night herons, and then this past year, only 9. So again, it shows a decrease. Like black-crowned night herons, the smaller green heron also uses tools to fish. They're a very secretive bird, and during nesting, they're very hard to detect. In the Clearlake Oak Keys, breeding pairs were first observed in 2023 and in 2024, And we had 3 successful nests observed in the same location. And this is actually right next to my house. And this year we had 2 pairs, and they both nested twice. So we had 5, 10, 14 chicks hatched and fledged successfully. And previous research. In 1895, not 1995, there was a colony of 100 double-crested cormorants at Reeves Point. And it's a quote that he said it was an immense colony of double-crested cormorants, half a mile across the Narrows. So there were larger populations back then. Rood in 1965 documented the demise of Clearlake's breeding grebes after the applications of DDD in 49, 54, and 57. The populations of egrets and herons are also lower than in former years. And then Wolf and Norman said in 1993 they did their first comprehensive studies in multiple breeding colonies, up to 210 nests of double-crested cormorants, then up to 286 of great blue herons. No nesting great egrets were reported, and we're not sure if they just decided not to count them or they were not there. And only 3 nesting black-crowned night herons were reported. And then Schuford in 2010 said that in 1995 to 2000, the breeding surveys of double-crested cormorants were up to 375 nests of double-crested cormorants. The methods used. In 2006 through 24, when Floyd was doing the grebe survey, he documented all his heron sightings and cormorants. They searched for colonies from canoe, motorboat, or land, and I believe he said he did like 10,000 miles during that paddle time. They counted or estimated the number of nests at each colony. There were inconsistent sampling with more sampling done during other years. And a lot of that was because of water level. The statistical analysis, they compared years with large colonies sampled at Rodman Slough, the Upper Arm, and Cache Creek, and simple linear regressions were used to test the number of grebes versus year, number of nests versus water level on March 15, which is early in the breeding season. And the results? We had 9 colony sites, 2 in Rodman Slough, 6 in the Upper Arm, 1 in the Oaks Arm, 1 in Cache Creek, and there was considerable annual fluctuations in the colony sites. And here it lists all the sites that we monitor consistently. And then Rodman Slough. 2 colony sites, Long Tule Point and Cache Creek, were active each year, surveyed for 14 years, and 1 site at Quercus Point was active each year for 10 years. And then there were 10 colony sites abandoned without being reused in the study period. Upper Rodman Slough was active each year from 2011 to 2019, but no nests were found during the surveys of 23 and 24, which was very unusual. And Lower Rodman Slough, it was active each year during 2011 to 2014, but not during 2016 to 19 or 2024. 2 colony sites, Willow Point and Reeves Point, were intermittently active and inactive. The Lions Creek colony site was first detected in 2024, and Kelsey Creek colony site was first colonized by a single pair of great blue herons in 2021 in an area that was frequented by birders and hadn't been seen in the previous 20 years. And then nests at Clearlake Oaks wetlands were first detected in 2020, but may have been previously overlooked, and we have someone directly across that said they were there since 2017 that you know of. And again, it's just, we need citizen scientists, just let us know if you see a colony, just send us an email. Rodman Slough. And then, despite inconsistencies in our survey of breeding cormorants and herons, such as that not all colony sites were surveyed annually, the surveys occurred at different stages of the breeding season, and more than 1 survey in a breeding season for each colony site. Our data revealed several fluctuations in the presence and number of nests in each of the species at the colony sites, and 2 long-term trends. The higher number of double-crested cormorant and great that varies greatly over time, the environmental drivers of these trends is difficult to identify. Because breeding population surveys of cormorants of herons didn't begin until more than 4 decades after the applications of DDD on Clearlake, the immediate and long-term effects of DDD are unknown, although DDD concentrations in feathers, tissues, and eggs of Clearlake grebes steadily declined in the 1960s and 1970s. No such studies were conducted on the lake's cormorants and herons until 93-94, with much lower and sublethal concentrations of DDD and DDE were resulted from the breakdown of DDT were found in the tissues of double-crested cormorants and gray blue herons. These studies revealed a gradual decline in the lake's pesticides, which clearly didn't contribute to the recent declines of the double-crested cormorant and the great blue heron since 1993. So there's no significant relationship between the number of nests and the water level. And because breeding population surveys of cormorants and herons didn't begin until more than 4 decades after the last application, I think I'm supposed to be on the next slide. Yep, okay, sorry. The black-crowned night herons nested at 5 colony sites with a maximum count of a single site sample of 102 nests at Willow Point in 2016, and a maximum annual count for the lake of 109 nests at 2 sites in 2024. Wolf and Norman reported only 3 nests at Corcus Point in 93-94, and then we never have detected nesting there. The species was the only heron nesting at Willow Point, where 32 out of 104 nests, 32 to 104 nests were tallied annually between 2009 and 2016, mostly at Library Park, with smaller numbers within the 3 city blocks to the west. And in 2017 to 2019, which most of you will remember, that's when the loudspeakers with the cries of raptors and herons in distress were broadcast from the loudspeakers in the trees at Library Park in an effort to discourage herons from nesting. The colony site was not surveyed during 20 to 23, but 95 nests were counted in 2024, and only one of those was in Library Park. The others were about 150 meters to the south in a campground. There was no significant trend in the number of nests over time from 2009 to 24, although the counts revealed the highest numbers in May and June. 95 nests were tallied at Willow Point in March, and there was no significant relationship between the number of nests and the water level. Mercury contamination may have also adversely impacted the cormorants and herons. Mercury was intermittently mined, and the open pit mining began in 1927. Elevated but sublethal mercury concentrations were found in the tissues of the cormorants. But right now, mercury is presumably declining in the lake's cormorants and herons, and it's unlikely to have contributed to the decline of their breeding populations since 1993. These are young green herons that I took from my backyard. Habitat loss may reduce the carrying capacity of breeding cormorants and herons. An estimated 85% of Clear Lake's natural wetlands have been destroyed. Cormorants and herons depend on the tall, broadleaf trees for nesting, but no loss of trees has occurred at any of the 10 colonies, so habitat loss is unlikely to have contributed to the recent declines of all the species since 1993. And this is the graph that he put together, and it shows beginning with the double-crested cormorants, their numbers, the highest was 400, and then in 2025, we had less than 100. And then great blue herons, the high counts were almost 300. In 2005, we're down to below 100. Same with great egrets. They weren't counted previously. We had high counts of up to 30 nests, and then this year under 5. And black-crowned night herons, our high counts were up to the 100. And again, this year, because I think we've noticed new rookeries, it was 100. But in 2010, it was between right around 30. populations of double-crested cormorant and great blue heron appear to be declining. No significant trend in breeding populations of great egret and black-crowned night herons, but fewer data, and no significant relationship with water level for any species. There's no known causal factor for the decline in breeding double-crested cormorant and great blue heron, but possibly due to population fluctuations of prey. Future monitoring is needed to document the trends in breeding populations and environmental drivers of change. As I mentioned earlier, Redbud Audubon does a Christmas bird count, usually the third weekend in December. And these are just a few of our facts from 1997. If we looked at great blue herons, we had 62, and then great blue herons last year, 32. And some of the other ones I just threw in there for you were western grebes in 97 was 1,844, and 2023 is 219. And we have dedicated citizens monitoring the same area in a 24-hour period. And this is just an example of the numbers decrease. Our mallards went from 711 to 424, and the citizens actually do count every single species we see. And this is Floyd Hayes, who should be here instead of me, but he's out of the country, or I think he just arrived back now. And here's his contact information if you'd like to reach him. And we followed all applicable ethical guidelines for the use of birds in research, including those presented in the Ornithological Council's guidelines to use of wild birds in research. And funding was provided directly by a Herber Family Faculty Development Grant and the Margaret Hughes Faculty Research Fund of Pacific Union College, and indirectly by Audubon California, Luckenbach Trustee Council, National Audubon Society, National Fish and Wildlife Foundation, National Oceanic and Atmospheric Administration, Redbud Audubon, and Rhodes Scholar. And for assistance with field work, we'd like to thank Kathy Barnwell, Brett Hayes, Marta Hayes, and Dylan Turner. And that is Floyd's presentation. I don't think we have time for questions.
Did you want to take a question while we set up the next presentation?
I'll be here all day. And our and Candace?
Yeah. Where's Willow Point on the lake?
That's a good question. Can someone help me?
Willow Point, is that the campground south
Yes,
of Lakeport?
yeah. Well, you can walk to it, I think, actually, from Library Park.
Yeah, it's the outflow of Forbes Creek comes out in the middle of Willows Point. It's next to the old TNT building and Disney's boat rental.
I only know everything from the creek. It's like, oh, there's a rookery. Oh, there's one. I don't know the other parts. I'd like to introduce to you Candace Reynolds from HANA. And without her and Christy Vittorio and Christine Snyder, who stepped out, this next project wouldn't have been around. So it's my great pleasure to introduce Candace.
Can everyone hear me okay? Cool. So I know, in order to kind of stay on time, I'll try to, keep this conversation high level. We have a table, HANA Resources has a table just outside of this back door here. I'm happy to talk about this project in greater depth beyond this too, if we don't have time for questions. And I'll be here all day today, so you can pick my brain, and I'd love to hear what everyone has to say. So, yes. Okay, thank you. So my name is Candace Reynolds. I work for HANA Resources. So HANA Resources is an environmental consulting firm, and their office is actually based down in Lake Forest, California, which is southern Orange County. I work virtual, so I think I physically have been into the office maybe 2 or 3 times in the time that I work there. I actually reside up in Humboldt County. I live in McKinleyville, California. So where do you live? places that I've driven by. Now we've looked on maps and identified, and it feels personal. And so really taking ownership of all the work that we're trying to do here. So I didn't tell you my title there at HANA Resources. I'm a restoration ecologist, also a grants program coordinator. And so how we ended up coming into really this environment was to help facilitate this work. This was not an idea that we created. I didn't meet Christine and Chris and initially until this project had already been started. So it's just been really great to get to know them better, and we have an amazing team, and I've gotten to know a lot of people. Yesterday we were talking nonstop about this project, and I can't wait to hear more. We want to hear what you have to say, and we want to learn as much as possible to make this project successful for the community. So let's see. Okay, and from a range of verbal support to letters of support, this is kind of just the beginning of the folks that are hearing our project concept and are on board and excited about what's to come. I know that there's a lot of work to do, and this is the list. And if you are not on this list and you want to be a part of this, please come talk to me, whether that's verbal support or if you want to provide a letter of support and really tell me how you think that you could support this project. I want to hear about it, because the more support, if we just have unanimous community support, it's just going to make this project irresistible to funders, because this whole thing is going to be grant funded. That's our plan. You ever take match and other community support, but it's just really important. And I really want to make sure to call out, if those of you who I call out, if you could just raise your hand or stand up. I just really want to recognize the project partners. Chris from Pinecrest Research Corporation, yeah, you can wave there. Christine Schneider of Native Sage Consulting. Donna Makowitz, who we all know now very well, Redbud Audubon, myself, and our Director of Operations, Sloan Sanchez, can't be here today, but she's also a very big player here. And I have a few names from the Lake County Land Trust, Roberta, Valerie, and Mary Jo, but really to the whole Lake County Land Trust. So if some of you are here, if you could raise your hand too. Yes, we're just so happy to be working with all of you. It's just been a pleasure. So I just want to give you, again, this is a high-level overview, but I want to kind of give you a little bit of background, talk about some of the larger project goals, project development, and then through the project development, we have the project broken it down into 4 phases. So we have the phase 1, land acquisition, phase 2, planning, phase 3, habitat restoration, and phase 4, rehabilitation. So the project area is focused in Clearlake Oaks. How do you do, if you want to do the laser, how do you do that? Can you do that? Is that possible? If not, I use my hands a lot, and so, but I'll talk it out. So in the area that's circled, Clearlake Oaks, and I had learned, and I know people are talking about that this is the oldest, lake in North America. I think it's almost 500,000 years old, and it just, even more. Well, there you go. What is it? Well, I saw 2.5 million since the lakes were, it's come and gone, but 500,000 years it's been a persistent lake. Yeah, something like that. It's mind-blowing. And so it just makes it so important to conserve this resource. I mean, it's so necessary, and there's so many people here doing really great work in that direction. So the 3 projects that, there's 3 main projects we're focusing on. So this is the project area here on the map. So the Clearlake Keys Rehabilitation Project, that focus area is the outline in yellow. The Schindler Creek Habitat Restoration Project, that is the filled red area that runs through the Clearlake Keys and up into High Valley. And then the Shannon Wetlands Habitat Restoration Project is the purple dotted wetland area just east of the Clearlake Keys. So we have some big picture goals that goes across all of those project areas. I just want to preface this that we will definitely make sure early and often to speak with the tribes and really make sure to consult with them in all the work that we do, because it is important, and we want to learn, we want to do what's right for the land, and so anything else that anyone wants to talk about too beyond this, after, again, we are here to listen. So some of our big picture goals: to improve wildlife habitat for resident and migratory birds, restore spawning habitat and fish passage for the Clearlake hitch, improve water quality in Schindler Creek and the Clearlake Keys at the confluence of Clearlake, and improve the quality of life for residents of the Clearlake Keys and the community of Clearlake Oaks and Lake County. So this was a table that we developed because when you have 3 big projects, it gets very complex, and to try and explain this as we were beginning this development, we had to have a way that we could look at this as a quick overview. So we put this together, and the way you can look at it across the top are the 3 column headings, the 3 projects. Then we have it broken down into a planning and implementation phases. Phase 1 is land acquisition. Phase 2, again, our permitting across all 3 properties. Phase 3 can be broken down into two projects, and then implementation phase 4 and the Clearlake Keys rehabilitation. And I'll go into those in a little bit more detail. So phase 1, the Shannon Wetlands land acquisition, just some things to know about the property. So it's an 85-acre privately owned property, and we want to honor that they are ancestral lands of the LM Indian Colony that contain culturally significant sites and resources. We also want to highlight that this is high-quality wetland habitat, and that the Lake County Land Trust aims to acquire and restore the property, co-manage the land with the LM Indian Colony, and provide public access in perpetuity. And I also want to mention some other notable facts, that if you look to the wetland inventory map to your left, this area, the areas in green, they are classified as non-tidal emergent wetlands dominated by perennial plants that flood seasonally with the low water table. And the map in the middle may look familiar. The last 2 speakers have also highlighted this map as well, but I wanted to kind of focus on this site 10 in red. That's the orange circle there. Those are cormorant and heron breeding sites for both the black-crowned night heron, this is in the wetlands, the double-crested cormorant, great blue heron, and the great egret. And just this year in 2024 alone, Donna and the Redbud Audubon Society have counted in the wetlands over 100 different bird species. So while the numbers are down, that diversity is there, and we really want to protect that biodiversity. And then a CNDDB search has found, of course, special status species such as the Clearlake hitch, Townsend's big-eared bat, and the pallid bat. And I also want to note, if you kind of avert your eyes again to the left map there, that orange arrow is pointing to what is on the wetland in the west corner. It's an improperly constructed stormwater drainage ditch. We don't know exactly how far. We've looked at some aerial photos from like the late 1950s, and it looked like it was still there. So it's been there for a long time, and we are ready to get it out of there. So, all right. So once we acquire the property, we will then trigger preparations for phase 2. So during phase 2, again, that's going to be across all 3 properties, and this planning is going to help take care of everything that we need to take care of so that we can get boots on the ground and start the restoration for phase 3 and phase 4. So this is a list of the different, identifying upstream sediment sources. What are the opportunities that we have? What are the constraints that we're working with? That's going to be really, really important for our phase 3 projects in the wetlands. I mean, across all 3. We need to know where the sources are, so we're not just putting on a Band-Aid. And so that's going to be a really key point to what we're trying to do. Of course, going through all the environmental compliance and permitting, utilizing any kind of innovative resources and technology that we have to help make our projects more efficient and more effective. Because when we're on a budget, we have to make that count, and we want good quality data. So phase 3, once we've taken care of the whole planning phases, one of the project in phase 3, there's kind of two parts. We have Schindler Creek Habitat Restoration Project. So some of the overarching goals here are to remove encroaching vegetation barriers to Clearlake hitch migration, control upstream sediment sources through engineered design, increase spawning habitat by recontouring stream channels, and then stabilizing stream banks with native riparian trees, perennial forbs, and rock armoring. And then on the Shannon wetlands for phase 3, some of our project goals include improving water quality in the Keys by removing the drainage ditch and non-point source pollutants, so that drainage ditch I was showing you in the last couple slides, recharge groundwater, extending the seasonality of the wetland, revegetating the wetland with native, locally appropriate, and culturally rich species, and then finally establishing an environmental education site with interpretive signage and trails. And we strategically planned phase 4 for the Clearlake Keys Rehabilitation Project because we needed to address, like I said, we need to address those sediment sources. We need to see where those impacts were and address those before we could get to this project here where we're largely going to remove sediment from the Clearlake Keys and the mouth of Schindler Creek. We also would like to remove non-native aquatic flora, followed by revegetating and stabilizing the banks, and then improving water circulation, water quality, and connectivity. So we've got a lot of work ahead of us, but we're getting a lot of support. I'm hearing a whole lot in order to kind of get people up to speed. Maybe I'll skip here. Get people up to speed on what information and what findings that we're coming up with. Social media seems to be all the rage. I'm not a big social media person, but maybe I need to get on board. So I might not be the lead role on that one here. I know, but I think that this is how we're probably going to get a lot of folks, especially if maybe you're not a natural resource professional, you're just a Clearlake citizen, and you just want to know what's going on, you want to keep up. How's the restoration coming along? And if that seems to be the best resource, or if you have other ways or other ideas, come talk to me after. So if you haven't seen our poster, here it is. It's right outside the door. Again, come talk to us. You can talk to myself, Christine, Chris, the Land Trust. You can talk to Donna, and we'll do our best to answer all of your questions and find the best path forward as we develop this project. And again, I'll be here all day, and I don't know if we have time for questions, but I'll be outside the door all day. So thank you.
Do we have any pressing questions for HANA Resources? Anybody live in the Oaks? Who lives in the Keys? All right. Okay. Okay. So thank you. We have a break now.
Good morning, everyone. Just to save some time for the panel, we're going to get started. I have 10 minutes for my talk, and we're already 5 minutes late. But for those of you that don't know me, my name is Luis Santana. I am the water manager and a fisheries biologist for Robinson Rancheria. I'm co-moderating this session with Angela. And so we're going to talk about invasive species during this time. So there's a lot of invasive species, probably more than we could really pay attention to around here. So we're going to focus on quite a few that are more easily to manage. Well, it's not really easy, but people know how to manage them in a certain way. So throughout these next presentations, we're going to discuss most of those. With that being said, I'll get started on my presentation. I'm going to go by quick. I could talk about this all day, so if you guys have questions, even after the panel, please feel free to reach out. So fishes before contact, they're listed here. There wasn't too many. There's some to be rumored to be here that could have made it up above any kind of, fall through Cache Creek, or even when the lake was draining through the Russian River. They could have made it here, but there's really no evidence of it. And that's the salmon and the sturgeon and Pacific lamprey. But we do have brook lamprey here, so maybe they made it. And then this is fishes today that we find. Unfortunately, the Clearlake splitstail is now extinct, and also, I forget if they had Clearlake chub in the name. I think they did, so that's also gone. So I'll talk a little bit about this study because I know Ben's going to get into it. This is where a lot of our really good information comes from. This is electrofishing study, and this was more for people who weren't really familiar with it. But anyway, throughout the year, CDFW comes out and does their survey of the lake, and they're able to electrofish in certain parts of the lake. Fish pop up, you net them, you handle them, and then you release them. So they don't tend to get hurt just because we know what kind of pulses we need to send to be able to keep them alive. And so this was last year. I don't know about this year. But it adds to the sampling methods that Ben has been doing for upwards of a decade, I believe, maybe 2. But there's 10 sampling events where he did a mark recapture study. That's not supposed to say meant, it's supposed to be a mean total length, the CPUE, catch per unit effort, the relative population estimate, which, you know, you're able to compare in the mark recapture study, and he'll discuss that more in his presentation later today, so stick around for that. But he has a general fish survey and then a hitch survey, so he has 2 different sampling events. One focuses mostly on just hitch, and the other one's just overall general population of fishes. This is more of a study, so because he's going to touch on it, I'm not going to go too much into depth on it, and this was from 2023. So here's Clearlake. So it's 176 square kilometers of surface area, 160 kilometers of shoreline. Average depth is right around 27 feet with a max depth of 59 feet. I'll talk about it more in this discussion, but as far as monitoring for invasive species, we go way up in the tributaries and go into ponds and smaller reservoirs or lakes. So my invasive species program is mostly focused on the common carp and the goldfish. And so they're really tolerant of really bad water. And we have a lot of bad water here in Clearlake, specifically from, you know, right around Memorial Day through September. And so they're able to thrive here. They easily outcompete native fishes. They're a type of minnow, and Clearlake H are minnows. They're super aggressive and territorial. If you guys are ever out in the lake during their spawning season, they definitely push other fishes out of the way. We've handled bass that have, like, you know, stab wounds that come from the carp, and they're not like trying to stab them, it's just incidental. So we tagged the 46-pound female 2 or 3 years ago, and so just to like kind of think of what that could potentially mean, 5 to 10 pound female carp can produce anywhere from 100,000 to 500,000 eggs. And so we did tag a 46-pound female. So another reason they're kind of bad for our environment is they uproot vegetation. They're really good at eating plants. So a lot of farmers in the Central Valley, if they want a pond that doesn't have plants in it, they'll introduce carp. And so they're really good at doing that. And so that becomes a problem because it takes away habitat from other fishes, not just native fishes. So those aquatic plants are really good, basically cover for the fishes lower on the food chain. And so when they uproot those plants, that cover is no longer there. And if you guys remember during the drought, the last time of the last portion of the summer into the fall, there was like no cover whatsoever in the lake. So that vegetation is really important for cover for native and non-native fishes. They stir up sediments during their spawn. So if you guys go out during the spawn that starts right around April, the shoreline is like just black just because they're spawning. They're really good at disturbing sediments. So during their spawn, they disturb the sediments, they come up to the surface, and it's just like, oh, what's going on? Did it just rain? No, the carp are spawning. They are very good at eating everything in sight, including macro and microinvertebrates. And so there's a couple studies, I don't think I linked it here, but there's a study where basically there's extinction events of those little bugs just because carp were so good at eating them. And so a lot of the studies coming out of the Midwest and the East Coast show that when you remove carp or any species closely related to them that do basically the same thing, water quality improves. And so this is one of those studies. This is actually one of the studies that our contractor that we work with to show us all this stuff did. And so they did their study on wild rice. And so right here on the left, they fenced and seeded a portion of the lake. And then right next to it is open seeded, so they didn't fence anything off. This is just fenced off, and then this is just open water. So you can see when you keep carp out, vegetation tends to grow. So this is, we'll talk about our study that we completed in 2022. And so before we started the study, we kind of put in all of Clearlake's information to try to figure out what the tolerance is of the lake. And so if there's 89 pounds of carp per acre in Clear Lake, that was going to be ecologically damaging. And so we used electrofishing boat. That was thanks to CDFW. So they came out, did electrofishing, we established the catch per unit effort, and put that into our model. So our goal in our initial tagging of these carp was 30. And then we just tagged 28 more in February, and we're hoping to tag 25 more this November. And the reason we're tagging some of these fish is we have this antenna, and we could go out and kind of locate these fish when we tag them. And so if you ever see one, you'll know it's tagged because there's this antenna sticking out of its belly. So this will just help us kind of figure out where they're hanging out throughout the year. And the other reason we do this is so they tend to congregate together in the winter. They just all bunch up together for whatever reason. I'm not entirely sure why. But if we have them tagged and we could find them during the winter, it'll be easier to just put a net around those tags and then bring them all in and try to get rid of as many as possible. So that study, remember, 89 pounds per acre is ecologically damaging. So if we go down here, this is what we found. 172 pounds per acre in Clear Lake. This is in 2022, so almost double. And then for goldfish, it was 65 pounds per acre. And so this is more of our CPUE data that we got. We got a lot of carp, a lot of goldfish, Sacramento sucker after that, largemouth bass, Sacramento blackfish, black crappie, and channel catfish. And so during this time, we also used gill nets. And those gill nets, because they were so big, we knew that we weren't really going to catch anything besides these guys. So the reason we're teaming up with CDFW on carp removal, carp and goldfish removal, they're good at eating a lot of eggs. So when the creeks go dry during those droughts, the lake is kind of the only place that Hitch could use to spawn in. And so if that's the case, we want them to be able to spawn in the lake without carp going and eating all those eggs. This is just a picture of one of the tags. So this is the antenna sticking out of its belly. This is us doing surgery on the fish. And they're really hardy fish. Like you put them basically in a big tote for like 5 minutes and then they're good to go. We haven't had any morts yet. So enhancements from carp removal, better water quality, harmful sediments could be removed via bioaccumulation, more and bigger native and introduced fishes, native aquatic vegetation growth. And then this is kind of a map of where we found those tagged fishes in 2022, 2023. So these yellow dots, there's 0 counted there. And so you see these, the orange is 1, the red is 2 to 3, and then the darker maroon is 4 to 5 tags found in that area. So we're going to continue invasive species program development. there's so many, and I have no idea how we'd be able to kind of manage all the invasive species. So, you know, as we develop our program, we'll continue to expand in any possible way that will help native fish and wildlife and plants to thrive. So I'm running out of time, so I'm just gonna go quick. Our capacity, we have to work with everyone because we don't have the capacity to do everything that we want to do. So state, federal, county, other tribes, nonprofits, we have to work together to try to get everything done that we want to get done. And then this is my contact info, in case any of you guys want to contact me about any of the programs that I just discussed.
Questions for Luis?
Could anglers help with the carp removal?
Yeah, 100%. So there's a big bow fishing culture on the lake. The problem is they have to compete with bass fishermen as well. And so like the best spots to bass fish are also kind of the best spots to carp fish. There are people that do target carp, but it's probably nowhere near enough to actually put a dent in the population.
There's another question.
Hi, Luis. I was hoping to hear a little bit more about your plans to like round up the carp. I know you've been tagging them for a couple of years now, and have you done any of those nettings yet? And if so, were they successful? And if not, when are you planning to do them?
Yeah, they were successful as part of one of our grants. We did the feasibility netting of it. Unfortunately, at that time, we weren't able to remove those fish. It was kind of just, we're going to test this to see if it works or if we have to go a different direction. Our first net, the estimate was 50,000 pounds of carp. And that was in the redbud area. Yeah, I mean, we had to release them. We didn't have anything to kind of remove them. But this fall, we will be removing a lot.
Hey, I have a question about the, maybe you can't answer this, but maybe Ben can when he comes up, is what are the effects of the pelicans on this lake?
Yeah, that's a good question.
And has anybody studied that yet, or are we going to do that in the future?
I don't think so. I don't think they've studied it. I've heard a few people discussing about talking them in the future because I know they were here naturally, but it was more seasonally. And now they're kind of just residents. So I'm sure they have a big effect on, hitch, but also other fishes.
One time for one more question? Anybody? Okay, thank you, Luis.
Yeah, you're welcome. So next, CDFA is going to talk about their hydrilla eradication program.
Morning. My name is David Kratville. I'm an environmental program manager with the California Department of Food and Agriculture, and today I'm going to talk to you about the hydrilla eradication program. I've worked with CDFA since 1998. Closer to my mouth? Normally I don't have to be told to speak up, but Shut Up was my middle name as a kid. I'm an environmental program manager. I've been working at CDFA since 1996. My background is almost entirely in noxious weed control. In addition to working in the hydrilla program, I was a district weed biologist, and I currently manage the noxious weed grant program as well. But this should be a great talk to follow up with that previous talk. But I'm going to focus on hydrilla eradication in Clearlake specifically. So hydrilla, it's a non-native plant from Africa and Asia. It was discovered in California in 1976, the same year that I was born here in California. We paralleled each other numerous times. It was discovered in Clearlake in 1994, which was the year I graduated high school. So me and this plant are just going hand in hand, and hopefully when I retire, it'll be out of here. But so there's been over 30 eradication events, successful eradication events in California. We currently, the largest infestation we are still actively working on is here in Clearlake. And then up in Yuba, Nevada County, we have as well. But you can see hydrilla. There's two biotypes of hydrilla, monoecious and dioecious. We have both forms here in California. Monoecious is what's in Clearlake. But this plant can grow all the way up to the Canadian border and down all the way through Mexico. So California, everything grows great in California. You take a plant that's adapted to survive drought conditions and live in temporary monsoon waterways and introduce it to California with our lovely weather and year-round water, and it just grows like crazy. But we've successfully eradicated it numerous times throughout the state. So just real quick, I'm going to run through the authorities that CDFA has. So the Code Section 403, the department prevents the introduction and spread of injurious insects, animal pests. This is why you get asked for fruits and vegetables when you come across the border into the state from out of the state. Along those lines, CDFA is also designated as the lead department for noxious weed management. So we tackle hydrilla as well as, like I said, we do exclusion efforts and then fund weed grants for the counties and weed management areas. But in 1977, California legislation established a statute that requires the department to do surveys and, when feasible, eradication efforts for hydrilla. And specifically, Code Section 6048, it is unlawful to produce, propagate, harvest, possess, sell, or distribute hydrilla. This is one of the only plants that's named by name in California law. And that is why we still have an eradication effort on hydrilla, and we don't do the eradication activities for a lot of other invasive plants, noxious weeds that we used to. But hydrilla is named by name, and that real important word there is shall. The department shall do this. This is a mandate of ours. The way that it is funded, it's a very collaborative effort. So we get funding from U.S. Bureau of Reclamation. That money is fully expended in Clearlake. We get money from the California Department of Water Resources. This is also, it needs to be used within the Delta watershed, which Clearlake connects to. So basically all those funds get used in Clearlake. And then the largest chunk of money we get is from the Harbors and Watercraft Fund. And that's funded by when marinas sell gasoline. When you buy marine gasoline, there's a tax that is used to keep harbors and waterways clear. And so we get a portion of that to work on hydrilla, portion of that funding. So here is a little diagram of some of the commonly confused plants. These two here are two different, hydrilla is very plastic. Sometimes you see it described as being very serrated and rough, but it also, depending on where it's growing, can be very smooth. There's not those rough serrations. The thing that I want everyone to notice, if there's one thing you remember after my talk, it's the number of leaves in a whorl here. So that these plants, and I'll show you a side shot in a sec, but this is what's called a whorl, where there's a circle of leaves coming off the central stem. If you find a plant and over again it's in whorls of 5, we want to know about it. There's lots of other diagnostic things that people will talk about. That number 5 is the one that I tell everyone to look for. This little tiny guy down here with 3 leaves, that's Elodea canadensis. That's one of the native submerged aquatics of California. There's 2 species, canadensis and natalii, but this is canadensis, the little guy. That's very common in foothill streams. And then this big one here that has, look at 4 leaves, that's Agariodensa. This plant is all over the Sacramento San Joaquin Delta. I don't think we've ever found it. It is in Clearlake? Oh, you got rid of it, okay. If you go to the Delta, bass fishermen talk about fishing the hydrilla beds. We have never found hydrilla in the Sacramento San Joaquin Delta. Agariodensa is everywhere. And when you look at the two together, like this is so robust, it seems like it would be worse. But hydrilla, historically, when it gets established in the same ponds, Agariodensa quickly loses out to hydrilla. Hydrilla just pushes it out. But anyways, I'm babbling. Whorls of 5, we want to hear about it. So that's the characteristic to look for. This is that very spiny plant. Sometimes this is flipped upside down. These are called spicules. You might see them along the midvein. This is pretty rare. I don't see this very often in California. But again, 1, 2, 3, 4, 5 leaves in a circle, in a whorl around the stem. When you get the end of a growth shoot, these nodes where those whorls are, they all get packed together, and it's very difficult to count how many leaves are in one whorl. But as you see, as that stem gets older and the node distance increases, it's easier to count them. So don't find one little segment and has 5 leaves and just completely freak out. If you see 5, 5, 5, 5, 5, 5, oh, just repeating itself over and over again, then that is something that we would love to hear about. Again, highly variable. These are the same plants, just growing in 2 different ponds in the same general area. This one was super serrated. This one, you can hardly see those serrations at all. So don't go by the serrations as a diagnostic for hydrilla. The reason hydrilla is so hard to kill is this. It produces a tuber. These tubers, where hydrilla developed or evolved, there's monsoon rains. So it's northern Africa, India, into Asia. There are areas that may be bone dry for several years. This plant had to develop a way to overwinter, is the way that I would say it. They aren't seeds, it's just a propagule that gets stuck down into the soil. You can completely dry out a pond and kill most aquatic vegetation. The second you put water back in that, those hydrilla tubers sprout, and they say, thanks for getting rid of all my competition. Thanks for the haircut. You know, they grow like crazy, because that's what they evolved for. In the monsoon areas, the monsoons come, this temporary short-lived lake that might only be 6 feet deep, might only be there for 2 months. This plant had to sprout, go through its growth cycle, and send new tubers into the soil before that monsoon temporary lake pond dried up. So we get these here in California, and these tubers can sit for 5, 6, 7 years in dry soil waiting for the water to come back. And we cannot, I'll show you the pictures when I get into how we control it. We can't really target those tubers when they're down dormant in the soil. This is a picture we took in the late 90s. This is actually Clearlake. This is what a patch of hydrilla looked like in Clearlake. One of the things that hydrilla does, the previous speaker mentioned vegetation being important for fish in particular. Hydrilla, along any of these aquatic vegetation, they do have that edge habitat, but hydrilla makes such monospecific stands. It is 100% full of vegetation. There's no life in there. When you dig out these plants, it's just black, mucky. There's no dissolved oxygen. And this is what it does in ponds. So this pond is 6 to 10 feet deep. You can't really see it maybe, but it looked like a golf course putting green. That hydrilla is like a ½ inch from the water surface. Hydrilla grows to the surface, goes sideways, 100% fills the water column. There is nothing going on under that green mass. It's just black, stagnant, dead water. There's no light penetration. Initially, when you first have a couple aquatic weeds, they might provide habitat for fish. When it gets, in a matter of a few years, when it gets to this stage, there's no fish living in there anymore. So our control efforts, we utilize the airboats. A few years ago, I had us put insignia on the tail fins of our airboats. If you do not see the big CDFA symbol on that boat, it's not us. There are a number of other other airboats out there working on the water, but our boats all have a CDFA insignia, and I should update my photo to show you what that means. But we use all sorts of watercraft. A lot of our locations are small ponds, and we just utilize the kayaks. So this is our treatment protocol. If we find a rooted plant, that establishes a new treatment area, and per the aquatic pesticide labels, here in Clearlake, what we do is called a partial lake treatment. We consider the entire lake, for legal reasons, infested, but we only treat areas around rooted plants, where we find a rooted plant. If we find a floating fragment, that does not trigger a treatment event. We only treat where we know a plant is growing from the soil. But per the label, the minimum that we do is a 5-acre area around that plant. We do an immediate treatment with a contact herbicide. Typically that's copper is what has been used. And that burns down the plants to limit fragmentation and possible spread from that area. And then we follow up with a systemic, and what we've used historically and has been the best tool for us is fluoridone. And we use the slow release pellet. Previously, we would remove an area from treatment after 3 years of no plant finds. Over time and numerous other smaller areas, resurgence was noted, and we had a technical advisory panel. We worked with researchers to determine a more successful schedule for removing areas from treatment. So I got a couple graphs here. This is, I went back to 1996. I believe that was the year that we started using fluoridone. Prior to that, we only used copper in the lake. But this is the number of hydrilla finds. So it was found in 1994, 95, 96. We had, I guess I chopped off the numbers for the number of finds. At any rate, we had a peak. We started treating with fluoridone in this time frame, and the number of finds went down. Per our old protocol, in 2003, we might have had one plant find in 2003. I believe 2004 was when we got to 0 plant finds. At any rate, we reduced all the acreage. We did our 3 years of no plant finds, and then we just had this resurgence, this massive spike, almost to the same number of plant finds as we had at the peak previous. So this is where we extended that to 7 years, and you see it tapering out. 2016 was the last year we found a rooted plant, was the last year we created a new, added additional acres for treatment. So here is the actual acres of treatment you can see, and I'll just do both of them together here. So you can see the plant finds went up. So as the finds go up, we start treating more acreage. As the finds go down and we would remove, after 3 years of no finds, we would remove areas from treatment. So then it just plummeted. It went from almost the most acres of treatment down to 0 in just a couple of years. And this is where we realized with this resurgence that that was a problem, and we adjusted our tactics. So you can see we quickly knocked it down with our treatments. So the number of plant finds, we would only find a few per year. But we really hit the brakes on pulling acreage out of treatment. We continued to treat for that longer 7 years, minimum of 7 years after no plant finds. This is an example of the treatments we do. This is what the copper herbicide looks like. It's a liquid formulation. And then this gentleman is measuring the pellets for the slow release pellets for sonar, the fluoridone. That's our long-term systemic. So this is one of those small ponds I was talking about, and I will show you some pictures of it later on when it's full of weeds. But that's me in a kayak paddling around, and that's us doing our copper treatments. In the small ponds, we treat the entire water body. Anything under 10 acres we consider a small pond, and we just treat the whole entire thing. Here in Clearlake, we do the partial lake. We do the minimum of 5 acres. But in the smaller ponds, we just treat the entire waterway. Here is another small pond. I don't know if you can see the little pellets coming out. He's using a belly grinder, just a seeder that you would use for your lawn. We have modified ones, larger mechanical ones on the front of the airboats that we do the same thing. Here in Clearlake, we use one of those seeder spreaders to throw a swath of those pellets. This is an example of healthy hydrilla versus fluoridone damage. So this is why we treat with a copper-based herbicide or a contact herbicide, typically copper. But we come in, when we have a plant find, we come in and we use copper to kill all this vegetation that's growing. If we just throw fluoridone on it, anything that's already grown does not die, is not directly affected. Fluoridone works by stopping the production of chlorophyll. So all of this started growing after fluoridone was introduced. So none of this new growth will survive. It can't produce energy. It doesn't have any chlorophyll. But this is why we go in and burn the whole plant up with a contact herbicide. And so here's my little cartoons that I made to explain this, since the aquatic applications are much different from what most people are used to doing, you know, if you spray around your lawn or a roadside or something like that. So these are the problems with hydrilla. We have these tubers that can sit, as I said, for years and years down in the soil just waiting to sprout. But an actively growing plant can produce what's called a turion. So these little buds can just break off, or it can just directly fragment. Just a little small 2 to 3 inch piece of hydrilla will start a new plant. So when later in the year, towards the end of the season, what hydrilla does, because it's expecting the water to go away where it evolved in the monsoons, what it does is it tips down, and the ends of these growing tips penetrate down into the soil. Depending how fluffy this is, it usually goes to like a clay layer, but I've chased them up to 2 feet down into the soil. in a canal where we were using dredges to remove all the hydrosoil. So it goes down as far as it can, and it deposits a tuber, and that tuber, like I said, can sit for years and years and years waiting to sprout. So what we do is we come in with the copper, which turns the water purple, and we burn everything up. Copper just breaks down the cell walls. All the plant matter that comes in contact with this concentration of copper in the water basically just dissolves, breaks down. And this is when you have to worry about dissolved oxygen crashing when you make an aquatic pesticide application. This is also it's not selective. Most plants are susceptible to copper. There might be some, but the rates that we use fluoridone is very specific to hydrilla. There will be damage to other plants. It's a range, but luckily hydrilla is very susceptible to fluoridone. At any rate, this is our protocol. We come in, we treat with copper, and then you can see we burned up all the plant matter in the waterway, but we still have these tubers and the perennial root crowns that are waiting there to sprout. So then we come back and we put our pelleted pesticide product out, and these slow release pellets just sit at the surface of the soil, slowly releasing the active ingredient. And so as those tubers sprout, they come up, they hit that layer of fluoridone. They're not able to produce any chlorophyll, and we just deplete the energy in the tuber. So this is why over years and years we're able to wear down that tuber bank and finally remove areas from treatment. So real quick, the previous speaker was talking about droughts. That last drought really taught us a few things. Again, this is just the nature of aquatic pesticides. When you have submerged aquatics, the emergent or riparian stuff, you treat it, you spray it just like any other terrestrial plant. You spray the product on the plant. In aquatic settings, we for submerged aquatics, we put the pesticide in the water itself. So here's what happens. Hydrilla is doing its thing. It's putting down tubers at this water level, and it likes to put them right at the surface of the water. What we learned, we were treating, during the drought years, these ponds, the water level would be down quite a bit, and the same thing happened in Clearlake in the recent droughts. The shoreline, there was hundreds of yards of just mud that we couldn't put pesticide in, and we couldn't get up to look for hydrilla. You can't look for these tubers in the soil without using a dredge and digging it up and sifting through it. So essentially, during the drought years, all these tubers are just sitting dormant, and there's not much we can do about them. But we can come in here and treat the water, and we did a great job, and we think we thought we were doing great. We were going to declare eradication of this little pond. The drought ended, and suddenly it looked like we hadn't done anything. It went back to square one. And so this is why we didn't pull acreages during the drought, because we can't go out and survey for the hydrilla, and we can't get product onto the plants to kill them. Here's that pond I was treating in the kayak. This was during the drought. You see all these cattails, mix of cattails and tules, and this grass growing around the edge. So essentially the water level was down to here for all those years of drought, and we were controlling hydrilla, we were controlling it. We thought we were doing a great job. The water came back up, all this grass, there's all the cattails. You see this area where there's no cattails, there's like a 6 foot wide buffer. This was solid with hydrilla. And you see the water came up behind these grasses. This was all bone dry for all those years of the drought, and it was just a fairy ring of hydrilla. This is just solid hydrilla around here. And then the bells went off, like, oh my goodness, we can't declare eradications on these if we can't control or survey those areas. So lastly, real quick, we utilize a statewide trapping grid. As I said, I've been working for the state since 1998. There's been numerous people over time that have come and gone. In my head, I'm still the new kid, but I'm the dinosaur now in our branch. Funny how that happens. But and this is specific to eradication work. Eradication work is much, much different from control work. But we developed this, we have a statewide trapping grid, but we sort of modified it for Clearlake. And just to be able to track, so this is just a fake pond, and we're saying there was some plant finds there that year. And then maybe the next year we had a few more and another one there. And then the next year there's more and more. But what I'm able to do with this system is identify areas where you know, the manager 20 years ago might have remembered that, oh, you know, 100 yards off of so-and-so's dock, we found a plant. When you're trying to eradicate, you cannot allow anything to survive. You can't allow one individual to survive. You know, if you call someone out to get the weeds out of your yard and they get 99.99% of them, you'd probably think, hey, you did a great job. If I do that, I fail. We have to control every single individual and not allow them to propagate. So we utilize this system to identify areas, and that helped drive, we made some adjustments, but just look at different areas of the lake differently and modify our treatments a little bit. But that's really specific to eradication work. But over time, like I said, this has been going on for 30 years in Clearlake. There's been a lot of people working on it in that time. We just try to use a scientific GPS, GIS tracking-based system to really target our treatments. And with that, I will say, I didn't even say this, this is the first year that we are not making any applications in Clearlake. To date, we have not found any hydrilla. We have not found a rooted plant since 2016. There was a fragment found in 2019, but no plant was ever found. Nothing's been found since. So we're very happy. We're not saying that we've eradicated it from Clearlake in any sense. We're going to be here for many, many years looking, hopefully. But yeah, we've Mike Meskey, who unfortunately isn't here. Holly is here. She's one of our boat captains. You know, our crew are people that live here in Lake County, work on the lake every day. Mike was a great addition. He's done a fantastic job. And anyone in here that knows him seems to like him. He's a great guy. But yeah, we're extremely happy to say that we're not making any applications this year for hydrilla in Clearlake. And thank you.
Are you done?
Okay.
Are you done?
No, I'm done, yeah.
Okay.
But
I have a quick question for you, and then I'll go to the audience.
Sure.
So, Angela, I am the County Invasive Species Program Coordinator, and we are right now trying to manage another invasive aquatic plant called creeping water primrose. And we don't know, it goes to seed, and we don't know how long those seeds last. And so I'm wondering, I saw the map with the wide range of eradications that were successful for hydrilla in California, and if those other water bodies were successful with only the 3 year of no fines for the limited treatment, and like where did the 7 year come from? How did that process happen so I can learn from it for the Primrose Management Program? And then is that 7 year thing unique to Clearlake, or is that something that is across the state that you guys all learned together?
That's a fantastic question. There's a couple things. Some of those infestations may have been a water feature the size of this table. If it's in a cement-lined water feature at a zoo, we come in, we drain it, we scoop the soil out, boom, problem solved. Some of those locations are very small ponds. Like a lot of our ponds are smaller than this room. We can treat the whole thing. The water's crystal clear. We all know that Clearlake can be anything but clear at times. So in a small water body where we can treat the entire, we can keep the concentrations up, and we can see it's easy to survey, it's less likely to miss something. Another issue is monoecious versus dioecious. Monoecious, which is here in Clearlake, produces many, many more smaller tubers. And we always thought, oh, those big honking dioecious tubers, they must last forever and they're going to be a real problem to get. It's not the case. It's just a numbers game. There might be one of those monoecious tubers out of thousands that wants to wait 10 years, 12 years to sprout. So the monoecious versus dioecious is a problem. But really, a big part of it, I believe, is just the size of Clearlake. If we eradicate successfully from Clearlake, it will be world news. It hasn't happened.
I second that. I've worked across the country in
Yes.
invasive species programs, and California by far sets the map for hydrilla eradication.
Yes.
So yes.
Yes. Thank you.
So have there been any studies on the toxicity of copper? I know that overdose in copper in some places can kill fish. So I'm just wondering if what levels of copper you're putting in there, Has there been toxicity? Does it kill hitch fish? Because I know it kills other fish
So-
if the toxicity is too high.
So when we deal with copper, there's a number of issues. We utilize the labeled rate and we follow the labels depending on the situation. So I don't want to spit some numbers out because it depends on the situation. There's a number of, typically what causes aquatic life to die from a contact like copper, a copper treatment, is the dissolved oxygen crash, because you burn all that plant matter and then bacteria start breaking it. They literally consumes all the oxygen. If you are to utilize it in a pond and treat the entire pond and it crashes, that you can definitely have issues. In a partial lake treatment, we're lucky because there's room for the fish to move to. In regards to hitch, before we make a copper application in this lake, we contact Ben Ewing. We have regular contact preseason. We contact, Mike contacts him, and if it's designated as a hitch area, if he thinks hitch are breeding there, we would have to figure out what we're to date, we haven't had a problem with that, but we do that prior to a copper treatment. There are other species of fish, and I don't have the label memorized, I don't want to misspeak here, but there are certain species of fish that are more susceptible to copper, and depending where we are in our smaller ponds, we might do alterations based on that. And typically, a lot of times, one of the rules of thumbs in aquatic treatments is to do a third of a pond. It depends. That pond I was treating is an irrigation pond. It doesn't really have anything in it, so we were able to treat the whole thing. If it's a fishing pond or a natural pond, we would treat thirds at a time, and you give that third of the water body a chance to break down. You give refuge area for the fish and other aquatic life to move to not suffocate from the crashing oxygen, and then you make a series of applications in those thirds of the water body. So those are the sorts of considerations we make for aquatic life. Sorry.
And additionally, for the copper use, the county doesn't allow any other copper discharges. So we don't issue any other permits. So copper is only being used during a hydrilla treatment process. So there's no other sources of copper.
And the other item I should add, as I showed, we only utilize copper when we have actively growing plants. It's not our long-term. So ideally, we would make an initial copper application at the very beginning of a plant find and then not apply copper to that area again, unless 20 years from now a plant pops up again.
We actually have one more question, and then I'll come back. Okay.
I can go ahead and get her first.
Oh, okay. You see that, please.
What about the chemicals that they're using to get rid of the other, the primrose?
That's not a question for me to answer.
That is for me to answer.
Yes.
Primrose is actually, the best time to apply herbicides for primrose is the hottest part of the year, which we're actually really not allowed to apply herbicides because the water temperature is too warm and the DO is too low. So we're establishing a program to try to figure out how to manage primrose without using herbicides. There's a product called Triclopyr, which is a systemic, and that's used on primrose. But again, the timing of when it's most effective doesn't mesh with wildlife protections and water quality protection. So it's not. If we do spot treatments of primrose a little bit here and there, but widespread treatments of primrose with herbicide is not feasible on this lake at this time.
Pulling them?
Yes, we're trying to establish a pulling and other methods. We actually just got a grant to do experimental burning on primrose in areas like Rodman Slough with Terra. Where's my Terra folks? Yes, so our burn masters are going to try to see, particularly for burning off seeds of primrose. Yeah. Yeah, but you can come and ask me any questions about primrose. That's not David. So one more question while we set up the next presentation for this. I'm going to scoot over here, guys.
Has there been any new or more recent research done that you're aware of that is looking at eradication methods that are using different routes to eradicate?
If you're talking about different chemistries, in California, we're unique in that we have the Department of Pesticide Regulation, which is an additional layer of regulation for aquatic products. So The aquatics realm in general does not produce a lot. It's not a really big market for the manufacturers to target. In recent years, there have been a number of new products, and some of them have been registered in California. Unfortunately, when you're dealing with submerged aquatics, there's a whole slew of additional restrictions you have to worry about. One of the biggest is irrigation restrictions. So you can't irrigate, depending on what the product is, you may not be able to irrigate with that water. The biggest item for us, for our protocol, is the slow release nature of fluoridone and the longevity of fluoridone. We have not found anything to compete with that. So no. And it's just, aquatics are such a small niche of pest control, submerged aquatics. It was like 20 years of my career before they said there's something new. And then we were told, California, you'll get it in 5 years. The rest of the country gets to use it. So.
Thank you very much. I will say
Sure.
one more note. The team that runs the airboats, they are essential, obviously, to this program. They also help us at the county and the public because they're out there every day and they notice anything that's going on. So, for example, if we have a spot where someone drops some invasive water hyacinth, they're the ones that see it, and then they let me know, and my team goes out there, and we can get rid of it right away, saving complicated, expensive treatment and removal later. So we're in debt to that program. And then also the airboats, people see them. You guys all seen an airboat? Really loud, right? It's very obvious they're there. There's a lot of water moving, and it looks like maybe they're doing treatments all the time, but like this year, they're not doing treatments. The airboats are out there monitoring. So just because someone sees an airboat, it doesn't automatically mean that they're putting stuff or poison or anything in the lake. Take a look at them. They're out there, they're throwing a grapple, they're surveying, and then they're also keeping an eye out for other invasives for their partners. So I just want to put that out there.
If you see them throwing something by hand on the water, that is our grappling hook on the end of a rope. We pull that along the bottom to pull up aquatic weeds to look at them. It's not a treatment hose going in the water. And early detection rapid response is the answer to all of these, any sort of pest or disease or anything.
Thank you, David. All right. We're in our last talk, and then we'll do a panel. So I'm going to introduce a technician at Water Resource Department, Corey Husted. And this is a program that's near and dear to my heart. I manage it. It's invasive mussel prevention program here in Clearlake. And, yay! Everything that we're talking about and learning about for Clearlake, if we got invasive quagga mussels or invasive zebra mussels in this lake, everything gets flipped on its head. And we have to start from scratch and learn everything all over again. Because quagga mussels have such a devastating impact on lakes. From the nutrients, from the bottom up, literally from the soil all the way to the top, the whole ecosystem will be totally changed. So it's really, really important personally, but also professionally, and I want to stress you guys, it's probably one of the most important programs we have on this lake. And so I'm really excited to introduce our technician. Like, no pressure, right, Corey?
I was just about to say, thanks for really hyping it up.
It's like, Corey, welcome.
That goes forward, and that's back. Hi, everybody. Thank you, Angela, for the introduction. Again, my name is Corey Husted. I have been working with the Water Resource Department for the past 4 years and with the Mussel Program Prevention Program for about 2.5 years, almost 3 years. Today, I'm going to be speaking to you about the prevention program, what that would look like if we were to get an infestation, what we are doing currently today, and what we'd like to see in the future for our program as it evolves. But before we do that, I'd like to show you guys just a little history of how these mussels came about into the United States and how they made their way out west into California. So right here, we have some examples of what quagga and zebra mussels look like. Right here is the zebra mussel on the left. You can tell the difference between these two by their shape and kind of what their designs are. The zebra mussels have these zigzag type of shapes. They're more triangular and they lay flat. Compared to the quagga mussel, where they're more rounded shape. They don't lay flat, and they have these circular rings. They're also lighter in color. And here's just an example of just how devastating they can be to shorelines, to property and infrastructure, and just how fast that they can populate. And here are some quick facts on just what they are. Female quagga mussels can lay up to 1 million eggs per spawning season, and they can live up to 3.5 years. They are very adaptable to the climates that they're in, and for Clearlake, we are a calcium-rich lake, so they would have a feeding frenzy on our lake itself. Adult mussels can last outside of water for about 5 to 30 days, depending on the weather. If it's hotter weather, they will die off a lot quicker, but they can last up to 30 days. And that's really crucial when we're doing our screening process for when we do our sticker sales. The veligers, on the other hand, that's the microscopic life cycle of these. They do need water to survive as well. And the way that they move to and from water bodies is by boater traffic. So boaters that are unaware that they're maybe in an infested body of water, or maybe they knew that they were in an infested body of water, didn't properly clean, drain, and dry their vessel. So they would leave standing water in their live wells or in their bilge and their ballast tanks if they're a wakeboarding boat. And then they would go and travel across state lines or wherever, and they would release that water into bodies of water, and that water body would be infested. And the way that the adult mussels attach themselves is by byssal threads. And, sorry. You can kind of see just an example of just kind of how creepy these things are. They're pretty much just like Velcro. They're very difficult to get off, very manual, very labor intensive to get these off boats. We have an example that we do for our outreach events where we dipped a boat into Lake Mead for 6 months, and it's really awesome. Whenever you guys, if anybody ever sees us at one of our outreach events, I'd highly suggest checking out that boat. It's really amazing what they can do. And here's an example of just like the life cycle of the quagga and zebra mussels, and from their egg cycle to veliger to juvenile all the way to male. And so it is believed that quagga mussels were introduced into the United States by a cargo ship that came over from the Black Sea and Caspian Sea over near Ukraine, and they made their ways through the channels into Lake Erie and discharged their ballast water into that body of water. And a year later, in 1989, they were discovered in Lake Erie. And not only in 10 years later, this is exactly what the map looks like of just how fast they spread throughout this, Midwest eastern regions of bodies of water. And you can kind of see they even started to make their way into the Mississippi River, most likely from boater traffic. And by 2007, they were actually discovered in Lake Mead, and they continued to just go out west even further and further. And even in that same year, after January, they were discovered in Lake Mojave and Lake Havasu in California. And once that was, I'll go right back. So yeah, this is the map of just how fast they've spread in just a 20-year span. And this is what the map looks like today. You can tell just how bad that these things really get and how quickly they go if boaters are not educated on clean, drain, and dry. You can tell right here in California, in the southern part, connecting to the Colorado River system, we have a very bad infestation, and I'll get to that in the next few slides. So what we did for County of Lake in 2008, the Department of Public Works enacted the Lake County Water Vessel Inspection Ordinance 2936 for the Lake County Invasive Mussel Prevention Program. And what that entails is every boat that comes into the county needs to be screened properly before they are to enter the bodies of water in Lake County, and most importantly, Clear Lake. And as of today, we have 26 sticker vendors and 16 ramp monitors that man all of our public ramps. These are the first, I'm gonna drink some water real quick. Get dry mouth. These are our first and last line of defense for keeping Lake County clear of mussels. And just like I said earlier in the last slides, this is what California looks like today. I'm not going to read every single one of these names. I can barely remember them. I have to look them up myself sometimes. But there's a lot of main lakes that we do see our fishermen and other visitors that are coming from. So we have a hot list of, am I doing that? Sorry, guys. We have a hot list of examples that we give to all of our vendors around the lake that sell our stickers so that they can be more prepared for when boaters do come out to get stickers for us, from us, excuse me. And right now I'm going to show you a PSA video that we worked on, me, Angela, and Sam Houston last year. And so go ahead and take it away, Sam.
Welcome to Lake County, home of California's largest natural freshwater lake, Clearlake.
Originally called Hobbiton, meaning big water in native Pomo, Clearlake is one of the oldest lakes in North America.
Clearlake has over 120 miles of shoreline with shallow and rich waters that makes it a world-class fishing destination.
The productive waters of Clearlake have produced record-catching fish, which contributes to the average 15,000 boaters that visit Clearlake every year.
Clearlake is currently free of invasive quagga and zebra mussels.
Monthly monitoring by Lake County's Water Resources staff help to maintain Clearlake's mussel-free status.
If invasive quagga or zebra mussels are introduced into Clearlake, their devastating impacts will last forever.
Mussels consume massive amounts of green algae when they filter feed lake water,
which will decimate the sport fishing population, as green algae is the base of the food web in Clearlake. Mussels can attach to and clog drinking water pipes,
causing millions of dollars to the public and private sector to pay for needed maintenance and removal.
For the drinking water systems on the lake, this is especially concerning as Clearlake provides drinking water to about 66% of the county's population.
Added cost to remove mussels would make drinking water treatment more difficult and expensive.
There are no examples of successful eradication of invasive mussels from lakes, meaning if quagga or zebra mussels are introduced into Clearlake,
they will be here forever, and the Clearlake as we know it today will never be the same again.
There are 3 simple things we can do to prevent the introduction of invasive mussels.
Before leaving any water body, remember to clean your boat inside and out, and all compartments. Remove any plants, dirt, or sand.
Drain your engine, pull your drain plug, and empty any water from ballast tanks or live wells.
Dry your boat, including inside compartments, and make sure all equipment, including water toys and fishing gear, are completely dry before visiting another water body. Every boat launching in Lake County needs to be screened and stickered.
Find participating screeners and sticker sellers online at www.nomussels.com.
When visiting a sticker seller, the boater will fill out a single-page screener form. The screener will verify that the boat is safe to launch in Lake County
and does not have mussels or has not recently been in a mussel-infested lake.
If a boat is high risk or likely to have mussels, an inspection is needed, and the vendor will call a certified watercraft inspector from the county,
and they will perform an inspection on the boat for free.
Once a boat passes screening and/or inspection, boaters will purchase a sticker for $20.
The County of Lake quagga mussel stickers are located next to the yearly California state sticker, which will be adhered to both sides of the bow, next to the registration numbers and the state's mussel fee sticker, as well as at the back of the trailer. Please report any violators without current quagga mussel stickers.
Even screen boats will sometimes be stopped at the ramps by ramp monitors for quality assurance.
Sometimes, mussel sniffing dogs will also be present at the ramps to conduct impromptu inspections.
This step won't take long, but it's important so that we can continue to protect Clearlake from invasive mussels.
If you have any other questions, or you think you see a quagga or zebra mussel in Clear Lake or in another water body in Lake County,
you can call us at Water Resources at 707-263-2344.
You can send us an email at water.resources@lakecountyca.gov.
Or you can send us a message on Facebook. Find us at Lake County Water.
Thanks for helping us keep Clear Lake clear of invasive mussels.
And with your help, we can protect and preserve Clear Lake for future generations of people, plants, and animals.
Thanks to our funding partners at the California State Parks Division of Boating and Waterways for supporting this program and PSA.
Thanks again, Sam. First time, guys, sorry. Speed round. Okay. So, yeah, just like the video said, invasive mussels would be absolutely tragic to Lake County. And, microphone? Oh, sorry. It'd be completely detrimental to Lake County. And even on a national scale, we can just see just how expensive these invaders can be to a community. Yeah, just nationally, these numbers are from 2016, by the way, so these numbers are not as completely accurate, and I guarantee they're almost doubled now. But nationally, 120 to 138 billion in annual cost. In the Great Lake Basins, 30 million on annual cost for mussel monitoring and control, and in California alone, $30 billion for their drinking water systems. And how that's going to translate to Lake County, where is in this next slide. Right now, fishermen, when they do come in for their tournaments, it is an estimate that they bring in $1.3 million. This number is very conservative. This number was brought into an algorithm that is for one fisherman coming into the lake fishing for 1 day. And these tournaments go on for 5 days if you consider pre-fishing, which is 2 days before these fishermen come in. So what that means for the economic impact for Lake County, water purveyors that bring in drinking water to the county, like the video said, 66% of Lake County residents use the lake for their drinking water at home. They would at least need to spend $100,000 just to maintain their facilities. Property owners would lose equity in their homes. I don't think anybody would really want to be living next to a dead lake with a shoreline filled with dead mussels sneaking up the place and damaging their property. Local restaurants, bait and tackle shops, hotels, resorts, gas stations, small business owners for boat repairs. The list goes on of the impact that invasive mussels can bring to a community. And to top it all off, we would lose our state and federal funding for our mussel prevention program, as we would no longer be a preventative lake. We would be a containment lake, and essentially cueing the domino effect. If we do not continue to have programs like this, this is going to be us if we were to get invaded, just waiting for that last domino to fall. And I think most importantly, the environmental impacts that would come to Lake County if we were to get invaded. The green algae food web would be completely decimated, causing smaller fish to not have any food to eat. If there's no food to eat for the smaller fish, they start to die off. If there's no smaller fish for the bigger fish to eat, they start to die off. fishermen don't come to Lake County to go fishing anymore. If there's no fish in the lake for the migratory and the native birds species, we're going to see a huge decline in that, and I don't even want to think about what would happen to all the grebes. Shorelines, like I said earlier, would be littered with sharp and smelly decaying mussels. You wouldn't be able to walk on the shorelines. Your dogs wouldn't be able to enjoy it. Swimming on the shorelines or off the shorelines would not be possible. And lastly, property damage would happen because they would attach themselves to any object that is touching the water. And so how we're helping stopping the spread here in Lake County is we utilize this app called the WID database, and it's a very useful tool for all of our ramp monitors, and hopefully soon in the 2025 season, I'd like to get all of my vendors in on this application. And what it is essentially our screening sheet in digital form, where we can look up a boater's CF number or registration number for their vessel, and we can see what body of water that they were in last, because it's all on the merit base of what boaters tell us when and where they were in their last body of water. And so to combat that as much as we can, we do have mussel dogs on bigger fishing tournament days that set up. These dogs are amazing. They can sense an adult mussel all the way down to the larvae and eggs cycle of their life. We do outreach events as much as we can. We did, I believe, 4 this year, very rewarding things. And to combat the fees for this is we do free inspections and decons. We want everybody coming to Lake County to feel like they can comfortably come here, knowing that they're not going to pay an arm and a leg to get inspected if they were in a body of water. We don't want to be a police state of telling people from Lake Mead that, hey, you were in Lake Mead, we don't want you here. That's not what our prerogative is. We want to welcome everybody and do the right avenues, and if decontaminations are needed, we will do that for free. Let's see, yeah, and like I've said in previous slides, we have all of our ramp monitors and sticker vendors, spread out throughout Lake County, being able to screen boaters, asking the proper questions of when and where these boaters are coming from. We also have a vendor over in Blue Lakes, and they are in contact with all 4 resorts there as well. So if any boaters are coming into Blue Lakes, they know to go to our screener in Blue Lakes. And then we also have 2 vendors in Lake Pillsbury, and they've been with the program for over 10 years, longer than I've been there. They know how to handle any boaters, and any boaters that do go there, they come clean, drain, dry. And here's just an example of all the access points into Clearlake. This is not including all the private resident locations. That number is in the 400 to 500s, I'd imagine, maybe even more. So it's pretty difficult to kind of get every place monitored. We do our best to do it at the public ramps. And here's a couple images right here of just what we've been doing this year. Outreach events and decontaminations, as well as our mussel dogs that are working with us side by side. And this is actually a really interesting image. Back in 2020, a boat came in from Ohio that had dead adult mussels on it. This boat made it all the way through California stations. The boater was told to get a decontamination. We were the closest one. This came from, I believe, Tahoe. I can't remember exactly. But our staff had a decontamination machine, and we were able to completely gut the engine, fill all the necessary areas with hot water to kill them for the correct amount of time, and we were able to send this boat off. I'm not going to be able to touch too much on this today. Maybe we can bring this up in the panel discussion, but if we were to get infested, this is a great resource on our website, www.nomussels.com. We worked closely with Leah Elwell and Lisa DeBrucker from the Creative Resources Strategies, working on a rapid response if we were to get contaminated with quagga and zebra mussels. It's a very great tool. I would encourage you guys to check this out. Here's all the partners that we worked with for that collaboration. It was a great 2-day workshop, and it is available online. So what we would like to see in the future is to beef up the WID database for California specifically, just because we have 43 lakes that are infested in our state. The reason why we want to buff this up is because not all water agencies use the WID database. So it's a big guessing game on where these vessel owners that are coming from. So if we have boater movement transparency, we'll have a much better success at stopping a spread coming into Clearlake. And then in my personal opinion, I would love to see 2 permanent decontamination stations in Lake County. We have 2 mobile stations and it works great, but it's a very time-consuming process compared to a permanent decontamination station as this one. This is a dip tank, costs about $1 million, but what it does is the pool of water heats up to 120 degrees, and the boater can then bring in the water into its boat for about 5 to 7 minutes, and then they're on their way, and they are completely clean and clean of invasive mussels. And here is a slide of where you can find out more information. If you guys would like to take pictures of this, I can leave it up for about 15 seconds. 1, 2, 3. And that is it. I appreciate your guys' time. If you have any questions, I believe we can bring it into the, we'll bring it into the, thank you.
Thank you, Corey. So let's have our invasive species presenters up to the table, and we'll do a panel. We have about 15 minutes. So David, Luis, and I will walk around. Are there any questions for our panel as they get situated? And there's these mics too, or yes.
Angela, I heard that you were not funded, the county wasn't funded for the quagga mussel program recently. Can you tell us what's going on?
Thanks, Janine. That is an important question. So the funding for the invasive species mussel program, we have 2 sources. One is through state funds through the Division of Boating and Waterways. So when boaters purchase their state registration sticker, previously they could just check a box and get what's called a mussel fee sticker, and all that money for that mussel fee sticker was like $16 each boater would pay for 2 years, would go into a fund, and then we get grant funds out of that. Well, according to a federal law now, those registration stickers for the mussel fees at the state level can't be sold together with their boat registration. So boaters get their boat registration sticker, they can buy it online, and then they have to go to a separate web page and purchase the sticker separately. So what this means is we've seen a significant drop in those funds for state mussel fee sticker sales, and that trickles down to grants. So that means there was a very highly competitive grant cycle, and the county, unfortunately, this year was not selected. We've been basically confirmed we can get a grant next year for that, and we're working off remnants of last year's grant. And then we have another funding source, which is the federal source of U.S. Fish and Wildlife, and we were not selected for that grant fund this year either, due to prioritization for containment programs, which are really important to keep mussels contained in other water bodies and not get to places like Clearlake. But that means that going into next year, this program is going to, we have to get more creative with funds for that. And that's on me. That's my program. Because what I want to do is keep people like Corey and our 15 ramp monitors, which all live here. They work for the program. They live here. They work here, they play here, they spend all their money and all those grant funds that come from out of county into county, and they also protect our lake. So it's my goal and my job to find those funds to keep that program going so we can protect our lake and we don't have to fire anybody in the program. So thanks for that question, Janine. Yay! Okay, other questions? Oh, is the panel ready? You guys ready to take questions? Okay. Please stand.
Yeah, hello. I'm Dr. Jay Holden. I noticed in the first presentation regarding the carp that you included mute swans as troublesome for the lake as carp. I've been studying the handful of mute swans on this lake for nearly 20 years. I represent a group of concerned citizens about misinformation about these swans. Much of it originated with what a U.S. federal court called the government's, quote, shoddy research and conclusions, which led to mute swans being classified as an invasive species and the mass killing of them. And as we all well know, the government can get things wrong. I have with me a summary of our group's independent research and observations, which I will give copies of to interested people here at the end of this presentation, and which we will be glad to discuss in detail in another forum. For now, we'd just like it to be known that swans have been recorded as residing on Clearlake for at least the last 136 years, and that rather than posing a serious environmental problem to our lake, these vegetarian mute swans provide a clear benefit to the lake since their primary food is not tules, but algae and submerged weeds, including the ones discussed here today, which are definitely an environmental problem here. So I just wanted to say that, and I hope for more dialogue about the mute swans and current valid research and observations regarding them. Thank you.
Okay. Was there any comment from the panel for that? Let me just go. Sorry. Was there a question? Paul? Okay.
Yes. Are there any natural mechanisms that limit the quagga mussels, such as predators that could be imported? I guess in the areas where they originate from, somehow they don't over proliferate. And I wondered if there was something that could be employed.
Yeah, currently there's no known predators for the quagga or zebra mussels. Angela, if you want to jump in, go ahead. But I mean, I think there was a study out there was like a red crappie potentially that would eat them. But even if they did, some of these mussels can survive the stomach lining going through the digestive system of the fish, and they would still survive.
Some research has shown that red ear sunfish, did you just say that?
I didn't know if it was a crappie or if it was a sunfish.
It was the red ear sunfish. And actually in our response plan, one of the Fish and Wildlife recommendations was to promote habitat of red ear sunfish, which are not native to Clearlake. But by supporting habitat for red ear sunfish, we could support a healthier population of red ear sunfish, which have been shown to eat quagga mussels and zebra mussels. However, like most biocontrol, when it goes in the real life system, there could be lots of other tasty things out there that they'd rather eat before the quagga zebra mussel. So we don't want to rely on that as our sole response mechanism. Another question?
Hello. Yeah, my question could be silly, but are kayaks also susceptible to these mussels, or is it only when boats have been sitting for a long time? Because the kayaks are hopping different bodies of water all the time, so I was just wondering.
Yeah, thank you for that question. So kayaks are a little bit more simple of a vessel. There's not as many compartments as a fishing boat or a wakeboarding boat. But I don't know if anybody's really familiar, but these kayaks are getting pretty dang complex now. The one thing I can say is if you do have an electric motor on your boat, look inside that propeller. I guarantee you haven't, and I guarantee there's standing water in those propellers. So yes, and if it gets to the complexity of those vessels, but if it's a standard, even like there's no inside cabin kayak, it's typically going to dry out within a 48-hour, 72-hour period, depending on how hot it is outside.
Could we have a follow-up with you, David, for hydrilla and spread with motorized boats and kayaks also, please?
As far as susceptibility, we do, the external border stations do detect hydrilla coming in on boats at times. A lot of the aquatic weeds can get pinched between the boat and the bunks of the trailer. That's one of the locations. The real danger with hydrilla, if you did have a water, some sort of ballast that some vegetation could stay moist in, but boats that have mud on them that could contain tubers are the real problem. Unfortunately, one of the items that one of the ways that we see hydrilla spread is in aquatic nursery stock, like water lilies. Water lily has a bulb that's in a pot that's in wet soil. We also intercept it coming in the pet trade from Asia, oftentimes with like aquaria trade, live freshwater shrimp. They will throw a piece of plant material in there. Luckily, the locations of hydrilla, other outside of California infestations, you have to drive, you know, basically from Texas across Arizona, New Mexico, something like that. So a lot of hydrilla dries out during that. But the tubers, mud and tubers, absolutely hydrilla could survive in. But moving which is illegal anyways, but moving fish around in a live well is any sort of water that could keep the plants moist is a risk.
Hi, this might be a silly question, but regarding the first talk, do you guys have a plan on what to do with the carp and goldfish you remove? Like, what's your plan for after? How do you dispose of them?
That is not a silly question at all. That's actually a question I continue to ask myself, because we have done removal events, and so what we've done here is we'll put them in our garden. So we have an elder's garden, we put them in there. During the winter and early spring, if people want them to eat them, typically that doesn't happen. I'll do that. I'll give them away for people to eat them. There is a fish consumption advisory on Clearlake though, so you can't really eat much of the fish coming from Clearlake. For males 25 and older, you could eat 3 servings, about the size of my palm right here, a week. So you can't eat much. We've looked into rendering facilities, composters and stuff. It's coming to crunch time, and I'm just like, oh man, we're gonna have so many fish. I'm not entirely sure what I'm gonna do. When there was an event where there was like a lot of fish that our garden couldn't take, or local farmers or anything, we just dug like a 10 by 10 hole and buried them.
Does anybody have a cat food factory that you are short on supply? Anybody? Anybody? Future industry in Lake County?
And
Anybody?
I have looked into that stuff, the like cat food and fish farm food. The problem is California can't legally have one, so you have to send them all out of state.
I have a question for the gentleman in the middle. There has been fluoridoid detected in tules, and I'm just wondering if you guys have completed your EIR?
No, the
Does it
EIR
include
has
it?
not been completed yet.
Do you know when?
I do not. I know that we're working on it.
Thank you.
Okay, other questions? I'm on my way. All right, raise your hand again, folks. Okay.
Yeah, I have a question about the hydrilla and the eradication of it, opposed the possibility of toxicity to humans when trying to eradicate it near public water intakes for public water systems and so forth. Has there been studies or issues, or do you do like avoidances of them? I know my water system I work out, we have an avoidance of a 1/4 mile for the primrose and everything, because we get notifications from you where they're going when you guys are doing it. And I do have a follow-up question about zebra mussels as well, regarding, I had a friend that lived in Erie, Pennsylvania, half hour from Lake Erie, and they moved out here, and when they never registered the boat out here, so they have to do the monthly instead of the annual stickers, and they told the people that that's where they were from, and they had never once got searched, their boat, for any type of mussels. They just, he pays the $20 and gets a sticker. Same with me when I bought my boat out of county and brought it here. I told them same thing, and never once got searched when we did the mussels. And I always brought my boat with me, but never got searched, so we just stopped bringing in the boat to when we purchased the stickers as well.
Can you guys address the first question, please,
Sure.
about the toxicity for drinking water?
In regards to water intakes, it is dependent on the label. But yes, typically a 1/4 mile from a water intake is pretty standard. It depends on the pesticide product. In addition, we have a NPDS, National Pollution Discharge Elimination System permit, and we do water monitoring, all of those. But a very important thing for us is knowledge of where water intakes are. We are aware of all of the official water intakes, and those are all built into our system. And I don't believe in the recent years we've had to do any buffering. We've not been within that quarter mile of any water intakes. But yeah, we have the same, it depends on the label. Again, we follow the label for the individual product, but quarter acre is pretty typical of most of the products. And that can go for irrigation and or potable water or livestock water, depending on the label.
We'll do one more question.
I heard a report that the grebes, I heard a report, newspaper friend, that over 100 grebes died on the lake in the last, year? It's been going on for pesticides. So when they did an autopsy, they found that the cause of death was the pesticides, herbicides. Do you know anything about that? Because 100 grebe, that's a lot of birds that are being affected.
Is that a question for me? I do not. We are notified when, and we also participate when our staff, my thing's falling, when our staff notice fish kills, we immediately coordinate with Angela, and then the word goes out to Fish and Wildlife, and we cooperate with them. And they do necropsies, including looking for pesticides. I am not aware of, nothing's come across to my attention for grebes. That's nothing that's reached out to us. I know that they've looked for pesticides and fish kills. But again, typically when fish die, oftentimes it's dissolved oxygen is the issue.
Oh, so for the grebes, we did have a grebe talk earlier, so Donna will comment on that.
You said that you have over 200, you have over 100 grebes that are, dead fish. And that's dissolved oxygen levels. And that's not uncommon.
But confirming there, to your knowledge, there's been no recent case of 100 dead grebes where they've done, okay, just checking, okay.
For anyone here, if you notice dead fish in Clearlake, there is a dedicated project on iNaturalist for Clearlake dead fish. If you could please report it there, that would be very helpful. Thank you.
Okay, thank you. Do the panelists have anything to say to close out the session? Lively bunch. How about clean, drain, dry? Clean, drain,
thanks,
dry.
everybody.
In Owens Valley, and we have an observatory at Yellowstone. We have one in Hawaii. We have one in Alaska, in Anchorage/Fairbanks, and one in Vancouver, Washington, that deals with all the Cascade volcanoes. So some of the other observatories, you know what, before I go on too long, I'm going to start my timer. Usually I talk at conferences, and there's a red light and a green light, and somebody fidgeting next to you if you go even into the yellow. Today I'm unconstrained other than by Mitchell's dirty looks. And so the other volcano observatories really do observe volcanoes and set, they talk a lot with airlines, for example, and decision makers, policy makers based on real threats. We do that in California to some extent, but our volcanoes don't erupt nearly as often. So we get to spend a lot of time doing kind of basic foundational research to understand the past history of our volcanic systems and thus kind of better inform our hypotheses about what they might do in the future. So today I'm going to talk about our kind of recent research in the Clearlake volcanic field and hopefully motivate our decision to start restudying the volcanic field and give you some background of why the field is here. So on the left is a diagram from a 2018 publication that we put out called, I think, something to the effect of California's exposure to volcanic hazards. And each of the little red triangles is, you guessed it, a volcanic system. And those with explosion lines from them are things that erupted in the last 3,000 years. Clearlake is here, and it is red, meaning that we classify it as high to very high threat, but it hasn't erupted in the last 3,000 years. Anybody know the last time Clearlake is thought to have erupted? Yeah, 10, 11, 12. This is bingo. Why do I have a job? So most of the work that was done on the volcanic field was done in the 70s and early 80s as a means of better understanding the geothermal potential of the field, right? This is what our hazard assessment currently looks like for the volcanic field. Probably not inaccurate, not very detailed. Like you show this to somebody that is trying to evacuate schools, if there happens to be an eruption, they're going to want more detail than that. So we're going to go through a quick Geology 101 tectonic explanation for why we have a volcanic field in the coast ranges of California. So the three different major plate boundary types are a subduction zone, a divergent boundary, and a transform boundary. In a subduction zone, we have commonly oceanic crust being subducted beneath a more buoyant continent, and we get a volcanic arc. The Cascades are a volcanic arc. There is a plate being subducted at the Cascadia subduction zone, and you're generating volcanoes there inland of that subduction zone. This is what California looked like 80 to 120 million years ago, and there were volcanoes on top of what is now the Sierra Nevada mountain range, right? That unroofed bunch of granite that crystallized in the crust has now been exposed at the surface. So those are the roots. A divergent boundary, like can be seen at the East Pacific Rise or the Mid-Atlantic Ridge, is a place where crust is being pulled apart, oceanic crust, and you generate melt at those places. That's where we generate the most volcanism on Earth. And then the third is one that we're all very familiar with, I think. If you're in here, you're probably interested in this and know all the stuff I'm telling you. But this is the San Andreas Fault, and it is a transform boundary separating the Pacific and North American plates. The San Andreas Fault does not comprise that boundary entirely. Rather, it's made up of a series of faults, all with about the same movement on them, or the same direction of movement. It's a zone that's accommodating that differential movement. So, all three of those boundaries have been important in the last 30 million years of tectonic evolution of California. So, here's what it looks like up north now. We've got the Juan de Fuca plate being subducted beneath North America. That is what's happening up here. So those little teeth are subduction zones, so Juan de Fuca being subducted beneath North America. We have transform movement of the San Andreas Fault in the North American and Pacific plates. Right here, there is a ridge segment, so that's a divergent ridge, a divergent boundary there, and another transform boundary there, forming the Mendocino Triple Junction. So that's today. Is there any way you can click on that? It's supposed to be a video. Let's see this work. Yes. Okay, pause. Can we pause? All right, I want you to pay attention. So this is 40 million years ago. There's our timeline. I did not make this. I stole it from Tanya Atwater, who made it a number of years ago. She's at Santa Barbara. And it hopefully will be illuminating. So you've got the Farallon plate being subducted 40 million years ago beneath what is going to be California. The Pacific plate is moving in this direction, the Farallon plate is moving in that direction. The North American plate in this animation is held fixed. Cool? So let's watch this segment right here. So that is a ridge segment. That's a divergent boundary. Cool? Hit play. As we go through time, let's watch this. Do it. Oh. Yeah, how you've demonstrated your ability. Is there something I can hit? No, probably not. Maybe. Nope, I'm useless.
Go back to the slide before.
I like this idea. All right, so genius, 10 points. So you see that right here, right there, that ridge intersects the continent at about 30 million years ago. And then as the Pacific plate is pulling that north, the subduction zone is moving north, and that triple junction is migrating north. So 30 million years ago, we began subducting a segment of ridge, and there is volcanism occurring at that ridge. When we subduct it, that volcanism is shoved underneath the continent. And instead of getting volcanoes like a subduction zone makes, like Shasta and Lassen, that are inboard of the coast, that ridge segment, hit go again, that ridge segment produces volcanism right near the coast. So right along the coast, it hits 30 million years ago. Anybody know any volcanic rocks in like San Luis Obispo area? Morro Rock, the Morro Islay Hills, the Berkeley Hills, Pinnacles, Quien Sabe, all of those are related to triple junction migration and a slab window, i.e. subduction of a ridge segment. And so those volcanic fields are oldest to the south, and they get younger as you come north. Clearlake is the youngest of those systems. It began erupting about 3 million years ago and has continued erupting, although not continuously, until about 8,000 years ago. So, oh, hey, look, I did it that time. Let's watch it again. What the heck? So, boom, San Luis Obispo, we start migrating volcanism north, and we get these little bits of volcanism occurring near the coast throughout California in the coast ranges. And Clearlake is the youngest. Moving on. So this is a map published, like in 2000 or so. All of these dots, or squares and circles and triangles, are places in California where quote-unquote triple junction rocks are exposed. So there are little bits and bobs of this volcanism all over California. Superimposed upon this are larger volcanic fields, of which Clearlake is one. So this is a bunch of text. Don't look at it. I stole this slide from a colleague, and she doesn't know what she's doing. So here's the plate boundary. That is the southern edge of the subducting plate as it moves northward. 12 million years, 9 million years, 5 million years, 2 million years, 3 million years today at the Mendocino Triple Junction. So the southern end of that Gorda Juan de Fuca plate. Here's the Sonoma Volcanic Field just south of us. Mount St. Helena is part of that. And here's the Clear Lake Volcanic Field where we are. So why do we want to come back and spend a bunch of, well, a little money and a bunch of time? That's how this really works. Studying the Clear Lake Volcanic Field. Well, Clear Lake is the closest big system to the Bay Area, and there are a lot of people in the Bay Area. I work for an organization that is charged with understanding threats to population and infrastructure from volcanic eruption. So Clear Lake sticks out like a sore thumb. There is active geothermal potential at Clear Lake, right? You guys are all familiar with the geysers and all of the energy that they produce. It's had a long history of eruption. 3 million years of volcanism is not insignificant, even in geologic time. We've got recent eruptions, there's seismicity in the area, and we sit right within this giant zone of the boundary between the Pacific and North American plates. So it's a seismically active area as well. So we want to better understand the past of this volcanic system so we can better understand what it might do in the future and what hazards might be associated with future eruption. And when I say future, I don't mean this week or within our lifetime. I have the luxury of being a geologist and understanding time on a broad scale. So 100,000 years or so, 10,000 years, 5,000 years. That's kind of the time scale we're talking about. But we've convinced Congress to give us money to study this stuff, so let's all just pretend that it's imminent. So the Clear Lake Volcanic Field, we've segmented its eruption into 4 different, we call them episodes. And it's just an easy way to bin what is occurring through time. So eruptive episode 1 is in green, and these are all of the rocks that you see as you go south down through Middletown, out like Butts Canyon. You've got these hills that are capped by lava flows. So there's all these little bits of lava up at the hilltops, and those erupted sometime between 1.3 and about 3 million years ago. That's the oldest stuff in the volcanic field. And it stretches all the way out to Berryessa, and then as you come north toward the lake, the lake. It's here shown. It doesn't show up really well, but there's Yoke's Arm there, and here we are up off the map. So that's episode 1. Episode 2 is in yellow, and that's Cobb Mountain and those rocks kind of around the southern end of the volcanic field. And about 1 million years ago or so, that was active. After that, we built what is kind of the hallmark feature of the volcanic field. So that would be Mount Konocti and all of those intermediate composition volcanic domes. So all this stuff, I don't know. A phoenix rising from the, we can only guess. It's gone. So episode 3 are all of these intermediate volcanic rocks in orange. And then episode 4 is the youngest stuff. Go. It's not listening to me. Can you advance the slide? Episode 4 are all the youngest rocks in the field, and those in composition are very similar to the first stuff to have erupted starting around 3 million years ago. So these are little lava flows up on Konocti. They are some flows in High Valley, the cinder cones that you see quarried around the lake in different spots. And there are also Mar deposits. M-A-A-R is an eruption that occurs through lake water. So around the peninsula here and Soda Bay and Horseshoe Bay, there are kind of crater-shaped features around the lake. They're craters, and they were formed when lava interacted with water, flash boiled that water, and you get a little Mar crater. So I think I've already gone over this. This is my colleague Danica. She's the one I stole that slide with all the text from. So if you see us in the field, tell her to tighten up her slides. And the other reason that we really want to study Clearlake is because the field just to the south, the Sonoma Volcanic Field, which was active from 8 to 3 million years ago, stretches all the way down to San Pablo Bay. We're most familiar with it because of all like the Palisades in Napa. Those are all welded ash flow tuffs. So big explosive eruptions that produced ash. Clearlake has not done that in its lifetime. There's one pyroclastic eruption in Clearlake, the Bonanza Springs. It's about 1 million years old. But the Sonoma Volcanic Field is characterized by multiple caldera-forming eruptions. Big eruptions, certainly relative to Clearlake. If Clearlake is maturing toward that end, we really want to know that. So Clearlake thus far is not characterized by those eruptions, but the volcanic field generated by similar tectonics to the south is. And so it seems as though that's at least a possibility for Clearlake, and we really want to constrain the probability of that possibility. So what are we doing out here? Here's a map of the geology. This is taken from the geologic map by Hearn and Donnelly Nolan and others that you guys can get online. All of the yellow symbols here are places that we have sampled rock. We've been all over the place in the last 3 years in a little blue Ford Ranger pickup, myself and Danica, and we are kind of throwing the kitchen sink of analytical capabilities at our observatory at the volcanic field. So we're doing basic geologic mapping. We are doing lots and lots of geochemistry to try to understand where these melts were formed in the crust and how the chemistry changes through time, so we can compare it to other volcanic fields and see whether or not there's some characteristic life cycle of these coast range fields and whether or not that is some sort of a predictive help. We're doing lots of petrology to do many of the same things, kind of understand the plumbing system of the volcano. I myself am a geochronologist. I use radioactive isotopes of uranium to date rocks to put together a comprehensive eruption history for the volcano. So did it erupt constantly through time? Has it just been a leaky faucet, or did somebody shut the water off and let it build up in the crust and then you get something big, right? Understanding the behavior of the system through time is really important to understanding what it might do in the future. We've got folks doing geophysical surveys, trying to understand, use seismic and gravity and magnetotellurics to understand what's happening in the deep crust, like from the mantle all the way up. So understanding the plate geometry and how that controls volcanism at the surface in space and time. We've got folks doing gas sampling in the lake, looking at hydrogen sulfide and primarily CO2 gases in the lake, around the lake, And then we've also got people doing what's called paleomagnetics. As a rock cools, the high aspect ratio minerals within it align with the North Pole of our Earth, which is just a giant dipolar magnet. And we can use that to tell time in between the spots where we can actually date the rocks radiometrically. So we've got a lot of nerds all working together on this project, of which I am proudly one. And we've been working a few years on the project, and we have a few years left. So here's part of the team and kind of what we're doing out in the field. And what we're producing are peer-reviewed publications, because that's the metric by which our performance is measured in part. So we're generating new science on the volcanic field. We are going to publish a hazard assessment, which is kind of the product that we most commonly produce at the observatory, which will be publicly available. And we'll hopefully communicate what we think the probability of future hazards, where those hazards might occur, and what they'll look like to the public and to the folks making decisions on behalf of the public. We're also building a website that is maps-based, so it's kind of like if you were to Google restaurants in my area, a bunch of different things would pop up and you could click on them. That's kind of what this website will be. You can find where your house is. It'll tell you what rocks are on it, and then there will be virtual field trips to take through the volcanic field. Kind of cool. It's in the nascent stages, we'll say, but we're working on it. And then we also are interested in doing a whole bunch of outreach, talking to the community about the volcanic rocks that they live on. Not necessarily just the hazards, but I mean, we're all fans of the rocks, so that's what we want to convey. And then what I'd like to do with much of the rest of my career at the USGS is march my way south through these volcanic fields to give the same treatment that we're giving at Clearlake to the rest of the volcanic fields, and kind of understand the tectonic picture holistically. It's very interesting to me. So this didn't come through, unfortunately. I think it's the most important slide. It's a huge thanks to all the landowners in this area and our partners, whether they be folks at the county or vineyards. We have had such amazing luck and amazing conversations with folks that are interested in the rocks on their land and smile at us and shake our hand and say, yeah, go ahead, you idiot, go bang on the rocks in my backyard, I don't care. And I'm like a kid at Christmas when I get a bag of rock that I've wanted for a while. So there's got to be folks in this audience that have rocks in their yard that they're interested in. Come talk to me about them, because I guarantee I'll be interested in them too. So thanks to everybody in this community. I'm going to wrap up by saying that last night I had a poster, and it's characteristic of this area, and I've worked all over the world, and there's something about this area that attracts people that are interested in science and care. And so I've had more fun conversations with interested and knowledgeable folks in this community than I have anywhere else. So I'm hoping that the feedback process between the products that we create and that you will be using is a two-way street, because I'd really like to get them right so you guys can lean on them when you're talking to folks about what you're interested in. And I will shut up and take questions now or at the end. Right now, questions, bring it on.
Thank you very much, Seth.
Yes.
If anybody has any questions, feel free to raise your hand. I will come by.
Oh.
Seth, I have a question.
Yes.
At the Triple Junction, is it either the Farallon or the Pacific Plate that's subducting underneath that east to west line? Or is that just a colliding, crushing?
So the Farallon Plate is gone.
Okay,
it has been subducted, but yeah, in north, the Juan de Fuca and Gorda Plate are being subducted. That's what's creating all those Cascade volcanoes. And there's a big effort right now geophysically to try to image where the plate that's south of the Triple Junction exists underneath the continent. So it was subducted, and the leading edge of that spreading set. I talk with my hands, and it's very difficult to get. I want to draw on a whiteboard, like that's my go-to. But the leading edge of that ridge segment that was subducted is somewhere beneath California now, up there. Oh, do I have it? Maybe I have. Let me be the most prepared human. Yes.
So those horizontal lines, as it
all of
progresses.
these lines You can't see the numbers. That's 20, that's kilometers depth. That's 400, that's kilometers depth. So the Gorda Plate is being subducted underneath North America, and the edge of that plate is about right there. So that's a drawing of the geophysically imaged subducting plate. And the stuff to the south, that spreading ridge, is somewhere off in here. It has been subducted, and we don't, people are trying to image it with geophysics to see where it is.
But as those horizontal lines in the ocean move northward, is the Pacific Plate, I guess, subducting underneath those horizontal lines?
Yeah, the Pacific Plate is outboard, and there's a ridge segment right out here that's separating the Juan de Fuca and Gorda Plate. So in time, just like the Farallon Plate was consumed, the Gorda Plate and Juan de Fuca plates will be consumed, and you will be subducting either the Pacific Plate or the San Andreas Fault will have grown all the way up there. So 30 million years ago, the San Andreas Fault didn't exist, right? It is growing in the wake of the migrating triple junction. People are nodding. I don't know if I believe you. Yeah, so people are like, yeah, sure, bud, shut up. So,
but since the Pacific Plate is moving northward,
yeah.
Doesn't it subduct underneath that horizontal line at the triple junction currently?
No, there's a transform boundary there. Well, I'm going to take one more quick question because we've got to move on. And then you can talk to me after, and I will wave my arms for hours.
Sure.
I think the gal over on the right with a striped shirt on, yeah, go ahead. She had her hand up first. She was quick on the draw.
Thank you. A few years ago, I attended a committee meeting, which you know how government loves great acronyms. It's the SMAC committee, which is the Seismic Monitoring Activities Committee. And Calpine was there along with USGS, and one of the things that they mentioned at that particular meeting was that the geothermal injection of of the treated water and the extraction of steam does cause earthquakes.
Sure.
And one of the members from Calpine said, or USGS said, as long as the Maya-Camas fault line doesn't nucleate right there at the geysers, you won't be blamed for it. And so my question is, do all of these small man-made earthquakes at the geysers geothermal area help release the pressure on the Maya-Camas fault?
That's a good question.
Thank you.
Yeah, so I am not a seismologist. If anybody is, they can tell me to shut up and they can give you a good answer. But I would say no. I would say that that there are different systems, and that the seismicity induced by injection at the geysers is shallow and localized around their injection sites. And the propagation of that energy to catalyze an earthquake on the larger Maya-Camas system is probably not reasonable. So I don't think the two are related, but it's really a question to ask a seismologist, not a geochronologist. That's the answer I'll fall back on. Good question. All right, I'm out of here.
All right. Thank you very much, Seth. All right. Can everybody hear me okay? Should I lift this? All right. Well, I'm Mitchell Breedlove. I'm with the County Lake Water Resources Department. I oversee groundwater management, lake bed management, and water rights, things like that for the county. So we're going to talk a little bit about the county's efforts and monitoring programs that we do. So I'll do a little overview. We're going to talk about what a groundwater basin is, for those of you who don't know here in the room. I'll hold it. All right. We're going to talk about the Sustainable Groundwater Management Act background, and then the county efforts and support that we do. So we'll start off here with key definitions of what a groundwater basin is. And you can see it here. It's an alluvial aquifer or a stacked series of alluvial aquifers with reasonably well-defined boundaries and a lateral direction having a definable bottom. So then we can break a groundwater basin down into a groundwater subbasin, which is created by dividing a groundwater basin into smaller units using geological and hydrologic barriers or institutional boundaries. So let me get some notes out here. I apologize. I'm nervous. I haven't spoken to anybody, this many people in a long time. So. All right. Well, so what we'll do is we'll define a confined, semi-confined, and an unconfined aquifer. And what a confined aquifer is, and you can see that here, is an aquifer below the land surface with layers of impermeable material above and below the aquifer. And an unconfined aquifer, which you can see in this location here, is an aquifer where groundwater is in direct contact with the atmosphere through the open pore spaces of the overlying soil or rock. And a semi-unconfined, which you'll see here, is partially overlain by rock formation which has low permeability through which water can pass only slowly to recharge the aquifer. And in terms of what a water table is, that would be the upper groundwater surface of an unconfined aquifer. So the county has 7 main groundwater basins within the county's jurisdiction. And I'll touch on Big Valley here down a little bit, but we'll start here. We have Scotts Valley aquifer over in Scotts Valley on the western side of the county. We have Upper Lake Valley, Long Valley, High Valley, Burns Valley. And over here on the right down in the Middletown area, we have Coyote Valley and Koyama Valley. I always struggle with that name. So let me go back here. The reason Big Valley, and you'll notice the difference, red or non, these are monitoring wells that we no longer monitor in red, and the green are ones that we monitor. And I'll be getting into some more details on this. But the Big Valley Basin here, you can see there's a lot more that we monitor in this area, and I'll get more into that here soon. So what are our measuring methodologies? So we have electronic sounders. So this is a easier, faster, simpler way to monitor groundwater. You stick this down a well casing, and then when this tip of the probe touches water, it creates it conducts and it makes a noise, so we know. But these are not as solid because you may hit the side of a casing and it may hit water early and it will beep. So you have to be careful on what you do. And then you have a still tape here, which is a lot easier, but it takes longer because you have to go down past the wetted, like last measurement that you've had in the area to make sure that you've gone deep enough. So we'll get into, so this is the CASGIM, which is the California State Groundwater Elevation Monitoring Program. And so our readings that we get from the electronic sounders or the still tapes go into this website, which the California State has created. They created that in 2009, and that's to track seasonal and long-term groundwater basin levels. The program's mission is to establish permanent locally managed. The state really wants to maintain local control in the area. They don't want to have to come in and monitor things. They want the local to be in charge of that. So all of our readings, which we do on a biannual basis, and I can go back to these slides. So in Big Valley, we monitor 10 wells monthly. So we do this one monthly. And then these other ones we only do biannually. We do a spring reading and a fall reading. So some Sustainable Groundwater Management Act, otherwise known as SGMA. We like to use a lot of acronyms in the groundwater world. So if there's any later on, you can come and ask me that I may have missed. But in 2014, the Sustainable Groundwater Management Act was formed, and let me get my notes here. This was formed by Governor Jerry Brown, signed into law, 3-bill legislative package comprised of Assembly Bill 1739, Senate Bill 1168, and Senate Bill 1319, otherwise identified as SGMA. And SGMA requires medium, high, and critically overdrafted basins to develop a groundwater sustainability plan in an effort to ensure the groundwater basin reaches sustainability within 20 years. So that's this. Of our 7 groundwater basins, our major ones, only the Big Valley Basin 5-015 was determined to be a medium priority basin. So that's the one that had all of the monitoring wells. That's part of the reason that we have so many there. So we'll get into the definitions of what Big Valley Basin is here. Sorry, I think I missed it. So for those of you that don't know, the Big Valley Basin lies south of Clearlake and includes Kelsey Creek and Adobe Creek, which both drain into Clearlake. This is a source of water for the community of Kelseyville, as well as much of the agriculture in the county. This is the largest agricultural area in the county, and the basin is considered to be 6 miles wide and 8 miles long. So we can talk about some implementation here. The Big Valley, over here on the left, we don't have the dates, but in 2014, this is when SGMA went into effect. In 2016, 2017 was where some of the first GSAs were formed. In 2019 is when the Board of Supervisors, sitting as the Board of Directors of the Lake County Water Resources Department, established the Big Valley Groundwater Sustainability Agency, which is led by myself within the Water Resources Department. From there, we applied through the district for some Prop 68 funds in 2019, 2020 for about $1.4 million to develop a groundwater sustainability plan, as our basin was determined to be a medium priority, and we were awarded that money in 2020. Through 2020 to 2022 was the development of that plan. The Board of Directors appointed a groundwater sustainability advisory committee, and that is comprised of local water purveyors, tribal nations within the area, myself at the county, and we have some environmental agencies that are included. So in 2022 and 2023, we submitted this GSP, and it was adopted and accepted from the state with some recommendations of things that we can do to ensure that we're reaching sustainability. So what are our next steps? So we're into the implementation phase now. So our GSP was developed, and now we have to implement the projects and management actions of which we determined within that plan. So we're in the implementation phase, as I mentioned here earlier. Some of the next things are we're extending our facilitation support services, which I'll get into a little bit on the next slide, I believe, which is a program through the Department of Water Resources. It's free, it's no cost to us at the county, and basically we have facilitators that come in and help us do public outreach. We have advisory committee meetings. That's on a quarterly annual basis. So every 3 months we meet with those entities that I talked about earlier, and these are the people that helped draft the GSP, and now they've moved into the GSP implementation. Another thing that we're looking for is seeking long-term funding mechanism, and then in 2027 is our 5-year update that's required. So these are some of the scopes that our facilitation support. Stantec is the company that has been consulted by Department of Water Resources, and we currently have these 3 items here that are included in our current services till the end of August, and we just heard that it's been essentially approved, and we're finalizing our draft to continue these services from the end of August, September through December. And some of that is continuing to help us with the groundwater sustainability advisory committee meetings, Board of Supervisors updates. So if anybody misses this, I plan to be in front of the board within a month or so to have a much deeper depth of what's going on in the aquifer and so on and so forth. We have quite a few vacant seats that were determined in our advisory committee. A lot of that is underrepresented users. We're also looking for domestic well owners in the area to be a part of this committee. So if anybody's here that is a domestic well owner and wants to be involved in this, please reach out to me after this, and we'd love to get you on the advisory committee. We plan to do a tribal workshop, underrepresented groundwater user workshop, so that we can reach out to the people that may not be able to make it when we have our meetings. We tend to have them in the middle of the day on a Friday, and we're looking to change that to in the afternoon, later at night, for people that work during the day and don't have the privilege to being able to leave their work and join us for the meetings. So within the GSP, they determined, and this wasn't done by any other GSP throughout California, this was unique to ours, they preemptively determined a tier list of project and management actions for our GSP. Currently, the Big Valley Groundwater Basin is considered to be managed sustainably, so there are no tier 1 management. However, remember these next 3, as I'm going to be getting into some more details of what those project managements were for tier 1B, which was to otherwise comply with SGMA to fill data gaps and support the GSA. Tier 2 is to improve management, contribute to achieving measurable objectives, and tier 3 is to support wider water management. So I know there's a lot going on this screen. I'll try to go through them as briefly as possible. One of the first ones, so this is tier 1B, So this is things that don't need to happen, but things that we want to help achieve sustainability. Is we have the expand the well monitoring network and data collection. This is a big one. It's talking about installing some representative monitoring wells. We have gotten some support from the state Department of Water Resources. They have fast-tracked 2 wells that they're planning to input, and I'll talk about those 2 at a later slide. But we've gotten one of those wells implemented in, and that also kind of touches on the next one, which is improved understanding of relationship between surface water and groundwater, which also Valerie will be talking about next. As we all know, a big topic of conversation with the Clearlake Hitch and all things we want to know, okay, is pumping in a near to a stream going to reduce the surface water within that stream? So we have some wells that are being put in to help determine that. Conducting an RMS of the well's baseline water quality. Currently, the county monitors 6 wells within our Big Valley Basin on a quarterly basis, and so we're doing that. Some of these are cost estimates that were developed when they were developing the GSP. They're not factual, like for sure this is the cost. It could be more, it could be less. Another thing here is the state did a airborne electromagnetic study all the way across the state of California, and basically they had this helicopter that flew by, it shot down electromagnetic, and then the bounce and the feedback from that, they were able to determine what the geology below the surface is to a specific depth. So the Department of Water Resources had that study, and we plan to integrate that study into our hydrologic modeling that we use for our GSP. On the right, we have a domestic well management program. This is to help with well reporting, any dry wells, things like that. We do have a website. This was created prior to that website being implemented. That is within our County Lake Resources website. And then public outreach. We're getting help with facilitation support. So we'll move on to the Tier 2 projects, and many of you may have heard about a number of these things. But the big one here is implement the Adobe Creek Conjunctive Use Project. When that project was written back in 2001, 2002, the big focus was on groundwater recharge. That's not necessarily the biggest focus of that project anymore. A lot of it's going to be swapped to potentially providing supplemental flows during low water seasons to provide flow for the Clearlake Hitch. However, we're dealing with a lot of water rights issues on that. As you know, we are within the Delta water system, and so people downstream in the Central Valley also will protest what we do or what we choose to try and get here. The next big one is rehabilitate the Kelsey Creek detention structure. We do have funds to utilize this. However, we have not found a contractor yet and solicited that bid. Basically, this structure, the engine pulled up and out of the foundation of that, so we're no longer able to close our impounding gates and provide groundwater recharge. Another big one that I would love to see, and these are all ones that are just if we get to them, is improve water demand estimates. As you know, cannabis is a big thing in our area, specifically Big Valley, with it being a big agricultural area. Being able to determine what a sustainable yield is for those operations would be fantastic. Investigate recharge locations. That's a big one. We have some funds through DWR they have some assistance to help us with that. And then investigating stormwater capture reuse. This is a big one that our department is doing a stormwater capture plan, and this will be part of that. And some of the last ones is reestablish wetland and riparian habitats. One of the big ones there is the Middle Creek Restoration Project. If you're not familiar with that, I believe there's going to be a talk later on today on that. So you can see that this comprehensive list kind of included a lot of the different science that has been talked about here this week, which is great because we don't have to rely upon the people within Big Valley to be able to put these projects and management actions into place. We've been grateful for all the grant funding that we've gotten. So I'll talk a little bit about the monitoring wells. On the left are the proposed sites that we had submitted to the Department of Water Resources. This is also within our groundwater sustainability plan. And you can see here the preferred locations, 50 feet, 200 feet, and 2 transducers. So there's 2 completions on those wells. And on the right, you'll see here we have the Kelsey Creek location. That is directly east of our Kelsey Creek detention structure, which is a fantastic location. Our Water Resources Department owns that piece of property. We were able to install that well. That well, they drilled to 320 feet of depth to take samples. However, they screened at 160 to 180 feet for one completion, and the other completion is 60 feet to 80 feet of completion. I know that this week, as we're speaking now, they are inputting some telemetry on that well, and there's going to be a website that that data will be uploaded to, and I believe it is hourly readings. They may be able to do it more than that, but I believe currently they're going to do hourly readings. And then next week, we are starting, through the help of Department of Water Resources, we will be starting drilling a well here at Argonaut and Highway 29. That's basically behind the, I cannot think of it, Rainbow Ag. Yeah, basically behind Rainbow Ag, right at Highway 29. It is a Caltrans right-of-way parcel, so it took us a little bit of time getting some permitting there through Caltrans to allow this to be in there. But this one, I believe they plan to drill beyond the 300 feet, which Seth, I think, will be pretty cool because they are anticipating that they hit a volcanic ash layer. So I will keep in contact with you if they plan to still go that deep, then I will let you know if they do hit it. So anyways, that's basically it for things that we're doing. There's a lot more in depth. Feel free to ask me questions. If you want to stay involved, the best way is to join us at our Groundwater Sustainability Advisory Committee meetings. These are open to the public. They are streamed to the public via Zoom. Our advisory committee is in person. We meet up in Conference Room C, the third floor of the Lake County Courthouse in Lakeport. And these are our next dates that we plan to have these meetings. So it's the second Friday of each month from 11 a.m. to 1 p.m. If you want to be involved, this is a great way to be involved. And as I mentioned, I plan to bring something to the Board of Supervisors in the near future. So thank you guys.
I think we have time for a couple of questions.
On your advisory committee, are you only interested in the domestic well user that's on a alluvial plain aquifer, or will a fractured rock aquifer do?
Either one will do, as long as you're within our Big Valley Basin.
Okay, I'm in your basin, a Big Valley Basin?
Yes, yeah, so that would be this basin, let's see, this basin here.
Oh.
Kelseyville, basically
Oh, too bad.
Yeah.
Okay.
Yeah.
Geez,
Now,
I
it
had a
does reach a little
monitored
down
well and
here.
everything for you, so.
Okay.
But no, it's on the other side of the lake. Why aren't you guys interested in our fractured rock aquifers? Good question, right?
And that's great, yeah. Thank you.
Any more questions? One more.
So I see the Big Valley, and there's another basin, and maybe it is the Fractured Rock Basin, but there's been a significant amount of vineyard development in what I would call the Red Hills winery appellation. From the groundwater studies I've looked at to do some environmental review a while ago, it seems like the groundwater is moving down the Canocti Bay Fault Zone. The big neighborhoods in this lake all get our water from the lake. And nobody's really talked about because it's been significant development from native chaparral and dry farmed walnuts. I think if you were to take a drone flight from the top of the Glasgow grade to almost to Kelseyville on the south side of the mountain, it's significant, more significant than sometimes is a visual from just driving down the highway. Because the big neighborhoods get their water from the lake, I think it would be of interest to understand the effects of some of the ag development on the water that may or may not be moving through the Canocti Bay Fault Zone, because if that's a major water supply for a significant amount of the residential development that was there first, then we have to beg the question, in a massive drought, if the lake, and people say could happen, but it's a very shallow lake, in a significant drought, we might be out of water in the actual lake itself, and therefore no water for the residential development. And yet I have never, ever really seen a discussion on that particular area. Is that going to be something that is looked at?
Potentially, I would love to look into that. What we've based a lot of our monitoring stuff on, I'll go back here to this one here. So you're talking kind of this area, right? Red Hills.
Yes,
basically
yes,
this area.
yes. That, and
So-
then the Kanakta Bay Fault Zone goes right into the lake, which I would
Correct.
assume is delivering some groundwater, and maybe even groundwater that's been there since the last ice age, possibly. I don't know. I'm not an expert.
Yeah. I'd love to reach out if anybody has a well in that area and I could monitor. It would be outside of what we do. These are all groundwater basins that were determined through the State Department of Water Resources, through one of their Senate bills. And this is what they determined to be many of the groundwater basins, and so that is what we are required to monitor. That's why we haven't looked elsewhere. And a lot of our priority focus, as I mentioned, is here in the Big Valley because of the medium priority. But I'd love to maybe go out and monitor somebody's well on a monthly basis or even biannually in those areas. So if you know of anybody, please have them reach out to me. Yeah. All right. Well, thank you guys.
Really happy about the previous two talks because I think they've set up my talk pretty well. So thank you very much, Seth and Mitchell. I think I've got a nice lead on. That is not my talk. My name is Valerie Zimmer. I'm with the State Water Resources Control Board. And I do have a talk. It might be a slightly out-of-date one. Don't read it over here because I think I recycled the first slide. And I wasn't actually sure today what my audience would be if they'd all kind of seen my stuff before. And as you can see, we've been sort of hyper-focused on the Clearlake Hitch. Let me get my flicker. I would have added a slide on the why, right? My whole title is all about why are we interested in surface water, groundwater interaction? Stand by the podium. I'm in the way. Okay. I can do that. And I didn't actually have a slide on this, so I'm just going to tell you really quickly why. We got involved about 1.5 years ago when we were informed that. How many of you know what the Clearlake Hitch is? And how many of you don't know what it is, actually? So most of you know what it is, I think. The Clearlake Hitch is a fish. The fish is endemic to Clear Lake. This fish spawns in creeks. It comes up every spring, and it spawns, and then it returns back to the lake. And the fish is in trouble. And that's all I'm really going to say about the Clearlake Hitch, because there's a whole session on Clearlake Hitch following, so I'm going to sort of tee up what's happening. In the next session, you'll learn more about this fish. But the point is that they spawn in the creeks. And so we're really interested in what's going on in the creeks that the fish spawn. And that is the why we've gotten involved. So we have all these questions about, what's going on with not just the creek flows, but also what's going on, how does the groundwater affect this? And so the first question is, how does the water table depth affect stream flows at different locations in the Clear Lake region? How much does groundwater pumping affect the water table depth? In the past or the present time. What that means is in the past, was last season's pumping, does that have an effect if we don't have a good winter on the next spring? We don't know. What else affects groundwater levels and stream flows? We know that there are, legacy effects of gravel mining, of, incision of the creeks, that sort of thing. Like what else is going on that might be negatively impacting the stream flow? And then the last question, we're obviously interested in how do we address this, right? We want to, if we're going to do something about it, what do we do? What makes sense? What doesn't make sense? And so just a real quick, telling you a little bit about how groundwater and surface waters might interact together. The streams in Clear Lake kind of do both of these things. In the spring, when the water table's really high, your streams are flowing, and as they go downstream, they're getting bigger and bigger because they're gaining water from somewhere. They might be gaining water from tributary creeks, but they might also be gaining water from the groundwater. And so think about springs, right? As you come into the spring, you get springs, and as you go downstream, the streams get bigger and bigger, and they flow into the lake. But at some point in the season, that sort of switches, and what that means is that if you go up into the hills, you'll see flowing water, especially in Kelsey Creek and Coal Creek, but when you drive into the basin, those creeks are smaller and sometimes even dry. And so this is a condition that depends on the groundwater level in this area. And this is natural, by the way. The fact that these dry up is a natural condition. And so it is more of a matter of timing, right? Are these creeks switching from gaining to losing earlier than they should be? And if they are, why are they? And that's kind of where we're concerned. We're not talking about keeping them wet all year round, because that's not natural. And so here's an example of what that means. We've got, this is Kelsey Creek, this is Big Valley. These are two gauges, a USGS gauge in the hills and then a DWR gauge down in the basin. And the colors sort of talk about where the hitch are spawning. In this case, the red is like the hitch like to use Adobe Creek. They like to use Kelsey Creek, but then they kind of get stopped here in Kelseyville, and I think we're going to talk about why that is. But anyway, there's water up here. There's sometimes not water up here. And you can see this is 2023, and this is a spring, and you have the DWR gauge, which is downstream in the red, and then the USGS gauge, which is upstream in the blue. And what you can see in the early spring, this is April, is that the red is above the blue, which means as you go downstream, there is more water. And then at some point, right around the mid-May, that switches, and now at the end of the season, you have more water up in the hills than you do downstream, and eventually near the lake, it dries up. And so this is what we talk about when we're talking about gaining and losing systems. And so in most years, this is what you see. But in some years, we see something else. And droughts are obviously a concern. And I want to draw your attention to sort of this again, this red and blue, right? This is the blue, this is the upstream gauge. In both of these years, you can see that there is more water the entire spring season than there is downstream. In other words, the stream is never gaining in 2015. And one of the things we notice about the groundwater levels is that in March, usually in March, the groundwater is as high as it's going to be for the whole year, right? Because you just had all this rain. In most Marches, you see pretty high groundwater levels. And so in 2015, we had a moderate groundwater level. We didn't have a high groundwater level, but it wasn't terrible. And the other interesting thing is that the lake level was 4.5 feet. And those of you who live in the basin probably understand what that means. The lake has a gauge on it from 0 to 10 feet, roughly. And at 0, the lake is like super low, right? It's when it's super dried up. And at 10 feet, we're worried about flooding right here. So, this is a moderate lake level, kind of in the middle. And this year, you can see, like, even though it's losing, the stream kind of holds water all the way until about May 30th. And that's actually not bad. That's actually, maybe that's enough water for the fish, because you have hitch coming in say, April and May, and they need a few weeks. But if most of them can get back to the lake in May, then in a drought year, that seems like a win, right? I mean, that might not be great for a non-drought year, but for a drought year, that seems great. But you see a very different situation here in 2022. 2022 is really bad. You have a low groundwater level in March. The lake level was less than 1 foot. I think those of you who live in the basin can probably talk about how low the lake was, but it was really low. And what you can see down at Kelsey Creek was that the stream just wasn't really flowing at all. Like it's dry, dry, dry. Oh, there's a little rainstorm, it flows. Dry, dry, dry. Another rainstorm, it flows. It just basically wasn't flowing unless it was actually raining. And so that's not, obviously the fish can't use that, right? If we have that going on, if there's no water down by the lake in Kelsey Creek, the fish they've got nowhere to go. And even if they get in there in this storm, they don't have enough time to hatch and to get out back to the lake. And so this is a season when the spawning run would have failed. And so we're concerned about this. Obviously we're just starting this project. We just got involved 1.5 years ago. So when I'm showing you these very preliminary results, this is why I have a caveat. Like, we're still looking at this, like what's going on. And Mitchell, do we have this was supposed to be is this a PDF or is this this is supposed to be an animation. Well, okay. It's a GIF. Yeah, it should just, okay. It's supposed to be an animation. If it's a PDF, it's not going to work. If it's a PowerPoint, it should work. Yeah. Seems like I don't have any. Yeah, it's not it just runs without a button being pushed. Yeah, okay. It wouldn't run on a PDF. That's why I was, okay. Yeah, all right. Well, anyway, I will show you this animation at some point later. What you would see is that you would see the groundwater levels, changing over time, which is too bad. This is a pretty good little animation I have here. These are all of Lake County's wells. There's a few more up here, but they're like what I call the highlands. And so I have a hard time interpreting that data, like what's dry and what's wet. But in this case, you can see how does the water table change seasonally. what you would see is these colors would change on this animation. You would see kind of blues in the springs and the wet season, and then it would go to red every summer. But then you can see the drought years, it's a lot more red, and in the wet years, it's a lot more blue. And so seasonally, we have high groundwater in, lowest in the fall and highest in the spring. But in drought years, you might not see that recovery into the spring. And so this is one of the things that we're trying to figure out is what's going on. And again, this is that long-term county monthly data that Mitchell was talking about. We see, they're collecting data every month, and this is fantastic. They've got a really long record. There's a whole bunch of wells. They've put a lot of those wells online, which is fantastic, so you can go and look at it. I need to talk to Mitchell about getting the rest of that data because I'd like to see all around the basin. And by the way, I want to apologize for just focusing on Big Valley. We're not just interested in Big Valley, but that is just where most of the data happen to be collected, and so it's the easiest to show, to tell a story. But here's what we see. The problem is that we don't see everything. Big Valley EPA, that's Big Valley Rancheria, Sarah Ryan and her staff, were able to install some continuous monitoring devices. This is, I think, every hour. And so these devices are out there collecting samples every hour. I believe this well is actually, is a well that somebody's using. But you can see there are these kind of interesting groundwater drops, and we're not seeing this in the monthly data. I don't know if this is happening all over the basin, or if this is just a weird spot. I don't know if this water that's being taken is the reason you see the slope that's descending, or if that's natural. These are open questions, right? This is what we're trying to figure out. Like, is something that's going on here causing it to dry up later? I don't know. Or is this just a weird spot? And so we would like to see more of these continuous well fluctuations, because there's stuff going on that we're not seeing in the monthly data, even though the monthly data is fantastic and has a really long record, and we love it. And so, how are we answering these questions? We're doing some data collection and background research. We're doing some ongoing monitoring. We're doing some analysis and model building, and we did an emergency regulation and information order that I think some of you probably are aware of, and I'll talk a little bit about that. Really quick, geology. I'm so glad we had a geology talk. Again, this is Big Valley. You can see you've got these alluvial sediments, but what you really have here too are these volcanic rocks, and there was a question about the volcanic rocks, which go all the way up to the Red Hills. And the thing about volcanics, and hopefully Seth can correct me if I'm wrong, but volcanics are weird in terms of, when we think about groundwater basins in California, we tend to think about alluvial basins, which means like sand, gravel, things that sort of came down were carried by streams and look a lot like what you have in Big Valley. And that's kind of how SGMA works, is SGMA is entirely focused on these alluvial basins. But there are bedrock aquifers, and the good ones tend to be in sort of volcanics. And I don't know if these are the sorts of volcanics that would make a good bedrock aquifer, but I think that's a really good question that was asked at the end of the last section about, like, what is going on with that bedrock aquifer, and is there some effect? I don't know. And so we're interested in that. But you can also see, like, especially here, this is a cross section. You see Kelsey Creek, and then you can see Adobe Creek. And one thing to note is, like, they're not really connected through the same layers. Like, they're not that far apart from each other, right? Here's Adobe Creek, and here's Kelsey Creek. But, like, the geology is totally different. Like, they're not connected, and so what's going on in one is not necessarily what's going on in the other. But the other thing that's also interesting is that you have this volcanic underlying, there's a fault here. And you can see the volcanics are pretty close to Kelsey Creek. And in fact, Kelsey Creek, I think, does go through some of volcanics in its headwaters. And, that might be why Kelsey Creek flows year-round in the headwaters. It might be because there's volcanics. Coal Creek, which is over here, which is a lot more clearly in the volcanics, they'll have water in late summer. Adobe Creek, which is up here, does not. And I think this is because of the volcanics. So there is something going on with springs and the volcanics, and we are going to be looking into that. So that's what I say, we're background research. We're going to look into that. I would love to know more about what USGS knows about the rocks, so that we can maybe make that assessment with a little bit more science. We're doing some ongoing stream and groundwater monitoring. We're supporting the tribes. They're out there doing a lot of data collection in the creeks. It's awesome. And we're hoping to support them and put in new gauges. We did put in new gauges this year. And so we're going to be doing that going forward for the next few years. We also have some continuous well monitoring devices. If you have a well and you want it to do some water measuring, come talk to me after, because we have a bunch of devices that we just got. And I'd rather them be in someone's well than sit around gathering dust in our office. So we can offer that to that. Any of the wells that Mitchell and the county are using, we could potentially swap that out for a continuous well monitoring device and collect data. And we're not just interested in Big Valley. We're interested in anywhere that's potentially has a connection to any of the creeks that the hitch are spawning in. We would also like to do some aquifer pump tests, and that will probably need more than one well. That's a big deal, and you need a well where you're pumping it continuously for like a week, and then you have other wells nearby that you're monitoring the effects, right? And this gives you what they call aquifer properties, so that you have a better idea as to how pumping might actually affect the aquifer over the long period of time. Right now, we're making some guesses as to the properties in our models, but we'd like to have real data. And by the way, these don't have to be like new wells. These could be like old abandoned wells. Those might even be better. It might be better that you're not using them, because then they're a little quieter. And so if you have an old well on your property and you're like, yeah, I'm not using it, like why don't you come see what it is? Maybe that's where we want to go. I don't know. And then we're doing some data analysis and model building. And first of all, sorry for all the words on this slide. We are looking beyond Big Valley. And so, I did just show you a bunch of Big Valley stuff, and Big Valley is super important. But we are looking for beyond Big Valley, and I get this question like, well, why are you guys doing models? Like, we already have a model in Big Valley. We already, the GSA did a model, and USGS is doing another model if you were here yesterday. And I think the answer to that is different models do different things. Like the Big Valley sustainability models, it's a great model, and it's looking at long-term water supply sustainability. We are focusing on spring spawning season flows. And if you have a big water supply, model, you might not care too much whether the creek has 0.1 CFS or 1 CFS. But if you're a fish, it makes a huge difference, right? Because 0.1 and 1 is effectively not flowing if you have a big model. But we're going to be focusing on these sort of like spring season flows in groundwater. That's where we're going to be looking at that. And so that's one reason. The other thing is we're going to be using all the data from the existing models, right? Like the models, all that information that was collected in those models, all the information that the tribes are collecting, that's where we're starting, right? We're starting from all this great work that's already been done, and we're going to use that great work going forward and try to sort of drill down into the questions that we really are trying to get at, which is this sort of spring spawning season flow. And all the other things. And we've hired a consultant because we can't do it ourselves. We're not modelers, and we've got a consultant called O'Connor Environmental, and I feel pretty good about this because they have a lot of experience over the hill in Sonoma County doing these surface water, groundwater models, working on ecological flow focused models. That's kind of their jam. They worked with the county on their well ordinance in Sonoma County. They worked with ag groups on frost protection regulations, and so they have a lot of sort of ag and county and well and groundwater, surface water and ecology kind of experience, and I think that's gonna be a good partnership. However, we're not anywhere near a finished product. Like 2027 is when we're going to be done. And finally, we did do an informational order. Folks were sent letters. We tried to sort of target folks that were ag or potentially had big properties. That a lot of those folks were domestic. And you can see that we actually did send some letters to ag out in the Red Hills area. And this is we got a lot of questions about that, right? People said, why are you going out there? It's not near the creeks. And they're not wrong about that, but we don't know what this aquifer is doing, and we want more information on that. And that was why. And folks they were allowed to report on multiple parcels. We were trying to make it as easy as possible. We didn't want to overburden folks. They had 3 options on how to comply. There was a direct straight to us through the Farm Bureau, and then we have a group of ag growers that were actually doing work before we even sent this information order out, and so we kind of let them continue doing what they were doing and collected the same kind of information from them. This is an ongoing thing, by the way. We haven't finished. There are no results. Their second report is due at the end of the month, and so this is still, data are still coming in. But we have about 1,300 parcels that reported to us, which is great. That's a lot, and maybe 470 of them look to be ag. And so, I think we've got a lot of data going forward, and I think we're gonna make good use of that. Future data collection, I kind of already talked about that. We are gonna have some additional stream gauge data. Some of the ag folks are collecting stream gauge data and are gonna be providing that, which is fantastic. And then again, we're looking to identify landowners for continuous well monitoring and potentially wells for aquifer pump tests. And some of this is us working with the ag growers. Like, we do have some good cooperation, and I want to call that out. And then finally, like, you know, if you have questions and you want to get together with us, here's some resources. You can take a picture and contact us if you have comments or questions. And I guess I'll take a few questions. Thank you, everybody.
And I know I cried the first time I saw them because it was 13 years of working on Hitch before I saw them. And I know that all of us here care deeply about the chai, about the Hitch. I thank you for being here. I thank every single one who has done work over the years. And I'm especially grateful that the California Fish and Game Commission helped convene the first Hitch Summit 2 years ago to bring agencies together in a way that they've never been brought together, ever. Agencies weren't talking to each other about this, and now they are, on a frequent basis, as Felipe de la Luz will tell you more. I'm going to give it over to him, and thank you.
Thank you, Janine. Today's kind of a special day for me. 2 years ago, Sarah Ryan brought some tribal elders and some other staff from various other tribes, tribal EPAs, to the Fish and Game Commission. I was just starting in my job. I'm a native minnow enthusiast. There's a few of us out here. And so I'm watching the Fish and Game Commission meeting going like, there's this native minnow, this is on the horizon, so elevated it, told my management, and they said, well, take care of it. So that kind of looped me into this process. So I've been at this for 2 years. I feel like I can't really play the new guy card anymore, but I still have a lot to learn. And just want to express my gratitude for this community. Every time I come out here, I make new connections, and that's really what this talk is about, to kick off the Hitch session and really highlight some of the projects and talk about how we all really need to work together to conserve the species. And also talk about the connectivity between the Hitch and the landscape and the people in the region. So my name is Felipe La Luz. I'm a senior environmental scientist with CDFW. I facilitate the Clearlake Hitch Task Force. I don't get to go out in the field very much anymore, but I do really enjoy coming out, interacting with all of you people. So thank you for being here, and without further delay, I'm going to talk about the Clearlake Hitch Conservation Movement, which is really what we're part of. Not advancing slides. Okay. That's what this is all about, community. I get some feedback from all of y'all. Well, I already have my first slide memorized, so I'm just going to give a brief overview. Most of us know Clearlake Hitch is a native minnow. I love that phrase, I'll say it often. They're endemic to the Clearlake watershed, so they're a subspecies of hitch. Hands off. There we go. So just an overview of my talk. I'm going to give a brief species description. I know many of you are familiar with the hitch, much more familiar than I am, but I'll give some highlights. What I really want to focus on is the structure of the stressors, and I'll define stressors later in the talk, and how that structure shapes our solutions, the solutions that we're looking for. I'm going to talk about some of the conservation challenges, both biological and physical and cultural. Talk a little bit about some next steps and provide some information about how you all can stay involved as members of the public, as members of the scientific community, and so on. So Clearlake Hitch, as I mentioned, is a subspecies of hitch. Endemic to the Clearlake watershed. They occur nowhere else. They're a lake-adapted form of hitch. And historically occurred in much greater numbers. And to say that they're culturally significant is an understatement. It's not my place to speak to that. but I do want to just say that out loud, not only to the, Pomo people, but they've really, from my past 2 years here, have really been a symbol and a gathering point, a focal point for those of us that are conservation minded. We don't really talk a lot about the ecological function of hitch, but I just want to briefly touch on that I think of native fishes as a bellwether, as a biological indicator, and this was spoken about a little earlier. But the status of the hitch really reflects the health of the population. And so one of my mantras is, what's good for the hitch is good for the lake, and it's good for the county, because we're all really connected. Hitch, I've heard them referred to as the salmon of the Pomo. There's a lot of research on salmon showing how they are nutrient transport mechanisms that bring nutrients from the ocean up into the mountains. And hitch likely serve a similar role, not only feeding at the bottom of the trophic level, being an important food source for other animals and people, but also move nutrients throughout the watershed. And we don't really think about them as kind of a mechanism to sustain the health of the watershed, but that's really what they are. Next slide, please. That's not it. I think I'm hitting the right button. It's on. I got a laser. All right. So now I'm Matt Young. This is not my talk. Just bear with us, folks. A song about the hitch. I gotta save that for the poetry slam. I need that much time to write it. This session's off to a great start, but I think one of the strengths of this community is we've really been able to overcome a lot of challenges, and we'll keep supporting each other. Appreciate all your patience. I'm glad I've gotten over my stage fright. It's still not my talk. There we go. There we go. All right, thank you. Round of applause for our AV techs here. Thank you so much. So I'll try to get us back on schedule. Hitch use the entire watershed. This figure here is from Matt Young's paper, where he looked at eye lenses and really showed how he used some pretty advanced, sophisticated science to show that hitch use the entire watershed. And so migration allows organisms to utilize different resources at different life stages. This is a pretty common life history strategy, especially among California native species. And so hitch, as we know, undergo a seasonal spawning migration. So in the spring, they swim up the tributaries to spawn, and it allows them to utilize a diverse habitat. There is documentation of them spawning within the lake. Unfortunately, there's also documentation of carp preying on those eggs, and I'll talk about that a little bit more. But the reason I put this slide up here is to show that while they are capable of using many different habitats, depending on their life stage and what habitat they're in, that exposes them to different specific stressors. And by stressors, I'm just using this broad definition as a factor that prevents an organism from completing its life cycle. So we can think of stressors in many ways. An acute specific stressor, for example, would be a bear coming along and eating a hitch. That hitch is no longer part of the population and will not contribute and replace itself. So that's a really obvious thing. But many of these stressors are complex, overlapping, and cumulative. And so by that, I mean that a hitch that doesn't have adequate habitat isn't going to be as healthy. It's going to be more susceptible to disease and predation. Put on top of that poor water quality, and you get this trifecta of impacts that will prevent the hitch from completing its life cycle. You can only kill a fish once. So hitch need to survive their spawning migration. That egg needs to hatch. That larvae needs to rear and grow. That juvenile needs to out-migrate and then survive predation within the lake for at least a year or maybe 2 before it can replace itself. So at every step of this life cycle, they are experiencing different stressors. And so I just put these 3 examples here: habitat loss, predation, and water quality. This is by no means a complete list. And I'm going to talk about how these 3, I've been using them to kind of think about how to approach conservation from a high-level view. So a good example that we've heard about this morning of a management action is the Common Carp and Goldfish Management Project headed by Robinson Rancheria. This is one program with many benefits. So we have the immediate benefit of reducing egg predation if we can get the population low enough to make an effect. And the feasibility study that Luis talked about earlier really shows that these coordinated, planned out collection events, when they form these big aggregations in winter, we can really target the carp without really impacting other species. And that call for how do we use these carp is serious. So if we have other plans, a big part of this effort is crowdsourcing solutions. So that's an immediate, obvious solution, is egg predation, reducing egg predation. Luis also talked about tule bed disruption. So that addresses rearing habitat. And then substrate disturbance, which affects nutrient mobilization and sediment mobilization. So this is one program that has these multiple benefits that affects all life stages of the hitch, from egg through adult. So these are the types of solutions that we need to look for. To maximize efficiency, get the biggest bang for our buck and really make a big impact. Kind of the overview, I thought about putting a werewolf up here, but there's no silver bullet. And that's kind of my take-home message here is we need to find these many, many benefits to address the many impacts that hitch face. We talk a lot about habitat loss as a single problem, but once you start to dive into it, it's many problems. So thinking back to Matt Young's figure of the different habitat types, habitat is a really broad term. So we need to think about it in all those facets from different angles. So thinking of tributaries, of course there are barriers, which I'll talk about in a little bit. We heard about flow that the State Water Resources Control Board is looking into. Later we'll have a recording from Jenna Rindy, who can be here, about the in-stream flow program that's tying in flow with hitch passage. And that study was inspired and builds off of Big Valley Rancheria's work and their 2D hydrodynamic model with Flow West. So just a good example of how we can work together, build on the work that each other have done, and really make some progress. In the tributaries, we also need to think about habitat quality. Gravel, so we worry about sedimentation. Water temperature, is there sufficient riparian vegetation to keep the waters cool enough for these eggs and larvae to survive while they're in the tributaries? Big tool that we've been utilizing, we're really grateful for Robinson Rancheria, Habimatalel, and Big Valley for conducting these fish rescues. They actually go in and collect adults and larvae, transport them down to the lake. This is a huge service to the department. We're really grateful for it. Moving a little bit downstream to the littoral zone, we have community organizations, Lake County Land Trust, Terra, that are undergoing wetland restorations, doing prescribed burns to support the littoral habitat, which is important rearing habitat. This picture here is the Big Valley shoreline, where they're doing tule planting, important habitat for juvenile fish. And then we have the county shoreline stewardship program, where they're actually actively going on, removing non-native species, working with landowners to restore this wetland. Moving out into the lake is a whole different beast. And so Blue Ribbon Committee and the Turk have been doing, and UC Davis have been doing great work on nutrient source tracking and dissolved oxygen monitoring. Fred up here at USGS has a great paper showing how dissolved oxygen in the summertime really compacts the habitat available to hitch. And that has other effects, concentrating them, reducing the amount of resources that are available to them. I mean, many of us are familiar with fish kills that we see seasonally. And then Big Valley again, just another leader with their cyanotoxin monitoring. So these are just some examples. The list is far too great for me to cover in a talk, but these are just some examples about how many different organizations, from federal government to state government to local government to citizens to Lake County Land Trust to the Lake County Land Stewards and the Farm Bureau, are all kind of taking a bite out of this big problem. So I did mention barriers. When a species gets listed, so Clearlake hitch is a state listed species, the department, when they're petitioned to be listed, the department does a status review, and one of the big, more easily understandable stressors that we've noticed is that they've lost an estimated 92% of spawning habitat blocked by barriers. And this is an example of that. This is a little road on Manning Creek. We were able to do this, to install this little fish ladder, and it looks kind of silly, but we actually have footage of hitch using this, allowing them to move up past Manning Creek. This would not have been possible without cooperation from the landowner. The landowner approached us and said, hey, you know, we noticed them accumulating here. Our district biologist, Ben Ewing, who's going to give a talk later, went out, worked with some of our folks in our HabCon group and got this little fish ladder installed. So we're looking for these sorts of projects. You know, we don't have eyes everywhere. So this is just another crowdsourcing appeal. Like, if you guys know of a spot that's a barrier, if you're having problems, come let us know, come talk to us, and we'll find some solutions. We're going to start working with the county on various projects, and many are already underway. There's also organizational challenges, and so once you start thinking about stressors, I mean, this is just a Venn diagram from hell. So we got harmful algal blooms, we got habitat loss, we got predation, we got sediment, we got poor water quality, climate change. All of these interact in ways that we don't fully understand, but we do know that if we address a few of them, it's good. And so, again, there's no silver bullet, and we don't want to let perfection stand in the way of progress. We are working with cumulative and complex stressors. All of these layer on top of each other, and there's multiple organizations with multiple different efforts. And like I said, every time I come out, every time I get on the call, I learn of something new. So again, it's all about community, and that's what the theme of my talk is about. We are also working through multiple jurisdictions, so we're dealing with projects on tribal land, on public land, on private land, sometimes having to deal with Caltrans permitting, sometimes having to deal, well, always having to deal with state permitting, sorry. But it results in a complex regulatory landscape that can sometimes be difficult to navigate. But however, all of us are experts in our own field, and coming together, we can, you know, navigate this instead of, you know, trying to muddle through on our own. And then just to add another layer, we're dealing with multiple funding sources that each have different requirements, different reporting requirements. So again, there's no single solution. The solution is through collaboration and communication. And just seeing all the talks here today and yesterday, and some of the meetings that have been going on, the groups I'm involved with, we really have some great partners, again, at multiple levels. Blue Ribbon Committee, of course, taking a big charge, but also the community organizations, which I've mentioned already. We're also working on conservation strategy, which is difficult, to try and develop a governance structure that takes into account everybody's needs and wants, and directs everybody and kind of gets everybody moving in the same direction. It's not an easy lift, and we've been at it for quite some time. And then coming into my wheelhouse, we have a Clearlake Hitch Task Force and summits, and this is more of a government organizational theme, originally initiated about 2 years ago. So the task force originated from a government-to-government consultation, recognizing that the tribal governments are sovereign nations and treating them as such. So Sarah, Luis, Daniela, Patricia Franklin, all of you all, I look at, you know, I give you the same respect that I give Director Bonham or Carla Nemeth or the director of any of our other partner agencies. And I think that's given us a lot of progress, just the acknowledgement that these are sovereign nations and should be treated as such. We've held 2 summits, and we're planning a 3rd. These summits are high level to get our management in the room and focus their attention and really say, like, hey, like, these are the issues we're facing. These are the gaps in resources or jurisdiction. You guys get paid a lot of money, so give us some solutions. And then we have the task force, which is really to coordinate on-the-ground fieldwork projects, identify funding sources, and share information. Unfortunately, it's not open to the public. It is a government meeting, but we are finding other ways like this to really bridge that gap and get the public, involved and educated, and really hear some solutions. These are just some of our collaborators. I'm not going to leave this up. Again, it's a big group, and it's always growing and kind of always in flux in what we're focusing on. Just to report on some of the outcomes and commitments from the 2023 summit. Many agencies committed staff and funding. Our department promised me for another year, so you guys still have me. So to have this kind of coordination role. We've also have a strong commitment to co-management and really listening to the tribes, listening to the local governments, and not being like, I'm from the government, I'm here to help. We really do value that input and learn a lot from the entire community. Of course, supporting research and monitoring and restoration, and again, that conservation strategy. We also identified areas that we need to improve, and that's the strength of science, is that we keep looping back and saying, like, how can we do this better? Where are our data gaps? So surface to groundwater interaction with the State Water Resources Control Board and Big Valley Rancheria are really taking a big bite out of the problem by looking at this. We're also looking at biological data. The county, the tribes, CDFW, USGS, Fish and Wildlife Service all have their own separate sources of data. And we're looking for ways to combine this. One of the conversations coming up recently in the Clearlake Hitch Task Force is forming a data subgroup and a data clearinghouse where we could get all the data together, look at our methods, make sure that the methods talk to each other, and go from there. Because we can really learn a lot. There's a ton of coverage. And then we're trying to, of course, stepping up enforcement of existing regulations for illicit cannabis and illegal water diversions, and resolve habitat and life cycle uncertainties. For example, 2023 taught us a lot about habitat connectivity and brought up some new hypotheses that we need to really look into. We saw a lot of adult fish that we weren't expecting. We were thrilled. It was a big relief for me. But it does raise some questions about how do hitch utilize these smaller ponds? And are there like little meta populations that support the larger population? And that's a big question that's going to take a lot of us to answer. So how can the public help? Of course, share your data. And this is going for the scientific community as well. Share your data, even just observations. If you know that this is a problem, where hitch tend to congregate or tend to get stuck. If there's regular stranding events, let us know. Report stranded hitch to CDFW or tribal EPA. And just to stress to everybody, this is a threatened species. You cannot go out and grab them and rescue them yourselves. The tribes have a permit to handle them, so please just report them instead of trying to move them yourselves. And then report barriers. We don't know about barriers on private lands. We're not out here during the rainstorms, so we really rely on our partners to be our eyes. And of course, pollution, report either to the county or local EPA. And then here are some ways to stay informed. I'm gonna, I believe these talks will be available for download, so just go ahead and look at these, and here's some contact information. Mostly CDFW heavy because that's the lens I'm looking through. Just kind of speaks to where I'm coming from, but if you have specific questions about cannabis, about our in-stream flow study, or general fish questions, and if you don't know who to contact me. I feel like my role now is just kind of plugging the right people in together and making sure people can work together. And with that, I'll take a couple questions. Yeah.
Through this whole conference, it seems that carp is a big red threat, threatening a lot of problems, or creating a lot of problems. Now, commercial carp fishing was a big thing in the lake at one time. Did the market dry up? Did people give up just because they were old or whatever? But wouldn't that be an option to get rid of a lot of carp?
Yeah, and I'm not sure about the market forces. I do know carp are not one of the regularly consumed food fish that we tend to think about. I feel like the whole world eats carp except for us. The work that Luis is doing, really doesn't have a market. I know Luis has been working really hard trying to find a way somewhere to put these carp, be that in a fertilizer factory or a food source. So I don't know why it's no longer commercially viable, but if we can find a market for them, like definitely we do. If you want to take some, I can get you some.
Well, I don't have a cat,
Yeah,
otherwise.
yeah, and yeah. All right, any other questions? And we will have a panel discussion at the end, but I think we can queue up our next talk. Okay. All right, so I'll bring up Matt Young from USGS. Me and Matt actually go way back, and kindred spirits and minnow enthusiasts. So, ladies and gentlemen, Matt Young.
I need to get my phone timer on so I stay on track. Because if I get off track, you guys will be here for hours. Okay. Okay. Sound coming through okay? Everybody good? Let me make sure. Okay. So my name is Matt Young. I'm a research biologist with the U.S. Geological Survey. A completely different office than the volcano guy earlier, right? So the U.S. Geological Survey encompasses a wide range of scientific enterprise. Some of us do fish, and some of us do volcanoes, and you get both today. I'm here to talk about a variety of work that we, the USGS, have done associated with Clearlake Hitch. I'm standing here, but a whole lot of people have worked on this. The names on this slide, other people, but we've been working closely, especially with Robinson Rancheria. So thanks to Luis and crew. This could go a whole bunch of different directions. Is this better? Yeah? Okay. This could go a whole bunch of different directions, but I want to focus on, what do we do? By we, I mean our sampling program with the U.S. Geological Survey. Why do we do it, and what did we see this year? So I'm a simple person. I like simple questions. This is just a diagrammatic representation of the complex life cycle Felipe outlined earlier, right? So these fish are born in the streams, they come out, they spend time in the lake, they stage, and then they go back upstream to start the cycle over again. So we'll touch on this and similar life cycle diagrams multiple times, but this isn't new to you. You're probably familiar with Hitch. Most of what I'm going to be talking about today has to do with what goes on in the lake. That does not mean that the streams are not important. That's just where we've been focusing. So this map represents all of the lake samples that we've taken. We've been sampling since 2017, and each single point there's a tremendous amount of information. It's all of the fish that we captured at that point, and we also collect water quality information, including a full vertical. For those of you interested in like water quality modeling, we actually take a full vertical profile from the surface to the bottom. And so there's literally hundreds of thousands of data points. When do we do it, right? So we've been out since 2017. Here's each of these plots is just like the flow in Kelsey Creek. So you can see, this is springtime when flow is high. We are out sampling in the lake in early summer after the tributaries have largely dried up. We want to sample the fish after they've reproduced, hopefully successfully, and when they're back in the lake, and we want to make sure that we're not missing any that are hiding in the tributaries. What do we do? You may or may not be familiar with the sort of work we do. We deploy experimental monofilament gill nets from boats. It's basically a very fine mesh or large mesh of fishing line that's between 6 and 12 feet tall. We use it to, deploy it for between 20 and 40 minutes so we don't stress out the fish and cause any unintentional mortality. Bring them in, measure them, weigh them, and release them. This is a picture of the Robinson Rancheria crew on their vessel, and this is the USGS vessel. We use a range of different mesh sizes in our nets so that we can sample a range of different fish sizes. So if you picture like a mesh, like a big net mesh is going to catch big fish, small mesh catches small fish. That's all this figure represents. We could talk about any of this in more detail if you want. So why do we do it this way, right? We touched on our goal is to focus on hitch, this is another way to think about that life cycle, right? So we have what they do in the streams. They start out as an egg, they go through this larval stage, and then eventually they enter the lake. They get older in the lake, and once they reach a certain age, they will start the process over again, with some spawning in the lake, which is a whole nother nuance that we can touch on too. Overlaying sort of our earlier, simpler conceptual diagram, but this is what we do. This is what this GillNet survey is designed to do, is to focus on these fish that are either 1 year old or older. They're in the lake, and they are available to spawn during the next spawning window. So this is effectively a repeatable index of the abundance of this adult portion of the population. There's a whole bunch of other work that goes on, which you've heard about, Felipe touched on, other people have touched on, that fit into different parts of this life cycle model. And now one of the big challenges and opportunities for this community is tying it all together and figuring out how all these pieces fit to tell a broader story. But again, I'm focused on this. So I'll talk about the results from our 2024 survey here. All of the data up to 2024, so 2017 through 2023, is publicly available. There'll be a link, QR code for this link later if that's your interest. The 2024 data we collected it this year. It hasn't gone through the full final approval, so it has this little disclaimer where it's not yet publicly available. We're working on getting it QC'd, and it's just, we'll get that out as soon as possible. So this is a figure that some of you may have seen before. On the x-axis, the bottom part of this map figure is just each year. And the y-axis is the relative abundance of hitch. So this is in terms of fish per hour spent fishing, right? So you spend a lot of time, you catch a few fish, that's a small number, et cetera. We documented fairly substantial, dramatic declines in 2022 and 2023. These numbers, like 2022 represents 6 individuals. So we only caught 6 adult hitch in all of our efforts. 2023, we saw a fairly substantial rebound, if you will. We captured individuals, I guess I'll put it that way. And this is what things look like for 2024. So this is the grand sum total of all of the work that we did this year, partially was to generate this number. There's a whole lot more information that we collect than just the sum total or average of fish density that we encounter. So you can think about one of the most important pieces of this information has to do with the age structure of the population, right? Is this population made up of a mix of young, medium, and old-aged fish, or is it all one age class that is really driving the abundance that we see? You can see in 2017, there was a very large number of juvenile fish, and then, adults. As you go down the next year, you can see that these juvenile fish survived, and a lot of them got bigger. But there wasn't as much juvenile production, right? And so you can just keep following that down. These fish, some survived, got a little bigger. These fish, some fewer survived, but got a little bigger. And then 2022, or I should add 2019, 21, and 22, there was very little evidence for substantive juvenile contributions to the population. I'm not going to say there wasn't any juvenile contributions to the population, but there wasn't a lot. 2023 was great. It was such a relief to all of us who were out on the water, who were invested in the species, just to see something that was less dismal than the numbers that we saw in 2022. And perhaps most encouraging was this resurgence of some evidence of successful reproduction. 2024 looks in some ways a little bit more like 2019 in that there are very low density of juvenile fishes, and there's evidence for these fish, aging, and some survived, aged, and grew. There's a nuance here I want to touch on, and many of you may have picked up on this, right? I talked earlier about how we are not looking at juvenile fish. We're looking at fish that are a year old or older. So these numbers you see here that say juveniles, these are fish that were actually born the preceding spring. So fish we captured in 2017 were born in 2016, and vice versa. So what this means is that these fish born in 2023 were actually, or we encountered in 2023, sorry, were actually born in 2022, which is quite the enigma. For those of you who saw Val's talk just right before the break, she told us that there was no water in Kelsey Creek in all of 2022. So where'd the fish come from? And that's quite literally the question that I'm not going to answer today. But I do want to talk about some of the tools that we use to explore these sorts of questions, right? So this is the information that we have available from our month or annual surveys in the lake based on the gill nets. Oh no! This is the wrong version, and I can't tell you what the other stuff was. I am devastated. I'm so sorry. I can tell you what it was going to be. Do you want me to tell you what it was going to be? Okay. So can we go to the life site? Can we just like bring up the presentation again? I swear, we went through this ahead of time. We like had this queued up. It was going to be good. We like checked it at lunch. All right. So let's just start with this life cycle. So everything that I've talked about is focused on this part, right? So we're looking at what these fish are doing in the lake, how many of them are there. One of the a major question that we want to know is fish that are going back to spawn, these adult fish, where did they come from? Which tributaries were they born in? And does that change over time, right? Is one tributary good one year and then a different tributary good the following year? And how does that relate to the total abundance of fish you see in the population? So through some very fancy analyses, we actually will keep a very small subset of the fish we encounter. We will extract various tissues from them. Specifically, the two that we like the most are otoliths, which are ear bones. So fish have these little bones right here that are calcium carbonate. They're made, they're deposited sequentially, and they're made from basically the water that they live in. And you can use these otoliths to recreate the water chemistry that fish experienced in its entire life. So imagine like a little tree ring type deal. And at the center of the tree ring is when the fish was born, and at the edge of the tree ring is when it died. Is that good? Can people like, this is so much fun without pictures. So what we can do is look at the transect across the entirety of that fish's life, all of those tree rings, and see which water bodies it was born in. So through that, we were able to show that fishes from 2017 used many, if not all, of the tributaries that were out there, which is super interesting and super cool, and we're looking to expand on that and evaluate tributaries in different years and success of fish from those tributaries in recruiting to the spawning population. The second tissue, I have time. So the second tissue we really like are eyeballs. And this is my thing, I'm an eyeball person. So fish eyes do the same thing. Imagine you have a little eye, right? I can do this. Right here. There's a lens, just like we have. There's the lens at the center of the eye. That lens is laid down similar to an otolith, similar to tree rings. So at the beginning, the core of that lens, you can see what that fish was eating right after it was born. And then at the outside of the lens, you can see what it was eating right before it died. So you can recreate its diet from birth to death. And through that work, we were able to show that these hitch. Sorry? Science is so cool. Thank you. Through that, we were able to show that hitch will go ahead and move into the nearshore habitats of the lake. When they're about yay big, about 4 inches, 3 to 4 inches, they'll be in the nearshore. By the time they reach 6 to 7 inches, most of them are offshore. So out in the middle of the lake, foraging on zooplankton, and using completely different habitat than they are at other sizes. Using these two tools together, we can now say that this fish was born in this tributary. It left this tributary when it was 37 days old, moved to the near shore of the lake, lived there for 3 months, and then went out to the middle of the lake. And so we can use that we have enough individuals, we can use that to get a sense for which strategies are effective in leading to reproductive success. I so wish you could have seen all the pictures. I'll see what I can do about getting that updated in the publicly available digital booklet for the meeting. Yeah. So, no, it's totally, I mean, I don't blame anybody. But what I do want to point out, and I'll just leave it here for now. Well, I would like to acknowledge a whole bunch of people, first of all, right? So there's the agencies and groups represented on this slide, including Robinson Rancheria, the Fish and Wildlife Service, USGS, and the California Department of Fish and Wildlife, among a host of others. But I also want to call out the Clearlake Hitch Task Force that Felipe chairs. It's something we participate in, and it's a really valuable forum. And then a colleague of ours did the excellent illustrations. But the last thing I want to leave this with is all of the information that I presented here and all of the studies that I referenced are all publicly available and can be accessed with any of these QR codes. So if you want any of the data on the fish catch itself or any of the chemistry data and for otoliths or eye lenses, you can see that. Or if you just want the summary of the different papers that describe a lot of these things and where a lot of the illustrations that myself and Felipe used, they're available through these QR codes too. Yeah, that's it for me.
We have time for a question or two while we pull up the next talk. Is that okay, Matt?
Yeah.
All right. Any questions for Matt? Nobody wants to go in the nitty-gritty about stable isotope analysis? Okay. Oh.
And this is me also making sure that we have enough time to get the next presentation up so you can speak slowly. Ha. This is fascinating, fabulous. Again, we're so pleased to have more data and more data available. So if you could just walk us through these QR codes and answer questions like, how often are you updating the data? Do you have any, like I know USGS has some pretty clear restrictions on when you're able to release data, and that there's been frustration, especially from tribal partners, when they weren't able to get that data in a timely fashion. So how are we addressing that? And yeah, if you could just go through each one of the QR codes. When it says chemistry, what do you mean? When you say isotopes, what do you mean? When you say glade habitats, what do you mean? Etc. Merci.
Absolutely. So I'll start with I'll start with the studies because they're very easy. These are just links to the papers that are in the scientific literature that build upon these data. I'll touch on these data now. So the first QR code is for our fish catch data, and that's the one that is updated annually as we get our information in our catch. So we'll collect, the way it works at the U.S. Geological Survey is we will collect data. It has to go through a fairly rigorous internal quality control screen to make sure that those data points are, accurate, collected with the precision and accuracy we expect, and are representative of the protocols that we are enacting. So that process can take anywhere from 2 to 6 months, depending, and so that's the delay that you were referring to earlier, is it takes us a little while for us to get data through this screening step to make sure that we're not releasing data that has any inaccuracies in it. This data is updated every year. It's currently under review now. We anticipate it should be fully publicly available within the next, I don't want to pigeonhole myself, but within the next few months, certainly. Hopefully much sooner. This data includes our catch, the water quality that's associated with each net, and the location. Chemistry refers to the water chemistry information that was available, that was used for the otolith analyses. So there's information on a whole host of constituents that can be found in different water bodies. The most relevant is the isotopes of strontium in each particular water sample and fish sample. So in this data release, you would see information about strontium isotopes from fish bones, which I think is awesome, but there is a lot of interpretation needed to go along with that. With each of these data releases, there is extensive documentation saying exactly what each number means and how they should be interpreted. The third one, the final one that just says isotopes, that has to that is a release of the isotopes of carbon and nitrogen from the hitch fish tissues of interest. So we use carbon and nitrogen as a way to track what organisms have been eating. You are what you eat. So the carbon in you is the spaghetti you ate 2 weeks ago, or salad, whatever your diet preferences are. But that's what that data release is the carbon and nitrogen isotopes that can be found in both fish hitch muscle tissue and the eye lenses that I was discussing.
Thank you, Matt.
So the QR code campaign has been disabled for some reason. Your QR code reader scanner is working fine.
Yeah.
Hey, thanks for scanning.
So that was why there was a new version of this presentation, is because the QR codes don't work. So this is truly catastrophic.
Okay, okay.
What can I make a suggestion? What if I get it on the computer so at the break they're all up on the screen? Can I do that?
So there's this big firewall between me and the techies.
Okay.
And right now the techie is trying really hard to get the next talk up. We apologize for all technical difficulties, which were not within my purview. What we might be able to do is, do you have that slide on your phone? No.
No. I have it on my computer.
You have it on
right
your computer.
there.
Is it anywhere on a website?
Only yours. Only your website.
Okay. Well then, what we will promise to do is we will prioritize the uploading of your correct talk to the CLIS website on the Lake County Water Resources Department page, where all digital files of all presentations will be uploaded as soon as we can. That's the best I can do, and I am sorry. Yes,
Sorry,
Meg,
Sarah.
did you have a question? Okay, let's give Meg the microphone.
So I have a two-part question. Could you please bring up, this isn't one of those questions, but could you bring up the age class structure survey results? Thank you. So given that 2024 results look a lot like the 70% drop that happened in 2019, I heard you use the word rebound for last year's results, and then you're like, ooh, I don't want to say that. Given what you were saying about 2022 and there not really being the fish available to create the juveniles that were caught in 2023, can you speak to that a little bit? And then what if, here's a what if, like there were a lot of rescues in 2023. Did those contribute to the big juvenile catch?
Excellent question. There are a lot of pieces here, and I'll try to answer them as I remember them, and if I'm missing a piece, shout back at me. Yes, so one of the big questions, so maybe I won't answer them in exactly the way you asked, but one of the big questions and uncertainties is really figuring out where this is coming from, right? Is this the success of something that we are doing actively, some active management that's happening in the system that is saving the juvenile fish, bringing them to the lake, and that's the critical bottleneck? If we can do that, we can make this. It's hard because then there were a lot of rescues in 2023, and then we didn't necessarily see a commensurate rebound in 2024. So, is there some other place that these fish, some other habitat that we're not effectively sampling that we don't understand very well that is leading to these sorts of dynamics? That's also possible. So I think getting a sense for what is causing these very clear, successful recruitments into this 1+ age class is one of the key scientific and management uncertainties in the system.
Okay, here's my follow-up question. Will your 2024 data that's not yet available for publication be available to the U.S. Fish and Wildlife Service before they make their decision in January?
That is very, very, very high on our priority list. Like this high on our priority list. Yeah.
So yes?
So yes.
Okay.
So one of the things so although the data are not fully publicly available in their raw form, this, right, is publicly available. This presentation is publicly available and is something that Fish and Wildlife can use in any way that they see fit. The fishes and wildlife's, both state and federal.
Yeah, and we'll have to hold all the questions until we're actually about 20 minutes behind, so. Okay. Okay, well.
Is everybody okay with putting this slide presentation to bed?
Okay.
Okay, so we'll put that to bed. You can continue the questions so that you can line up those.
Okay, so we'll get Ben Ewing's talk. Okay, one last question.
Hi, Philippe. We met a few months ago. My question is simple. In a given tributary, let's say Hitch Creek, currently known as Kelsey Creek, starts at 1,300 lake level and goes up to 3,000 feet up in Cobb. How high did the Hitch go up that tributary?
That is such a good question. So the question was, how high do Hitch go up tributaries? And right now, and I am not necessarily the best person to answer this. Ben Ewing and Felipe might actually be better suited for this. But my understanding, basically, they can go until they hit an obstruction. In most tributaries, there are obstructions that are the defining limit to upstream movement. We don't see fish above this point. We don't know how much further up they get beyond that point because they can't access it. An unsatisfactory answer, I know. I imagine, what I can say is that I imagine it's going to have to do with the gradients involved. Once a stream reaches a certain steepness, they're just not going to be interested in going any higher or spawning in those locations. I'll take questions until they tell me otherwise. So,
isn't there a waterfall on Kelsey Creek somewhere, like a 17-foot one?
Yeah, absolutely. And so that would be, in that watershed, that would be the natural upstream limit to migration. In the other watersheds, what does that look like relative to topography is gonna differ. And I defer to folks like Ben and Luis Santana.
And that's a good segue.
Thank you.
Everybody, now we're bringing up Ben Ewing, who's the district fish biologist for California Department of Fish and Wildlife.
Yeah, thank you, Felipe. Since you already introduced me, again, my name is Ben Ewing with California Fish and Wildlife, district fisheries biologist for Alpine, Amador, Calaveras, and Lake counties. I'm here to give a little presentation on some of the past, present monitoring that's going on for the Hitch, as well as some past and future projects that we got going on. Currently, we've got CDFWs doing 3 types of surveys to get some data on Hitch and what they're doing, try to get some information. They're all a little bit different, so trying to use 3 different types of methods to get information on the Hitch I think is beneficial, as we're not putting all our eggs in one basket to try to get an idea on how the population is doing. One of the ways is visual surveys. Since 2014, we've used 21 sites on 7 tributaries in the Big Valley Basin: McGaw Slough, Adobe Creek, Coal Creek, Manning Creek, Kelsey Creek, Hill Creek, and Thompson Creek. We've also, since 2019, done a relative population estimate where we collect Hitch and mark them as a mark recapture tagging study on 4 historical sites that we've seen in the past where large congregations of hitch have congregated like in the lake itself. Those spots are Holiday Harbor, Canocta Casino Harbor, the State Park, and Soda Bay, and those are used with an electrofishing boat. Our last survey is a general fish survey in which we, again, we're using an electrofishing boat, and we sample 18 sites across Clearlake, and we use this to gather information on Clearlake hitch relative to also the other fish species in the lake. So the population estimate is obviously more geared towards Clearlake hitch. The general fish surveys, we collect everything so we can get a good idea of like how the hitch are stacking up relative to the other fish species in the lake. One thing I wanted to add, this year during the population estimate, we were able to work with Robinson Rancheria with our carp and goldfish removal project, and we're able to remove any carp and goldfish that were in the sites where we were seeing hitch. And we collected quite a bit of carp and goldfish that were right on top of where hitch were spawning this year. These are the results from 2014 to what we saw this year on our visual surveys. Nothing close to really what we saw last year in 23, which was a really good year, as everybody pretty much knows. They were everywhere. They were still pretty, it was a little middle of the road compared to previous years and this year. And I think most of the fish that we saw at the 7 sites were all at Kelsey Creek this year. This year, I mean, Luis touched a little bit on the methods that we use. We use the Schnabel and Schneemacher-Eschmeyer to get, try to get some calculations from the totals and get some relative abundance numbers. We marked 969 hitch this year compared to 1,000 in 23. You can say, unfortunately or fortunately, we didn't get any recaptures in this year, so you need to get recaptures to calculate a relative abundance. So we had 969 with 0. Last year we had 1,000 with 1 recapture. And these are just the total numbers of Clearlake that we've collected over a relative population estimate over the years. So it was, even though we didn't get a estimate, what we saw in the lake was relatively really good. One thing I need to note, in 23 I was able to sample 10 times, and this 24 season I was only able to sample 9 times due to a very large scale bass fishing tournament that I didn't want to have any conflicts with, so we only got 9 surveys. So I think it actually we probably would have collected more hitch this year in the lake than last year. But the numbers were up in the lake, but obviously, like the prior slides, you can see that we didn't see too many in the tributaries. This is some results from our general fish survey. Again, these are the same sites from our 2015 survey. I'm not going to go through everything, but in 2015, the hitch made up the 3rd highest, tied for the 3rd highest for species composition. And last year in 23, they actually made up the 2nd highest. However, the numbers, if you look, the total number of fish collected in different species was really down in 23 compared to 2015. But on the brighter side, it was good to see that at least hitch was the 2nd highest in 23. Some of the past work that CDFW has done to try to improve hitch tributary passage, I'm going to just go through a few of these, is the Kelsey Creek detention structure. Quick note, there was 2 ladders that were put in at the Kelsey Creek, and if you're looking upstream, the one on the left, talking to locals, and they were saying that the left side, the hitch really were only using the right side, so we were able to get our crew in there and do some habitat work, and from what I've seen, we've got documentation that they're using both of the ladders, which is good. This slide was brought up earlier, so I'll go quick. This was a quick story on this was, again, the landowner reached out to us. I would have never known about this barrier. It was on private property on Manning Creek, just above Soda Bay Road and Highway 29. They reached out at a Goodwill. They didn't have to, and let us know that they've seen hitch stack up right there. They felt bad that, I mean, I don't even think, I think this bridge was put in like, or the road crossing was put in way before that current landowner had it, but wanted to try to help the hitch out. So we were able to do a little makeshift ladder, and like was mentioned earlier, we do have video footage. I didn't put it on this, but we do have video footage of those hitch using that ladder, which was really good to see. And last year, they got as far up as I've ever seen them in Manning Creek, up way above Highway 29, like above like the Kendall Jackson property, if people know where the Kendall Jackson, and it was really good to see them. I've been monitoring them since 2013, and I'd never seen them that high up, so it was good to see this ladder. Seemed to be helping. I'm not going to say it was, they couldn't, you know, the water flows were a little higher, that they were able to get around it too and get up, but I definitely got footage of them using the ladder, which was cool. This was a project, this is on Coal Creek right at Highway 29. It was a Caltrans project. This is the before, obviously a big hitch barrier. We were able to work with the contractors and engineers at Caltrans, and they were able to put in this fish ladder. I don't have any documentation of the hitch getting up this far, and talking to the landowner that actually worked with us on this property actually let us know of a barrier that's further downstream. So we're going to try to work on the downstream barrier as well, because he was saying that until that barrier is pulled, that they can't really even get up this high to utilize this ladder. But once, if we can ever get that ladder downstream fixed, or the barrier fixed, then it'll be cool to see if this thing gets any usage. This was a project, again, we work with Caltrans, where they had culverts at Cooper Creek at Highway 20. We were able to work with them, and they got some box culverts put in, and got plenty of calls saying that there's hitch. And actually, I think Robinson did a late rescue in this section of hitch using this creek after the 23 year. So definitely a lot better than those culverts. You can see they would have to jump during low flows. They're not going to be able to probably make that jump at all. And now they have the nice box culvert, so that was a good project. This was a Caltrans project at Seagull Canyon Creek at Highway 29 and 53. There was a lot of big boulders and a lot of blockage. It was pulling up a lot of debris and stuff, so Caltrans was able to take the boulders out and put in some smaller rock, and it's more gradual. And I got reports of the hitch going above this past year, I believe, going up a lot further up on Seagull Canyon Creek. So that was really good to hear, because up until that point, I think the furthest they could get was about this point or a little bit further downstream in Lower Lake area. So this was a really good project. This was a project that Elam worked with the county, I believe, on Seagull Canyon downstream. You can see the barrier that was present before, and after the work they put a series of little steps, and it's worked really well. The hitch can get above that now, and it's right close to town. This was a really good one, because a lot of people can see it. You can go walk down there along the street and look down, and now you can see the hitch swimming up and getting past that area, because currently it was a lot more difficult prior to the project. This is probably the most recent one we worked on. This was on the Kendall Jackson property. They reached out to us. I would have never known, or we would, about this. I had heard rumors, but I didn't, I wasn't going to go on people's private property and stuff. So they reached out to us, let us know about this barrier. We were able to go in with our crew and take it out, so it's obviously a lot better situation for them. one thing other than the barriers too is just the vegetative barriers too that we've been working with the CCCs. We're able to work on, they do a bunch of vegetation clearing. This is on McGaw Slough. I believe this is on Finley Road. And yeah, they were able to do a lot of, I mean, this was so thick. I don't have the some before pictures, but it was so thick. This is one of the spots where I do my visual survey sites, and it was so thick that it was a natural barrier for them. It wasn't even a man-made barrier, and the hitch had a difficult time. And so I think we're still looking at trying to get the CCCs to do some more work in vegetative clearing. They did a lot this year. They did an unbelievable amount on Adobe Creek by Finley Road. That was, if people know that area and that stretch, it was really, really bad. And they cleared it out. It was a phenomenal job and made things a lot easier for the hitch migration. Oh, and one thing, we got one project on Schindler Creek. If people are familiar with, at the Dollar Tree on Highway 20 on Schindler Creek, there's a barrier there. Our crew is looking on October 8th to go out there and try to put another fish ladder and take out some of the baffling and make things a little bit easier. So we're working on that barrier removal in October. So we'll hopefully give the hitch an area in that, you know, the middle arm of the lake, an opportunity to spawn in Schindler Creek. One thing in the past, the department has been, usually has to be present during fish rescues, but we've now, this is the second year that we've been using MOUs, memorandums of understandings with the tribes, that they can perform fish rescues, because in the past, I'm out of Sacramento, and I'd get a call on Friday night or something that this pool's drying up, and there's hitch in there, and it was really challenging to have to get up there in time, you know, last minute calls. And now we've got some MOUs set in place, and the tribe's got qualified people. And now when we get a call, they are able to get out and perform the rescue, you know, a lot of times right that day, because a lot of these creeks are drying up really quickly, and young of the year, and adults too sometimes, are getting stranded. So here's some pictures of what happens. Like, you believe it or not, these little pools will have like young of the year. And here's a picture of some Robinson and county staff performing a rescue in Lakeport. Here's another picture with Robinson. They were using a backpack electrofisher in the previous picture, but other methods that are using a seine, a beach seine like that. Here's a picture of one of their rescues, and this is just one cooler full of all young of the year. So you can see like how many, you know, they're rescuing and how much they can be able to contribute and give those things a shot at the rest of their life. Future projects we got are still assessing water diversion and stream flow parameters and groundwater parameters, and I'm not going to get too deep into that because Jenna Rendy is going to be talking about her stream flow projects that they've been working on. We've also, I'll touch on this real lightly, we still continue to work on reducing the number of carp and goldfish in Clearlake. And especially during seasons where tributaries may not have enough water. I think it's really important that the hitch have some in-lake spawning opportunities, because, you know, I'm sure we're going to be running into other drought down the road and stuff. So to give them an opportunity to spawn in the lake would be really helpful. And there was a question earlier about what to do with the commercial fishing. Currently we do have a commercial fisherman out there electrofishing, and right now he is selling mostly of the goldfish he's collecting to Bay Area Asian markets. The carp don't have as much, according to him, don't have as much of an interest from people. It's harder to get rid of carp that are shocked like this compared to a smaller goldfish. Some recommendations are to continue to monitor the relative abundance of hitch, try to reduce the amount of legal water diversions on hitch spawning tributaries, continue to educate the public on the importance of hitch as an indicator species for a local community and ecosystem, preserve and restore hitch rearing habitat around lake, and address remaining hitch barriers that still remain There's still some in Clover Creek. We're trying to take care of that one in Schindler Creek later this fall. Adobe Creek, especially at Bell Hill Road, and Kelsey Creek that we're working on the Main Street Bridge. And Anthony with Flow West is going to talk about that a little bit later. And we'll continue to work with Robinson on reducing the carp and goldfish numbers. Thank you.
Okay, Eddie.
Hi, we're going to take some questions while we transition to the next talk. Announcement. The correct QR codes are on our Facebook page, Clearlake CA Science. They've been posted up there, so they're there for everyone. Or you can find me right here. Or you can go to Matt and make friends. Matt, do you want cookies? Okay, questions from the audience about Ben's presentation. Come on up and we'll give you the mic so that people online can hear.
I have a question. I'm familiar with Napa River watershed using fish ladders for stillhead, and a lot of times they get clogged with rocks and it becomes more of a detriment than a benefit for the species. Is that something that is a problem with Clearlake hitch? And if it is, do you have the measures in place to remove the clogged rocks from the fish ladders?
I mean, the ladders that we've been putting in I haven't heard of any like clogging issues. I mean, not to say they don't. The one thing that we've been working on, I think, when we were trying to make some of the designs, is trying to make these more gradual, nothing like super steep that would try to clog anything like pinch points. You know, some of the examples I was showing are sort of just like a little bit more gradual. So anything that's going to try to pinch things up is going to be tough. But I don't want to sit here and try to compare like the salmon barriers or the salmon ladders to this. I think a lot of times, you know, our fish. I'll be the first to say that I'm not an engineer. You know, some of these things we're still learning on this stuff. Like but I definitely think like examples like the box culvert and stuff, like, you know, compared to having just the regular culverts, you know, where they don't have to jump, are a really good thing. And also just you know, cost benefit type deal. So thankfully I've been able to I have a lot of trust in the engineers that I've worked with, like with Caltrans and with Flow West, and even our engineers at the department on designs that will try to help minimize things. I put a lot of trust in them. That's not my background as engineering fish ladders. I have some thoughts and my recommendations, but I definitely am not going to sit here and say, you know, I know how to design these things. I know that the hitch can't really jump too well at all. And, you know, anything where you can try to minimize like heavy flows or like, you know, any like pinch points and stuff, and some resting points. So like that one that our crew did on Kelsey Creek detention structure, they tried to, it was previously a straight shot, and I think that's what was hindering them. The other one had some little meandering and some little pools they could rest in. And so they were able to put some curves and some S-turns and some holding pulls, and now they seem to use it. But I'm still learning on it too, and that's why I'm not going out there. You know, we're working with other people. It's not me making the call. I work with other people I feel a lot more at a higher level that can design these things. And, you know, and then we still monitor them. I mean, some of these ladders, the Kelsey Creek, that was made, I think it was made in the late 90s with good intentions. It's never really worked, as far as I know. And so you got a lot of this stuff you're adaptive to see, you know, monitor it. But obviously you try to get it the first time, but sometimes, you know, the flows in these creeks, they change. You know, the hydrology changes. So I think you got to be adaptive on some of this.
Awesome, thank you. Yep, thanks.
Hi, Ben.
Hi.
Supervisor Green. I want to apologize to you because I'm one of those policymakers that don't know squat about science, and yet I get to ask you hard questions because I'm an idiot. And so I'm fascinated about the general fish survey and about the relative prevalence of non-native fish like largemouth bass and the hitch. And I guess my question is this. We've talked a lot about carp and goldfish. other environmental factors that may be impacting it. But I continue to be kind of stricken by, I see fish rescues on the one hand, and I know they're going right into the part of the lake where the bass tournament is that weekend. So, and again, the zones, what they're doing in the tribs, what they're doing in the littoral zones, what they're doing in the lake. So I'm glad that we're learning more about the life cycle of the hitch, but the life cycle of the bass is kind of interrelated with that. And I don't want to put anybody on the spot, but I think just like there are certain management actions that can and are be taken with carp and stuff like that, bass boats can do bioturbation too. Clearly predation is still a thing. And just to satisfy my own curiosity, from the barking I started about a year ago, at the CDFW level anyway, is there any dialogue between the sport fishing arm and what you guys are doing here to educate us about the hitch, and what do we know at this point in time about the actual interaction? Because I love seeing the hitch getting rescued, but I hate the idea that they're just going nom 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 with the bass once they get back in.
No, I hear you. I think two parts. The largemouth bass, there's no doubt that the largemouth bass eat quite a share of the hitch. So I'm not going to deny that. At this point, I'm thinking with, people think of a big bass like eating an adult hitch and stuff, which probably happens quite a bit. It definitely happens. What we're trying to approach with the carp and goldfish is, I think a lot of people, like Luis brought up a big like 40-pound carp. You could imagine how much food that has to eat. How many eggs it probably consumes, how many hitch eggs. So yes, like the largemouth bass, in the grand scheme of things, is not helping things, but bang for your buck, I definitely believe not only removing the carp and goldfish and reducing the numbers will help the hitch, but it also help the lake. We actually, and as far as the tournaments too, and that's been a big thing, and there's a rule that the tournaments have to release all their bass from the tournament. I think it's 400 yards from the release site offshore. Now, whether people are, and that is strictly to help, it's not only to help the fish, because what happens a lot of time, people just hang out at the docks after they release them, and then they just snag these big bass and take them home and stuff. But it's actually very, very beneficial for the hitch to release these, especially like places like Canocti Casino Harbor, where if you release all these big bass, and that's where a lot of our hitch, the rescued fish go. You're sticking all these bass right there, they're out of it, and then you just stick all this bait right in front of them. So whether or not these things are being enforced by the tournament directors, whether our wardens are able to, cover all the, especially like the small club tournaments, whether or not they're able to enforce if these guys are releasing these fish. But it's a two-part by releasing them 400 yards out. It's to help give those bass a chance to get away from people snagging them and get them out and not have them congregated, and also to protect a lot of those fish, especially like close quarters, like the harbor, Kanaka Steel, where they're trapped. I mean, they're not trapped, but they're in that tight spot. And then, Robinson does a huge rescue or something, and they release 10,000 young of the year. No, I agree. It's not a good thing. I've stressed to our wardens that they can't be at every tournament and be at every ramp where there's tournaments or club tournaments, but that is a big thing. And if you guys see it, people see it, they're obligated to they're supposed to supply a release boat and take them offshore. Unfortunately, I know that doesn't happen because Canocti Casino Harbor is one of my spots where I shock, and it's actually one of the best bass fishing areas when I shock it. The amount of big bass, and you'd think, oh, you have to take a boat and go across the lake, and I just shocked these monster bass right in the cove, and I'm like, and we also see a lot of hitch in there spawning too. So it is something that's on the radar, but if the public, if you guys see tournaments, and a warden's not there, they need to have a release boat for that reason.
Okay, I see we have 2 more questions. We are now 15 minutes behind. So, are you cool, Ben, with them coming up to you and asking their questions directly?
Yeah, sure.
Yeah,
yeah.
Okay. Yeah, let's do that. So this gentleman and this gentleman, please go directly to Ben. We're going to take a 15-minute break, and we will be back at 4:15. Thanks. We're We're going to start right now. And our next speaker is Luis Santana, whom you may recognize with a new non-hat on. We're going to start now. Thanks to everyone. If you still have conversations, just take it in the lobby. Thank you again. Luis, you're on. We're excited.
Okay, so since I'm local, I'm going to try to go through this so we could catch up on some time. But if not, then that's okay. So again, if you guys weren't at my talk earlier, I'm Luis Santana. I work for Robinson Rancheria. I'm the water manager and a fisheries biologist. So a little bit of what we've been working on. This isn't everything we do, but some of the stuff that we do. A lot of Clearlake hitch rescues. We're not only focusing on Clearlake hitch at that point. We do incorporate other native fishes. In-stream habitat mapping, I'll have a few maps later on. Spawner surveys, I was hoping to have a lot of that done by now, but I just didn't get it in time. Hopefully in the next month, we'll have a bunch of stuff to share. Invasive species management, and then I have a few slides about Habimitol's seine monitoring and pit study program. Again, some of the data on that I wasn't able to finish, but there's some really cool stuff that's in development right now. I didn't put a restoration slide on because I was just like, I don't think I'm gonna have enough time to go over it. But we have been doing a lot of small scale restoration. And that's Robinson and Clover Creek. But the Tejada Ranch and Hapinapo is big scale restoration, and that's in the future. So some of the rescues we did in 2024, well, the ones that I already had reports written for, I'm a few behind, but we did one at Stokes Avenue, which is right behind Century Market, here in, I think it's technically Upper Lake. Clark Drive in Kelseyville, there's a couple days where Big Valley couldn't make it to the rescue, so they're like, hey, can you go check it out? And we did, and we were able to get some hitch out. Scotts Creek, lots on Scotts Creek. I have some cool pictures from that. Middle Creek, Habimitol helps a lot with that as well. And they have, I think they did in the last couple weeks 5 or 6 rescues in Middle Creek. And then Kelsey Creek, anytime Alfred needed some help on Kelsey Creek, we would go help him out. So a little bit about the Stokes Avenue rescue. It happened from February 26th to 28th, and it was really funny. One of my friends, he called me, and like that guy never calls me, so I'm like, what's this guy want, you know? And he's like, hey, I'm running right here behind Century, and I think there's a bunch of hitch here. You should come check it out. And so I'm like, okay, and I think it was like, let's see. No, I didn't take water quality that day. It was a Saturday. So it was a Saturday, and I was like, all right, I'll go check it out. And sure enough, there's adult hitch. So I called the new game warden, Joe Hernandez, and it was only me and him. And so I took my dip net, and I think that day I got like 18 adults, maybe more. Not entirely sure. But anyway, so what happened with that, because it was in February, so you're like, why are you doing fish rescues in February? Well, when everything floods, they're just like, oh, there's this little ditch, and it's perfect for spawning. Let's just go up there and spawn. And then water recedes, and then they can't get out. And so that occurs often, very often. I don't know if I have a picture of it here. So right behind Century Market, just east of here, I got those fish out, and I'm like, okay, where am I going to put them now to where the temperature is, you know, somewhat similar so I don't shock these fish and potentially kill them. And so my sister, Daniela, works for Habimitol, and I was like, hey, can I take them to the Christmas tree farm? Because maybe the water there is very similar. And right here, you could see, oh, I didn't put, no, I definitely put it, but it didn't come up. Anyway, the temperature and the DO was very similar, so we took them there and released them at the Christmas tree farm on Clover Creek in Upper Lake. And so with these fish, I was actually able to pit tag them. So passive integrated tag, right? Transponder. And so tiny tags, very little. So the ones that I put in, I used a syringe to put them into the fish. And so they're really small, but you could have this thing that I call a magic wand, and you could like scan a fish, and if it has a pit tag, it'll read out a number, and then you could go through your data and be like, oh, this is this fish. So the same thing that vets use for cats and dogs, like when they tag them, it's the same exact thing, so same exact technology. And so the reason I wanted to take them to Clover Creek was Abimatel has their pit tag array on Clover Creek. And so what we did was we released about half downstream of the array, and then we released half upstream of the array to see if they moved up and down during different flows and different temperatures. And so I really wanted to have that done, but I didn't get it done, and I'm sorry. But hopefully in the next month or two, I could have that available. So this is the Clark Drive on March 8th. This was another high flow event. And so this happened last year, and I'm assuming it's been happening every year for the last 30 or 40 years. And one of the locals were like, this happens all the time anytime it's flooding here. And so for whatever reason, the hitch are like, oh, let's just go up this little ditch, and then we'll spawn, and then we could get out later, but then they get trapped. And so we did a rescue last year, and it was pretty extensive. I don't remember the exact numbers. I feel like it was like 600 adult hitch that we got out of those ditches. And so we did the same this year. There's 94 adult hitch that we got out, and those ranged in size from right around 3 inches to like 15 inches. And the crazy part was, like, even those 3-inch fish, they were all ready to spawn. Most of them were juvenile-sized males, and they were milting. And so they were all ready to spawn, and I'm like, oh, you know, we don't know exactly why they're ready to spawn, and hopefully soon we're able to kind of figure that out. We pit tagged only 10 of them this time, but we took them to Highland Springs because they were all still trying to spawn. So if we put them back in the lake downstream, they were probably just going to do the same thing the next rainstorm. So I called Ben, and I was like, hey, this is what I want to do. What do you think? He's like, I think that's probably a good idea. And so we took them all to Highland Springs. Unfortunately, some do die in the process, and that day 3 of them did die. So this is one of those males, and you can see how big it is. That's my hand. So it wasn't that big, and it was milting. And there's been 2 years of that. Not with all of them, but quite a few. And even females. Last year there was a female about this big that was full of eggs, and was getting ready to deposit them. This is another Clark Drive rescue. So this one is the same ditch along Clark Drive. There's a lot that Alfred from Big Valley did. He was able to rescue thousands this year. But in this instance, it was the same pools where we rescued the adults in the prior rescue. I think it was 5 weeks prior to that. And there was all these fish, and we think they were hitch. I can't really say for sure, because I was like, if we handle these fish, we're gonna kill a bunch of them. Let's just take them downstream, and hopefully they make it. But in the adult rescue, all we saw were hitch and catfish. And so I was just like, well, these are definitely larval minnows. So I'm assuming those are hitch. And so those ones we just put back in Coal Creek, and hopefully they could make it on their own, because this was in April. So there's still water in there until late May. And so by that time, that ditch was just like full of grass. So it was really difficult to rescue any kind of larval or fry. And so I talked to Bree, from one of the wardens. I don't know if she's gone yet. But she's transferring out, unfortunately. And she's like, hey, what if we get a water truck and like dump the water, and then it flushes them out? And I was like, that's a great idea. Who do you know that knows how to do that? And so she suggested fire department in the county. She talked to the county. The county's like, yeah, we could absolutely do that. Someone from Public Works. I don't know exactly who it was. So that's what they did. They got one of those big water trucks, dumped all the water. My biologist, Chris, who's on vacation right now, and my tech, Joe, who had training all week, so he's not here. They said that they did see a bunch of the larval guys move downstream. And so hopefully that was enough to get most of those guys out of there. So this is one of those pools where we found those adults and those larval fishes. As you could see, if you could see in this culvert, there's like this little white thing. That's actually a bubbler that Alfred left overnight to give him a little bit more oxygen. And I was like, great move. So then we went back and got it out as many as possible. So here's a picture of where Clark Drive is. That's one of the pools we did, and then the release site for the larval rescue. Down here, this is the entrance to the state park. This is where the kiosk is. This is Coal Creek, and then Kelsey Creek is over here. So Scotts Creek rescues. We are able to go all over Scotts Creek and in many areas because we have access mostly in public land, but then we also have some private land access, and those landowners are just like, hey, there's a pool and there's a bunch of fish. And so this one, so do you guys know where Cow Mountain Recreation Area is? So this is a threadfin shad, and this was in the pool at Cow Mountain Recreation Area. And we have no idea what it was doing up there because it makes no sense that it was there. I worked with American shad on the Sacramento, American, and Feather Rivers, and I know they migrate to spawn. And I was just like, what are you doing here? But everything else was suckers. But there was one threadfin shad, and it was way up there. This is a massive rainbow trout, also from Scotts Creek, but way down below. If you guys know where Scotts Valley Road comes in at Highway 20, right next to that. So right next to the outlet of Blue Lakes. But during, not this rescue, but this rescue, there was also Sacramento pike minnow. So super exciting, another native minnow. So like I said, Middle Creek rescues, those are still in progress. There's a lot of pools that are disconnected, but if we don't have to rescue them, we won't. We'll just let them do their thing. I didn't put it in this presentation, I don't think. No. So last year in Scotts Creek, so 2023, summer 2023, late August, we're doing mapping, which is the next slide. We're doing habitat mapping of the creek, and the crew came back. They're like, hey, there's pools and they're full of fish. Should we do rescues? I'm like, yeah, let's check it out. So we went, and there was hitch, stickleback, mosquito fish, and Sacramento sucker in those creeks. Oh, and California roach. And so we did one rescue, and then I think it was like a Thursday. And so we're like, oh, let's check it out tomorrow. We came back. The pools were still good. We're like, well, let's check it out Monday. Monday comes around. My crew comes back. They call me. They're like, hey, the pool is like 8 inches higher. And I'm like, that's really weird. I don't know if you guys are telling the truth. I'm going to come out. And so I went out there, and sure enough, the pools were higher. So I'm like, oh, something weird is happening here. And so I just said, leave the pools alone. Let's see what happens over the next few weeks. So I think we monitored them. We started monitoring in late August, and they were intact with fluctuating depths, temperatures until November. And then once November hit, the creek started rising, and then late November hit, and the waters came. So those fish made it. And so I think also November, I don't remember if it was, Ben, when we did the hitch, the backpack for hitch on Scotts Creek, I think that was last year, October, November. So downstream, we found more pools with hitch in them. So there's probably a lot of pools that we don't know of that are on private property that are housing a bunch of native and non-native fishes. So I'll talk a little bit about our habitat mapping. And so this helps us with monitoring. If we're able to locate the pools, we could be like, okay, so when it comes time to rescue them, depending on when the creek goes dry, May, June, July, August, we could say, okay, this pool is here. That's where we're going to go back and do rescues, because hopefully at that point they're all congregating together. So in 2022, it was just me doing mapping by myself, and I did Middle Creek, Clover Creek, and Adobe Creek. 2023, last year, we did Copsey, Kelsey, Siegler, Lyons, Scotts. Oh, I put Lyons twice. And Robinson Creek. Oh, I also did Robinson in 2022. I should have put that. And so this year, we're going to do Middle and Scotts again, and then we're hoping to do Alley and Clover. If we have enough time, we'll go to different parts of the county, but I'm not sure because our CARP program is gonna be pretty extravagant this fall. 5 minutes, perfect. This is like some of our mapping. So if you could see here on the lower left, the blue is a pool, the purple's a riffle. I don't know if that's green or brown, but that's a run. The red is a barrier in the stream. The green is woody debris, and then yellow is gravel bar. And so this is Middle Creek right here, and this is Scotts Creek right here. And so this is one of those barriers. This is right next to Scotts Valley Road, next to Blue Lakes. Last year we were actually able to go in there and help the landowner out, and we got all this out. And so the rains came, and then a wood jam probably 5 times the size of this went under the bridge and landed just downstream of the guy's property. And his property was already scouring away. So we applied for a restoration grant to do some work there, and we got it. And hopefully in the next year or so, we're able to get in there and make the creek better for hitch. And then this, we saw a lot of stuff like this. Not a lot, like 3 or 4. And so we reported them every time to CalTIP and Cal OES. Not entirely sure what came of those instances. Actually, no. The water boards contacted me about this one, and it was gone, but that was just a hose. So a little bit about the seining project. So Habimatul provides funding for us to help them out on, it's catered to hitch. And so you just go out and seine it, and the hope is to get hitch big enough to be able to pit tag so it could support their pit tag project. And so right here, this is, that looks like Lucerne. Yeah, that's Lucerne Park. And that is also Lucerne Park. So these are a few of the hitch that we didn't pit tag because they weren't big enough. We got some fin clips and measurements. This is just us working up the fish right here on the left. This is us seining. This is at Keeling Park. So this is for their Habimatul study, so the catch per unit effort of those fishes that year. We got a lot of suckers. We got the next most caught fish were Clearlake hitch, and then unknown. So all the minnows look exactly alike. So when you catch them, you're just like, oh, I don't know what this is, especially when they're this small. You have to do microscope stuff. And then the next year, I should have compared them side by side. A lot of inland silversides. So this is this year. Way more inland silversides. Hitch were still second, but not as many. Some threadfin shad. These were all, I think, crappie, black crappie. And we started catching bass. This is the first time I saw bass in our seines. Oh, I think that's it. Yeah. Any questions?
We do have time for a few questions while we queue up the video. Okay, way in the back.
These are probably bad questions because I'm not a fish person, but this is how I learn. So the fish that you said were spawning, is it possible, does that have anything to do with just survival, like in really bad conditions, sometimes bacteria are just like going crazy, dividing because they have that survival instinct? Is there something like that maybe going on with the fish?
Are you talking about the adults that we rescued?
When you were showing the fish that were milting and carrying egg, but they were really, really small.
No, those were trying to spawn.
Right.
That was like straight, our instincts, we got to go spawn. Because the
Okay.
temperatures were great. But as far as, you're talking about the size?
Yeah.
That's a great question. And I hope we're able to answer it soon.
And also with the creeks coming back up, could it have been groundwater levels feeding the creeks, or is it more likely it was a surface source?
All of the above.
Okay.
Yeah.
You mentioned one rescue you ended up putting up Highland Springs, I'm assuming upstream of the dam. As you're doing rescues, going back to an earlier question, is it primarily going back in the lake where it's nom nom nom, or is there some type of strategy you guys are pursuing, possible targets of opportunity that you could have them shelter in place, say upstream of a dam like Highland Springs or Adobe? Has there been any internal dialogue in your world or the broader world about providing refuges of storage for these fish? Because I'm still stuck like California condor. I'm assuming you should be freezing fish and saving DNA and getting ready to invent them in a lab. But this low-tech thing sounds good to me too. So is there any value in finding little pockets of not refuge, that's probably not the right term, but just populations that might be better protected from whatever's going on in the lake?
Yeah, so these fish are very resilient, and they do have their natural mechanisms to protect themselves from predators. And so my team always looks for tules. And so I said, find tules, that's where you release them. And typically we don't release them right in the tules. We're off to the side a little bit to see if they go to the tules. And all life stages go right into the tules that we've noticed.
Hey, how about a round of applause for Luis? Thank you, Luis. Our next presenter, Jenna Rindy, was not able to make it. She's out sick, but being the trooper that she is, actually recorded this. And so Jenna, if you're watching online, turn off your computer and go to bed and get better. But we can go ahead and start that video.
I'm a senior environmental scientist supervisor of the California Department of Wildlife. Unfortunately, I am unable to attend in person due to COVID. However, thank you for listening to my presentation on in-stream flow methodologies to evaluate Clearlake Hitch passage in tributaries of the Clearlake watershed. To provide a brief background, Clearlake Hitch is listed under the California Endangered Species Act as a threatened species. Clearlake Hitch passage is a known concern in tributaries of the Clearlake watershed. In addition, Governor Newsom signed Executive Order N-5-23, which directs the California Department of Fish and Wildlife and State Water Resources Control Board to evaluate in-stream flow needs to protect Clearlake Hitch. Therefore, together with my team here at CDFW, we designed the fish passage study with the goal of characterizing stream flow and habitat relationships for Clearlake Hitch. Our objective is to develop hydraulic habitat models in the Clearlake watershed. Together, we'll collaborate with our government partners, which includes California Native American tribes, local, state, and federal entities. We're grateful for the Big Valley Band of Homo Indians Environmental Protection Agency, along with Flow West, who have developed a hydraulic habitat model on Adobe Creek. We've worked closely with them and additional government agencies to expand 2D model development in the Clearlake watershed. Together, to do this, we identified 6 creeks, which are Middle, Scotts, Manning, Adobe, Kelsey, and Coal Creeks. And again, for each of these models, we'll develop hydraulic habitat. For each of these creeks, we'll develop hydraulic habitat models. A hydraulic habitat model has various components. For simplicity, let's consider each component. I have some animations here, so hold on a second. Hydraulic relating to or referring to water moving in the stream, shown here in blue. Secondly, habitat, the environment the Clearlake Hitch live in. That's kind of shown here in this kind of brownish orange and green here to illustrate the vegetation. And lastly, the word model, which is an informative representation of a creek in the Clearlake watershed. Together, we input the hydraulic and habitat data into the model to simulate conditions. For example, we'll use a specific flow to predict depth and velocity. To develop this model, we use various tools to obtain the data. We have various methodologies, which at the beginning of April this year, my team and I have been out in the Clear Lake watershed collecting data. For the hydraulic component, we have collected discharge, water's edge, and validation measurements consisting of depth and velocity. For the habitat component, additionally, we've collected pebble count surveys and contracted with NV5 Geospatial to capture high resolution light detecting and ranging, or what we call LiDAR data. With all this data, we're working to build the model itself, which will use the U.S. Army Corps Hydraulic Engineering Center's River Analysis System, HECRAS. For each of these methodologies, we use standard operating procedures to ensure our data are legally defensible. Excuse me. I'm now going to dive a bit deeper into what each of these methodologies entails, with the first being discharge or stream flow is the volume of water that passes a specific point in a river or creek in our case per unit time. It's typically measured in cubic feet per second. We measure the width, the depth, and the velocity. What's great about the Clear Lake watershed is how many existing stream flow gauges are available and also in real time. We will use this stream flow gauge data. However, we collect additional discharge in locations at each creek when a gauge may not be present, or to confirm discharge measurements. To do this, here, let me get my laser pointer here. Almost there. Together with my team in the field, we collect the depth in a subsection, the width, and the velocity in each of these cells. Then we get a total discharge by the sum of each of these subsections to obtain a total discharge, excuse me. In the field, this is what it looks like. Our goal is to first find representative sites that are reasonably straight, uniform, and regular shape. Then we set up a tape measure across the creek to help get the width. A USGS top-sitting weighting rod is used to capture the depth. On the rod itself, a flow meter sensor is attached and connected to a handheld device to calculate the velocity. We typically measure across this creek at least 20 times, or 20 subsections, excuse me. Measurements and calculations are recorded both on the hard copy data sheets and on the handheld device while we're in the field. Then in our office, we will follow additional quality assurance guidelines. The discharge overall helps us simulate the model at known streamflow measurements. Other hydraulic data we collect are water's edge. To get the water's edge, we use a real-time kinematic global positioning system to capture precise locations along the stream, in this case, the edge of the water. Water's edge helps us calibrate the hydraulic habitat models when simulating known stream flow measurements. Additionally, we collect validation measurements consisting of depth and velocity. We use the same tools that we discussed already with the weighting rod, flow meter, and RTK. However, the validation measurements help us assess the predictive capability of a 2D hydraulic model. Next, we collect the additional habitat data to better understand the Clear Lake Hitch's environment. Woolman pebble count surveys are done to understand the grain size distribution at various representative sites. To do this, a gravelometer is used as pictured in the top right. In the pictures below, scientists from our team collected 100 randomized samples at each site. Overall, this information is to help estimate spatial stream bed roughness in our models. Next, we hired NV5 Geospatial to collect LiDAR data. LiDAR data is pretty remarkable technology to capture topographic or terrain data, along with bathymetric, the underwater data. Together, it gives us a high resolution with a goal to help us understand from the Clear Lake Hitch's perspective with the habitat they live in. Essentially, it's a laser attached to an aircraft in our case to help us understand the elevation. Additionally, aerial imagery was also collected, which is shown in the next slide. Here is an example of LiDAR data on Scotts Creek. On the left is an image we captured in the field. On the right is an image from the LiDAR data. Red indicates higher elevation, and the light green represents lower elevation, which makes sense here. By understanding the elevation data along with other data types, we can simulate stream flow at different conditions to predict depth and velocity in each of these habitats. We just got this LiDAR, and we are very excited to have it. So you can imagine we have a lot of data to process. Which leads me to our current steps, where we've collected 37 river miles of data. The image on the right illustrates how many data points we have collected over the last few months. I realize it's kind of hard to see, but what I'm trying to convey is that it's a lot of data. We have about 40 discharge measurements, over 1,000 water edge points, over 500 validation points, about 30 pebble count surveys completed, and over 50 river miles of LiDAR data. So as you can imagine, we are currently processing a lot of data. Throughout our data process, we're following our quality assurance plan, which entails various quality control checks to ensure the highest quality data. I mentioned it earlier, but all of our data collected and processed follows standard operating procedures. In terms of next steps, we'll collect additional survey data, continue following our quality assurance plan, perform the data analysis and calculations, and to develop and build our 2D models so we can run simulations to better understand stream flow and habitat relationships for the Clearlake Hitch. Together with all this information, we'll develop a technical report with our results. We'll continue collaborating, coordinating, and sharing the information we obtain. And to wrap up, I'd like to acknowledge my team and others in our agency within the Water Branch, Region 2 Office, Conservation Engineering, and Fisheries Branch. And thank you again to all of our government partners who worked closely with us, designing or being in the field for the study. Lastly, thank you for the Clearlake community for welcoming us and listening to my presentation today. I am saddened I cannot be in person, but please send any questions or email to myself or the InStream Flow program. Thank you again for your time. I really appreciate it. Best, Jenna. Hello, my name is Jenna Wendy.
Yes, and unfortunately, Jen is not here to answer any questions, but we will call up our next speaker, Anthony Falzone, and maybe during the panel discussion, we might be able to talk some more about 2D hydrodynamic modeling if those questions come up.
Yeah, and if there are any questions, I can try and answer them on her behalf. All right. Almost good evening. You all have made it till almost after 5 o'clock on a Friday afternoon. So thank you very much. You all are troopers. And my name is Anthony Falzone. I'm one of the founders of Flow West. We're a civil engineering and science and data science firm, planning. I'm a geomorphologist, and I'm going to talk about Kelsey Creek and the fish passage barrier at the Main Street Bridge. Just to give you a little overview of the presentation, give you a brief background on Kelsey Creek. I'll go over that really quickly because we've gone over, other people have done a great job of talking about Kelsey Creek. Give you some project background, talk about the alternatives that we developed, and then the design that we advanced, and where we stand in permitting, next steps, and then to thank our project partners and acknowledge our funders. It's been a group effort. Originally, this project was started under the Elam tribe and is now being run by the we're working through the Big Valley. And just to give you an idea of what you're looking at here, that is the Main Street Bridge just outside of Kelseyville. You see the fish passage structure on the right side of the channel, and you can see where the white water is. That is the existing grade control structure that keeps the Kelseyville Bridge from collapsing from the channel being incised. Oh, I guess I can advance it. Sorry, that was the intro slide, missed that. All right, so Kelsey Creek Watershed, it's the third largest tributary to Clearlake. The watershed upstream of the Main Street Bridge is about 42 square miles. It's one of the few remaining Clear Lakes tributaries that still has a large population of hitch, and it flows down from Cobb Mountain. I am not going to talk too much about the hitch and their population decline over the last few years, because you've heard lots of other great presentations today and yesterday about this. But needless to say, their population is still not great, and they're still in trouble and need help. Kelsey Creek, I want to talk a little bit about the land use impacts. It's been severely impacted by gravel mining. There's been about 15 feet of incision in the channel around the area of the Kelseyville. There are also reduced in-stream flows from diversions and pumping. There's decreased water quality from runoff, and there's significant reduction in habitat from lack of access to the upper watershed, and also reduction in the amount of nearshore marshes, and also predatory animals in the lake that feed off of them. So they have a bunch of adversity to overcome. Whoops, that's going backwards. Here we go. A little bit about hydrology and a little bit about the competition for resources here. In the graph, we've got a typical wet year and dry year hydrograph, and you can see that the irrigation period and frost protection, wine grape and pear irrigation there. And you can see that when the hitch spawn, and that there's the potential for conflict over resources. And as we move into a period of longer droughts and more frequent droughts, water availability will continue to be an issue for the hitch. A little bit about the Main Street Bridge and the grade control structure. The bridge was built in 1947. The grade control structure was built across the channel to control incision and keep the bridge piers from being undermined. There is a bit of, even with the extension of the bridge piers, they are still continuing to be undermined. Let's see, the grade control structure is about 50 feet wide. It consists of grouted rock. There's about a 5-foot drop. There's an apron that extends out. I believe in the 90s, it's not well documented when the fish passage structure was built. Actually, I'll talk about that on the next slide, but I talked a lot about incision, and even now there's still about a 6-foot deep scour hole downstream of the grade control structure and the fish passage structure, and that's continuing to cause, it's undermining both of those structures. A little bit more about the fish passage structure. It's made out of concrete. Like I said, I believe it was built in the 90s, maybe late 80s. If anybody in the audience knows more about when that structure was put in and by who, I'd love to hear more about it. My understanding is it might have been like a local club or group of people who put it in, but there's not very much information known about it. What we do know is that it doesn't pass fish right now. It's currently being undermined. There are holes in it. It's very porous, meaning the water pours out of it. It doesn't function the way they initially developed it. It's about 3 feet of incision at the downstream extent, and it is definitely a passage barrier for the hitch. If we remove this barrier, it provides access of I think it's like 6 to 7 miles of additional access for habitat upstream. This is one of the primary barriers in the watershed, and I give a huge shout out to Ben and the work that he's done with his crew to help on the downstream barrier and make that more passable for fish. So this is the next big one to take care of. The project objectives and components, so objectives are really simple. It's to improve passage for the hitch and other native species. It will include demolition and removal of the existing fish passage ladder and the grade control structure. We plan for construction of a series of step pools that will allow the hitch to move up. And it will also provide scour protection for the Main Street Bridge. I want to go through a little bit about some of the design constraints and some of the criteria that we used when we first started looking at this. You know, the bridge is considered historical. It was seismically retrofitted. There is the grade control structure that was built in front of it. You know, flood conveyance is not a major issue here. It is, of course, a major concern with the adjacent residential and commercial properties in downtown Kelseyville being really close by. Some of the interesting components of the hitch is they rarely jump. You know, we're really focused on salmon and providing passage for them, and they're great jumpers. So the hitch is a little bit of a different species, and you know, it definitely requires a different approach. They also appreciate attraction flows so that they know where to go, and that's another challenge at the Main Street Bridge right now. Some of our original criteria was we wanted to keep slope below 3%. We had passage flows, doing some general hydrology analysis. We came up to 15 to 200 CFS. We want to keep the velocities below 5 CFS, 5 feet per second. And we want to have at least half a foot depth, and talk a little bit about the alternatives that we came up with when we first started looking at this structure back in about 2015. We came up with 4 different alternatives. One was to enlarge the existing structure. Another one was to separate a high flow and a low flow channel, and then have a meandering single or multi-stage channel. Also, we looked at a rough and ramp design. That's more to simulate a natural channel bed. We came up with the advantages and disadvantages of all of these, and we decided that the best solution was a rough and ramp multi-stage channel with no steps, and we came up with a conceptual design and then left it to do additional analysis. So some of the key components of this initial design are that it has a low flow channel that's about 8 feet wide and 1 foot deep. It does have slope that's less than 3%. We did a lot of analysis of what would be the ideal slope to maximize or to optimize passage and minimize the footprint of the project. And then we proposed placing large boulders upstream to prevent debris from clogging the low flow channel. We obtained additional funding and continued working on the project, and the idea was to advance the design. And so we started our next step of engineering work on this. We went back and looked at the hydrology and revised the hydrology substantially. We increased the minimum flow up to 25 CFS and the high flow up to 526 CFS. And let's see, what are the other important, the major finding from our additional analysis of our proposed design was that it wouldn't be stable and that it would incise, and that the natural bed, we were unable to maintain that with the high velocities and shear stresses that occur at the site. Although the channel is relatively wide upstream and downstream, it really narrows down right at the bridge, and so you get a concentration of shear stresses through there that make it difficult to maintain a natural channel bed without some sort of structure to hold it together. So we came up with a step pool design that has grouted boulder veins that go across the channel, and then a series of pools. There is a cross vein every other pool, and that provides structure to provide the grade control. just another view of the same design. The gray area is what we call engineered stream bed material, and it's just a specified mixture of sediments that we believe will be stable in that location, and it's packed in place. It looks natural, but you fill it in with the coarser material, and then you put the fines on top of it and wash them in with water so that the material stays in there and it's packed together. It just another way to try and keep this area from unraveling. We see protecting the bridge as a key component, and so our design there is a fair amount of structure in the channel, but it does more mimic more of a natural channel with the step pool. Just a little bit more of the detail of some of the rock cross veins and the low flow channel that's in the center. We stuck with the 8-foot wide, 1-foot deep channel that we had in our original design, and you can see that our steps, there's about a 1/2 foot jump or step between the pool at the top of the water surface elevation there, and the pools typically are about 2 feet deep from the crest down to the bottom. Let's see, using the hydraulic model was really important for our design. The previous presentation did a great job of explaining what a hydraulic model is. We used what's considered a coupled or nested hydraulic model, where we used 1D HEC-RAS on the upstream and downstream area just to give us water surface elevations, and then we used a 2D model within the actual study site so that we could really see detail how the fish passage structure would perform. And we looked at velocities, inundation extents, depths, and we looked at various different flows. I'm going to show 2 flows just to show you an example of our results. And first of all, we're going to look at depths and velocities through the structure at 2 different design flows, and then we're going to look at the 100-year flow to see what the flood conveyance looks like during the flood of record, or not of record, but what's considered the design flood. All right, so low passage flow, 25 CFS, the structure performs great. We meet our criteria for depth and velocity at 25 CFS. Water is confined mostly to the series of step pools or the low flow channel. When we bump up the discharge to 526 CFS, we still meet the criteria for depth, but our velocity in the main, in the low flow channels exceeds our threshold. But there is a lot of area where velocities are lower out on the fringes, and we feel that the fish can still make it up there. They will likely come up in steps and hold and then move up. So it's a challenging site to work with, and there are some additional modifications and tweaks that we'll continue to explore to refine the design. Flood conveyance, so it is important for people. If you put this new structure in there, how's it going to change the flood risk? In this particular area, because of the incision from gravel mining, there is a lot of excess flood capacity. And the brown lines across the top, those are the 2 banks, the right and left bank, the elevations. And then the 2 blue lines are the existing 100-year discharge going through the structure or going through the site. And then the darker blue line is the proposed discharge. And so you can see there's a little bit of a increase in water surface elevation right at the structure. It's a few feet, but there's plenty of capacity here at the 100-year discharge. And you can see that these lines, the blue lines, are very similar upstream and downstream, so there's virtually no increase in the water surface elevation in the upstream and downstream, and you get a little bit of a of an increase as you go through the new structure. Sorry, thank you. I wanted to provide an update on the permitting status of the project. We've been working through the design. We have a CEQA MND application pack, or mitigated negative declaration package, ready to go. We're waiting for landowner approval before the county, who is the lead agency for CEQA, can approve it and submit it. We have a package ready for the 401 water quality certification. We also have our CDFW lake and stream bed alteration agreement application ready to go. And there's a Lake County grading permit we have that package set up as well. Lastly, the 404 wetland project application is ready as well. We did a few specialized surveys associated with this project. There's the rare plant survey, cultural resources, and aquatic resource delineation. So we have, with our existing design, we have a fair amount of environmental analysis that is really pretty close to finalized. And if there are modifications to our structure, we're looking to reduce the length of the footprint. And so we think that even if there is a revision that reduces the footprint, that we won't have to reduce CEQA because we'll be making it smaller, not bigger. Next steps, we want to continue working with Lake County and CDFW to obtain landowner access to do the project, to implement it. And we are currently working with CDFW to optimize the design and minimize the footprint. One thing that we're looking at is enhancements to the piers on the Main Street Bridge to see if we can either remove or reduce the elevation needed for the grade control structure. That would reduce the number of steps that we need. So that's very exciting. And last step is, of course, to secure all the construction funding. We've made good progress on that, so I'll explain here. I want to thank all of our project partners and the funding that various different agencies have provided. CDFW is helping with the fish passage design review, and they're funding the current design process. Lake County, they are the CEQA lead, and they're taking the lead on landowner access. U.S. Fish and Wildlife Service, through the Tribal Wildlife Grant programs, they funded the alternative development and the design development. And then CNRA, through the Blue Ribbon Committee for construction funding, and also Caltrans as mitigation for the 3 bridges projects. There's mitigation funding that will be put towards this project to construct it. And with that, I can answer any questions. You can reach out to me, and also Sarah Ryan, who I believe is still here. You can ask her about it. There are many people who have been working on this project. Thank you, everybody, for your continued support and help.
Any questions for Anthony?
I think that this is more of a question for you because you're CDFW, but I'm just wondering, since it does have the fish in the creek, are you doing a 2081 incidental take permit for this as well?
So actually, I'm not in our permitting department. I'm a fish biologist by trade, but I am the person that will grab our permitting folks and drag them to the table when the time comes. But of course, seeing DFW being involved, we're going to follow our own rules. So yes.
So that's a good question. We were discussing that recently, and since I've been working on this project from 2015, seen a lot of drought during that period, and have always been working under the assumption that there's probably not that much need for take or incidental take permit because the creek will be dry, where in most of those years the creek has been dried. But in wet years there is water year-round in the creek, and so if construction does occur in a wet year, we will need to do some sort of flow bypass and probably do a incidental take permit, but that remains to be seen. I guess this might be the only time that you actually hope that you have a dry year. Yes?
One question back there. I'm wondering about the rare plant survey. Do you know offhand if you found any rare plants in the Kelsey Creek?
I believe in this area we did not find anything that was rare in terms of the vegetation types, but I do not. That's just my recollection.
The reason I ask is because there's a semaphore grass, and the original site of it was found in Kelsey Creek, and it hasn't been seen, as far as I can tell, since it was found, which was many, many decades ago. And botanists would love to have a sample of it again.
As far as I know, we didn't find any, but I'll ask our permitting lead to review the vegetation report.
We'll have one more question and then ask our speakers to come up for a brief panel discussion.
Thanks, Anthony. Just a quick question. Once you do have landowner approval and secure all the necessary permits and everything that you need to do, how long do you anticipate this project taking? And if it is feasible to maybe do when the water's out of the creek to minimize impacts to the hitch?
Great question. So I think if in an ideal world, if everything fell into place really quickly, and probably the most challenging part is the landowner access, we could, and I think we could go to construction as soon as next year. That would be in an ideal world, and a lot of pieces would have to come together. But it also depends on what we see from our design review with CDFW. If we do decide to integrate modification of the bridge into the project, that would probably extend the design period by another year. So you'd be looking at 2026. But I think, assuming the landowner issues are worked out, we're pretty close to move it forward. And once we have designs that are developed, it'd be easy to pull together the specifications and the bid documents and get a contractor going pretty quickly. We do have a construction window, which is late summer, so it's not going to make it this year, obviously. Best case scenario would be late summer next year, and if not that, hopefully the following year.
Thank you, Anthony.
Thank you all.
So I'm going to ask our speakers to just come up to the front. We do have about 15 minutes for a brief panel discussion. If folks have any specific questions that weren't addressed, please come up to the front and ask them in the microphone. And if there are no questions, then I'm going to lob questions at them off the top of my head. And we did lose Luis. He had something he had to take care of, and of course Jenna was unable to make it, so it's a bit of a smaller panel than we were hoping for, but we're happy to take any questions if anybody wants to kick things off.
I've got a question.
And I'm really good at addressing elephants in the room. So, Ben, here goes. Why the hell don't we just kill the bass? Why do they have to go back in the lake? I don't get it. Thanks.
That's a big question. It's been asked more than once to me. That's at a higher level. First things first, I think the feasibility of actually removing all the bass out of the lake would be pretty big feat to try to accomplish. Okay, so that's That's a difference. So under tournaments, that would have to go through a Fish and Game Commission, like I believe like a rule to be able to overturn that, because that's actually a sport. Those are sport fish tournaments. Those aren't catch and keep tournaments. In order to have those tournaments, it's a catch and release fishery. It was brought up, a person from the public came up to me earlier and asked the same question about why don't these guys, bass fishing is generally a catch and release fishery. Those guys have the option to actually keep fish on their own on non-tournament days. If they want to keep, they're allowed to keep 5 fish over 12 inches in Clearlake. But the bass angling community is really, as probably most of you guys know, is a very catch and release oriented. To have a tournament, they're not going to probably want to kill their resources and pay to go kill their resources. I mean, these guys are going out catching the biggest bags that they can and releasing them back so they can try to catch them again and have future opportunities to catch these sport fish. There is a probably opportunity to have that option, but I definitely don't see it ever happening because the anglers aren't going to be participating in that. They're all about, they get angry at people that just go out there and catch fish, catch bass, and take them home, even though it's perfectly legal. They're not wasting them. But the catch and release is huge in the bass community. So that's why I don't see that ever happening. I mean, they're not going to probably enter tournaments to kill their own sport fishery. You know, I don't see that ever happening. Again, especially if they have the opportunity on their own time, especially a lot of them pre-fish, they're completely legal if they want to keep and catch fish, but none of them, I mean, I'm not going to say none of them, but most of them, unless they maybe deep hook and like wound them, they're going to release those fish so they can try to catch them at, you know, they get bigger and catch them at a later date.
Okay, one other question. Oh, if I could add about bass fishing, we don't fully understand the impacts of the bass fishery. So before taking a step like that, at least in my mind, I'd want to have more information, some diet studies, and really see what the impact is. We have a better understanding of carp, and in that would be the carp management has multiple benefits, whereas eradicating a population of bass just straight through tournaments, again, may not have an effect on the bass population, and we're unsure if it would have an effect on the hitch-based population, whereas the relationship between the presence of carp is more clear.
Yep. No, totally got that. Yeah, just.
Can I jump on the bass thing?
And I have one other follow-up question because I want to know who gets to run the tournaments. Can anyone run a sports tournament?
You can file a permit and hold a tournament. Yes.
Okay, so I could conceivably hold a bass tournament, and it wouldn't be catch and release. I could do that.
No, it has to be catch and release. They're not catch and keep, not for bass tournaments. That's one of the stipulations.
And that's back to the commission ruling.
Yeah, it's in our code.
Okay.
Yeah,
thanks.
yeah. The tournaments offer big fish, big fish awards, but again, it goes back to they have to release the fish. But yes, there's big fish and then total bag limit. 25 pounds, 30 pounds for a 5-fish bag limit is pretty good at Clearlake, and regularly you see 10 to 12 pound bass caught.
Yeah. So just to follow up and moderate. Okay, let me moderate first. So I appreciate the passion. I was there a year ago. I got to slow my own roll, and I'm the policy guy. So I do want to state we do understand and appreciate how central sport fishing is to Lake County's economy. That said, somewhere between extermination by terminate, what type of outreach and education, though? Because I know that they would not intuitively want to catch and release, but how much education is there available? I do think there is an opportunity, because I do take opportunities myself to talk to sports fishermen. They probably feel like they're good stewards of the fishery in doing the catch and release, but if they were educated about the special case that Clearlake is, by far one of the most prominent bass fisheries in the country, if it's under environmental stress, It's not just about the hitch at that point, it is about the bass and other sport fish. So is there any middle ground, any bridge building that can occur to at least start those conversations before we even start pitching things to Fish and Game Commission? You know, is it just a bridge too far that bass fishing is bass fishing what it is all across the country and we can't touch that third rail? Or is there some bridges that we can either start to build locally or through our partner agencies like CDFW to start that dialogue? Because I do think through these various talks there are many extremes of opinions. My own opinions have not been well informed, but what can we do to better inform my opinions as a policymaker and to start bridging the gap with our sport fishing friends? They're friends.
I was going to let Matt speak because if you want to speak on this subject or talk about what you were going to speak about earlier.
I'll skip kind of what I was going to say earlier, but I think that it gets to some of what Felipe just mentioned, in that there are, in any scenario, there are often unintended consequences, right? So when you talk about biocontrol that has ramifications beyond immediate known responses, I think that one of the things that's increasingly clear from certainly the surveys that we do, USGS does, and some of the work that everyone else is doing, CDFW, tribal partners, showing that there are broader issues in the lake that are affecting all of the species. So we see booms and busts in hitch recruitment and recruitment success. There's similar evidence for booms and busts in recruitment success for bass and for other species that have we'll say other interested parties. And so I think that's the common ground, right? There's this clear signal that the ecosystem is not functioning for many of the constituents that we care about, both the native fishes that have massive cultural and local significance and intrinsic biological significance, and then also for sport fishing elements. The ecosystem is not working for either currently.
Well said, Matt. Any other questions from the audience? Sarah, come on up.
Well, my earlier question was answered by 4 separate panels, so thank you for that very elaborate answer. Bass fishermen, I understand the numbers are going down. If you wait 25 years, they'll probably age out. And then a wild question, why not just replace the bridge with a suspension bridge?
I don't think there are any engineers up here that could speak to the feasibility of a suspension bridge, but we do appreciate creative solutions.
Hello. I had a question about water quality and fish. And given the fact there's some data on, or some studies on cyanotoxins impacting the health of wildlife and waterfowl and fish, just wondering, is CDFW or anybody working on looking at that? I mean, we know there's cyanotoxins in the tissue of fish. We have study of multiple fish over the years, and we've got some more data that continues to show there's cyanotoxins in the fish itself, multiple species, fish and shellfish. So given the fact that the species seem to be declining in the lake, I mean, I think it seems to me like it would be worth looking at, really the state of California coming up with a number. There is a fish consumption number that the state has come up with of 10 nanograms per gram for sports fish consumption, but in terms of the actual health of the fish, it seems like it would be worth spending some time on that. I know that CDFW now has a HABS coordinator, which is fantastic, and so I hope that Karen and her Department of One will be able to continue to work on that. But just wanted to see if there's any comments you had about that information. Thanks.
Yeah, and I will speak for our HABS coordinator that she has expressed interest in starting a study. Unfortunately, it hasn't gone beyond the kind of spitballing stage, the initial conversations. It is an unknown. I did kind of a cursory literature search on impacts to cyprinids specifically. They seem to be pretty resilient, but again, we don't know specifics for Clearlake hitch. it would require, a study for us to make an informed decision. But I think we know that HABs are a problem. And I don't think we need more motivation to seek solutions for that. I think better understanding how microcystins and other toxins affect hitch would be informative, but I don't think we need to wait for that study. And I know you do a lot of great work in the microcystis monitoring, and it is a problem that we do need to address with the Clearlake. And the water quality within the lake is a massive issue as far as dissolved oxygen and harmful algal blooms. So absent any studies, I think there's impacts that we do need to address. And again, this speaks to the ecological function, bringing some balance back to the food web and the nutrient cycling to really reduce the harmful algal blooms and thereby benefit all the species in the lake and the people that use the lake.
And I think an important, that touches on something that's related and expansive. I mean, there are many things tied to water quality that lead to sublethal effects. It's really easy to see a dramatic fish kill due to low dissolved oxygen, and that's a very strong, immediate, lethal impact. There are sublethal effects from things like cyanotoxins or potentially mercury or moderate dissolved oxygen that could potentially impair some elements of movement and behavior, but wouldn't necessarily result in death, right? And so understanding more broadly how the different sublethal effects contribute to either reproductive success or some other element of distribution would be really valuable.
Regarding the question of catch and release versus catch and keep, if you were to keep the bass, you would also be lowering the mercury level. As we learned yesterday, the bass have one of the highest contents of that. I also want to ask a question about that I didn't get to ask yesterday, maybe you guys know, is regarding the mercury levels in plants, in any of the water plants or even the marsh plants like carex and even the tules themselves. Do you know if they capture the mercury so that you might be able to harvest when the wetlands are dry and be harvesting and removing the mercury in that fashion also?
I like going out on limbs, so I'll attempt to answer that, but just bearing in mind that I'm not a plant biologist and toxicology isn't my strong suit. But I do recall some conversations early on in my involvement with the former water manager from Robinson Rancheria, Corolla Kennedy, and her expressing concerns on native plants that are used for basket weaving. And she was really concerned with the basket weavers being exposed to mercury through native plant pathways. Again, I'm not an expert on this. This is just kind of secondhand information that I've had through conversations, but it does warrant further investigations, really understanding how mercury is traveling through the food web, and then also the sublethal effects, like I mentioned during my talk, how they're additive. So while mercury may not be directly lethal, methyl mercury may not be directly lethal in the levels that we're seeing in the fish, it definitely does have some consequences as far as reproductive success and reducing their overall success.
This is a question for Ben. That Manning fish ladder that you guys put in looked really great, but I noticed from the pictures, is that a crossing, like vehicles can actually drive through the water?
There was two of them I did, but both of them were used for agricultural crossings, though. Both of those Manning examples they used them for tractors, but those weren't both those crossings weren't got heavy public usage. They were on private property and they used them as tractors. The Kendall Jackson one used to mow their field for fire control, and then the other one was, I think, just to access their vineyard.
Okay. Yeah, I was just curious about any more of those. in-stream vehicle crossings like that, and if there are any sort of parameters around like spawning season restrictions?
Well, I think both those examples were put in a long time ago. I couldn't tell you like when those crossings were put in, but I'm sure those aren't the only two in the Clear Lake watershed. So again, that's why I was saying like out of their good hearts, because really they didn't have to let us know. If you guys know or you come across any of these historic barriers, and we're willing to work with these landowners. I think a lot of them are intimidated about letting us know they have a possible barrier, but we try to work with them, work through the permit process, and you know, so you know, we try to make it as easy for them, because otherwise we really don't have the power to be able to just go in there and just do it ourselves. You know, they let us know, gave us access to come in and do our work.
I will also add that Bureau of Land Management has put in place a wet weather closure for Cow Mountain. I know it's a really popular off-roading area, and they are taking some actions, are looking into redesigning the entry so that folks cannot drive across Scotts Creek right there at the entrance to Cow Mountain, and do in fact close the area when it's wet, when water's flowing through there. And actually we got some panicked emails this spring because of fencing going up in that area, and people were concerned that it would be a barrier for hitch, but it turned out to be Bureau of Land Management putting up fencing to prevent off-road vehicles from entering that area. So these are small steps in the right direction, but we do want to look for other opportunities like this. And you know, if we know private landowners that have these, again, this is my crowdsourcing, I rely on the community, that if we do know barriers like this, road crossings, problem areas, let us know, like contact us, tell Sarah, tell me, tell Ben, and we'll see what we can do. We have a lot of tools in our toolbox, and we're adding to that toolbox constantly.
Captive audience, can you speak to the public trust doctrine? People don't know a lot about it. It's in the Fish and Game Code, but it's kind of interesting, because you're right, private property owners might go, ooh, there's something scary in my stream. If I tell anybody about it, I'm going to get dinged. But then we have a large structure like the Main Street Bridge where we have clear blockages, but we need landowner approval basically to get the public trust doctrine to be enforced. Sonoma County is a very interesting example, because they have I forget what they call it, but a public trust resource map that they had to develop at the far end of a lawsuit or two. But I'm just wondering, how do you, one, can you explain what the public trust doctrine is that is in the Fish and Game Code? And then how do we as policymakers try to educate / enforce that as we are navigating these various blockages and things in our waterways? And if you are familiar with the Sonoma County model, has any usefulness come out of that public resource mapping?
The short answer is it's complicated. And like I said, it's a complicated regulatory landscape that we exist in, and I know you're well aware of that. I'm not in a position where I could speak a lot about the public trust doctrine, other than you know, we have a lot of good faith actors that are working on Clear Lake Hitch conservation, and I think I have to just leave it at that.
I'm not an attorney, but we did have somebody look into that, and there are other avenues that are preferred to take before you use that, and I think that is reserved for more, you want to be careful when you pull that one out.
Chris, we'll give you the last word.
I'm the last. Good evening, gentlemen. I appreciate all of the hard work that you guys all put into this science symposium and all your daily jobs. Please, thank you very much for all of that. I have a question. I know that sometimes probably you guys come across some red tape or, you know, barriers or something like, if I could just legally do this, you know, what would that look like for you guys if the Clear Lake Hitch was federally listed as an endangered species? What would it look like for you in a positive manner that could help you complete your job or get past that one little step, or maybe more funding to expand, what would be something that each of you could gain from the Clearlake hitch being federally listed? If you don't mind starting with Anthony.
So I think one thing, and this has been somewhat alleviated with the state, has been they've had a lot more funding recently, and there has been more funding that's come to the hitch. But in general, if there are a lot of funding programs that are limited to endangered species, and so having an endangered species, having the hitch listed would increase the availability of funding, or would make it more competitive on funding opportunities that are highly salmon focused.
Yeah, like Anthony said, I think there's probably some more funding issues, or some funding opportunities, I should say. I think some concerns that I'm speaking for myself and just working with Lake County residents, and just doing the barrier work that we've done on private properties. I hope it doesn't scare people from working with us, or if they find hitch, that there might be more reluctant to try to working with us and open us because of maybe more restrictions that they might be afraid of, whether valid or not. I do think, from what I've seen, especially in the last, how much it's ramped up in the last 2 to 3 years with how much work is being done to help this fish, how much monitoring and actually on the ground work to actually try to get this fish back on its feet is really phenomenal. I mean, I follow the Fish and Game Commissions just to keep an eye on what's going around the state on various other species, and obviously I'm biased for the hitch, but the amount of work and time that this community is doing is just is really good. I have to be careful what I say too, because I think anything to help protect the hitch is good, but also I also think there could be there might be too much in the sense that it might scare away a lot of people that want to help the fish, but might be more reluctant to open up and let us know, hey, we see hitch in our creek right here. Even though, once we go in and try to do the work, I mean, the people that we've worked with to do the barrier removal on the private property, I can't speak for them now, they're not in here, but if I were to guess, I think they would say that working with CDFW and the tribes, because the tribes have come out on some of the property to give their take on it, I think I would put money that they had a good positive relationship with us. They were glad to work with us through the process, and I want to keep that going, because I think that's what we got to keep the community. We're all in this together and trying to work together, and that it's not just some iron fist we're trying to get on properties and we're going to tell you all these permits and fees. I think in order to get further towards our goals, we got to keep working with these people. And but I'm hesitant because I'm not going to speak for the feds and stuff. But just my concern is that there is a lot of good work doing done. I don't know how much, but like Anthony touched on, I think there's going to be more funding opportunities. I just hope the public continues, because I think we're heading in the right direction. When we worked with Kendall Jackson, they were trying to work with the other private landowners out there too, to let them know. I said, hey, if you could just let them know, don't have them be afraid of us. If they see hitch on their property, if there's barriers, to keep spreading the word. So I want to keep that going, because I think we're headed in the right direction on that.
Can I give you a quick, easy answer and then a naive, optimistic answer? Funding, right? I mean, so we are at the U.S. Geological Survey. We're also in the Department of Interior, so we're a sister agency to Fish and Wildlife. And so that we work closely with them for informing their listing decisions and all of the critical habitat designations that might follow, those sorts of things. I think that in the scenario you laid out, the regulatory framework gets that much more complicated for everybody, as more agencies have direct fingers in the pie. It's a terrible metaphor, sorry. But I think that there's, as Ben was talking about, and as Felipe has exemplified with the task force. So hopefully there's this framework where there's local entities working in partnership with the regulatory agencies, and everybody will have a fairly good stake at the table, and it'll move forward fairly smoothly. And I naively think that the structure is in place for that to happen. I'm crossing all my fingers, but we'll see.
Yeah, and I guess I have to preface this with, like, my goal is delisting. Like, that is literally my job function, is to get species to a point where we can delist them. What positives, to speak directly to your question, obviously resources and staff. Matt also touched on, and Ben also touched on, that there would be an increased layer of regulation that we do need to consider. However, within the task force, we do have Fish and Wildlife Services, an active member. They're at the meetings, they're working with us, they've been good partners. So I am optimistic that we can put together like a structure. You know, the task force was originally formed as an emergency response, and my goal in the next year or so is to build the infrastructure so that if I get struck by lightning or abducted by aliens or whatever, that it can keep going with making the great progress that we've been making. I think the partnerships that we forged and the relationship that we forged with your leadership, with Sarah's leadership, have been really beneficial. So optimistically, if they do get federally listed, the service would continue to be good partners. We have those open lines of communication, and that we'd be able to navigate any additional regulatory layers with their help. But again, can't speak for the feds. I'm a state agency. Ultimately, my goal is to get these fish delisted to a point where they no longer need our protections. Lofty goal, but that's what I'm working towards, and I think we're making some great steps in that direction. Right. I want to thank everybody who stuck around, and I know Angela De Palma's not here, but watching her run around with the microphone, I hope she gets a good nap after this. I want to thank our panelists, Robinson Rancheria for hosting us, and hope to see you all at Sopa Reese tonight. One more thing. So doors open at 6. We'll see you there soon. Thank you all.